on social media, use that hashtag #PerfNow. This is also how we are going to accept questions. So use that hashtag #PerfNow on Twitter and Mastodon, or whatever you call it now. And also you can go to perfnow.nl/Q&A. Is that on there too? Yep, /QA. That's another way you can submit questions. And also if you're watching the live stream, there is a way to submit questions there. And we'll be happy to get those answered. All right, so it's time for our first speaker, Matt Hobbs. He is the former head of front-end development for the UK's government digital service. He's done some phenomenal work. He led a team of 30 people there, where he did some great work around performance and equity. And so I'm really excited about this presentation to learn more about bridging that digital divide. And everyone welcome Matt Hobbs.
Can you hear me? Hear me at the back? Perfect. Morning, everyone. It's an honor to be here as the first speaker on the second day of this amazing web performance conference. I'd like to thank the PerfNow team for inviting me to speak. I feel extremely privileged to be on this stage with such incredible speakers from the web performance community. My name is Matt Hobbs, and until recently, I was the head of front-end at the UK's government digital service. Today, I'm delighted to speak to you about the topic of bridging the digital divide using web performance, with a specific focus on the United Kingdom. In an increasingly connected world, it is crucial to ensure that everyone has equal access to digital resources and opportunities. In this presentation, we will explore how optimizing web performance can play a significant role in bridging the digital divide. Note the background image of this slide. I took a leaf out of Mark's book yesterday and generated it using Midjourney last night. So anyway, let's get started. First, let's understand what is the digital divide. The UK, like many other developed countries, is experiencing an aging population. This is increasing due to longer life expectancy and lower mortality rates in older generations. A person born in the past 20 years will have been exposed to the internet, mobile phones, and tablets with connectivity with the whole world from a very early age. Their brain knows nothing more and nothing different than looking up any question they have on a digital device. Having two young sons, I've been witness to this over the past few years, as they are both very fluent with technology. The digital divide is the gap between those who've been privileged enough to be exposed to technology and those who haven't. Although I alluded to it in my previous slide, it's an oversimplification to say it's only a young versus old demographic issue, although it's an easy assumption to make. A major misconception that people believe when talking about the digital divide is that there's only one, when in fact a simple division between two clear social categories doesn't exist. We live in complex, multifaceted societies. A more accurate way to examine the digital divide is across entire populations, including people's social, economic, and cultural differences. There are many reasons why an individual won't have been exposed to the technology. For example, they come from a family with less disposable income to spend on luxuries like mobile phones, tablets, and computers. They live in a part of the country with poor connectivity or an underfunded education system. They simply haven't had the opportunity to use technology. Maybe they've had no one to show them how to use it. Or a common occurrence is getting someone else to do it all for them, e.g. a family member or friend. Maybe they don't understand the benefit that technology can bring, or a combination of above. There are many people in society that are scared of change, and technology is a huge change. You'll often hear comments like, "I've always done it this way, why change now?" Or "Technology is going to take my job." So why is it important to reduce the digital divide? Reducing the digital divide is essential to create a more fair and inclusive society where everyone has equal access to information and opportunities and tools to thrive in the digital era. A more fair and inclusive society will enable individuals and communities to take part in social, economic, and civic life and foster development and progress for all. In turn, this improves social inclusion and access to information and knowledge, leading to better economic opportunities, education, and skills development. Bridging the global knowledge gap will create a more inclusive and interconnected global community for everyone. So we know the digital divide is detrimental to society and is something that we should be aiming to reduce. But how can web performance help do this? Web performance is a crucial factor in bridging the digital divide, especially for users accessing the internet across a large range and speeds of devices. For example, across a whole country's population. So let's look at a few web performance topics individually. Number one, optimized and efficient web design. If websites and applications are well optimized to load quickly and function smoothly, they can be more accessible to people with slower internet connections and less advanced hardware. This includes practices like efficient use of code, optimizing images and video, and prioritizing the loading of critical content. Note my use of accessibility in this context is in the literal sense of the word, allowing a user to actually access the information they need. Here I'll share a personal experience that happened to me in July related to digital exclusion in rural areas of the UK. My family and I were recently at a friend's wedding at the Lake District, in the north of the UK. This picture is from Derwentwater Lake, around 30 miles from the border of Scotland. We stayed in an independent hostel next to Derwentwater Lake. It was only when we got there we realised how remote we actually were in terms of connectivity. There was no mobile service across the whole site, indoors or outside. Wi-Fi was only available in 2 small rooms downstairs, and none of the 30-plus bedrooms had Wi-Fi at all. The bandwidth available was extremely limited, 3.4 megabits download, 8.2 megabits upload. They even say on their website, free Wi-Fi, although speed and bandwidth is limited by our rural location. There were 150 plus guests at the wedding, and approximately 40 kids attended too, including 2 of my own. As you can imagine, there were quite a few disappointed children when their tablets couldn't stream from their favorite video streaming service. As you can see from the map of connectivity in the UK, updated in July, what we experienced while in the Lake District isn't an isolated case. It happens across the country. For those wondering, the orange dots signify less than 10 megabits available, red dots less than 2 megabits available. Lack of any color means very little to zero connectivity available. Amazing, the specific area we stayed in, seen it by the purple arrow, I'm amazed that we had any connectivity at all. In fact, if we examine the 2023 report from the UK's communication regulator Ofcom, we can see that around 8% of the UK has no coverage by any of the mobile operators, the largest region being Scotland, at 17% of the country being a not spot for mobile data. As can be seen by looking at the map again, yes, these are rural areas, but they aren't devoid of people. They are full of everyday people trying to apply for passports, register a death, or file their tax returns. 17% of Scotland is a huge area, with hundreds of thousands of people living in it. For those people, any mobile or broadband connection is likely to be precious. They most likely don't care about huge amounts of interactivity on a website. They want the site to load quickly and allow them to get from A to B with as little hassle as possible. The UK government is aware of this issue, as a report from the UK Parliament was published in June. The report is called "The Government Has No Credible Strategy to Tackle Digital Exclusion." The key findings of the report say the government's ambition to make the UK a technology superpower and boost economic growth is being undermined by high levels of digital exclusion. The committee says the scale of the problem is a direct consequence of political lethargy. Some of the figures that come from the report make for a pretty disheartening read. These include 7 million households in the UK have no broadband or mobile internet access, and 4 million people are still unable to complete a single digital task to get online. Unfortunately, the problem has only got worse in the past few years due to the cost of living crisis, as people are cancelling their monthly internet packages to save money. This is costing the UK economy approximately £63 billion every year because the country has a digital skills shortage. Among some of the recommendations the report calls for is urgent access to help with the cost of living crisis and a big investment in basic digital skills, as the most basic digital skills are now as important as maths and literacy. An interesting note from the report, it specifically says the focus should be on basic skills, not coding. The chair of the committee, Baroness Stowell of Beeston, hits the nail on the head with her summary comments, where she says, digital exclusion is a moving target. As technology develops, people currently confident using IT at work and home will need to keep refreshing their skills to avoid being left behind. We need to ensure that people of all age groups develop the skills they need to operate and the opportunities they need to develop their skills as technologies change. As we all know, technology does move fast and it's always changing. And as coming back to the issue, the point I mentioned earlier, this isn't a young versus old demographic issue. All groups must be involved in this digital upskilling. So whose responsibility is it for the digital upskilling to help bridge this digital divide? There are 6 key sectors that are responsible for reducing the digital divide. They could fall on, first, it falls on governments to enact sensible policies to ensure equal access for all. Private sector companies have a role to play as well. They can make their products more accessible and more affordable. Non-profit organisations are already working in this space to provide people with equipment and training and internet access. Schools and universities should incorporate digital literacy into their curriculums. This is particularly important for rural and low-income areas, as students may not have access to the resources at home. Individuals can help bridge the digital divide by donating old equipment and volunteering to teach digital literacy skills. Global organisations like the United Nations and World Bank already provide funding and support for projects, especially in developing countries. All these entities have a role to play, and it's only through a combined effort that the digital divide can be addressed. Oh, sorry. As the creepy Wonka meme says, what's in it for me? Why would I, as an individual or organisation, do this? If we go back to our depressing map of the connectivity in the UK, we see there are 7 million households that have no broadband or mobile internet access. And this is costing, as I mentioned, this is costing approximately £63 billion every year. If you're a business, that's a lot of potential customers. If you're a charity, that's a lot of potential donations. If you're the government, that's a lot of people you are excluding from your services. And remember, they're all paying some form of tax. They have as much right to access your services as everyone else does. So let's see. Is this a UK-only issue? Unfortunately, no. This is a global issue with a staggering 2.7 billion people, or 1/3 of the global population, still remain unconnected to the internet. This is according to the International Telecommunications Union in 2022. The ITU statistics say that the cost of mobile and broadband services has dropped recently, but it still remains too high for the average customer in a low-income economy. A basic data plan in a low-income economy costs approximately 9% of the average income. People living in this situation are literally choosing between food and housing or connectivity. Under these circumstances, connectivity is always going to be the lowest priority. So coming back to what's in it for me. Well, there are 7 million households in the UK alone that could be your next customers, worth billions to the economy. And magnitudes greater is the 2.7 billion people, roughly 1/3 of the global population, that are yet to connect to the internet. So target these low-income economies. Web performance is vital to being successful in these low-income economies. As the memorable phrase from JFK goes, a rising tide lifts all boats. So if you make your sites fast for a low-income economy, it will be fast for everywhere, everybody, and everyone. Number 2, mobile-first design. Given that a large proportion of users in countries on the other side of the digital divide access the internet through a mobile device, as seen in this graph, where 50 to 75% of the population use smartphones. Keithan's fantastic talk yesterday touched on this topic. Designing with a mobile-first approach ensures that they have the best available experience, given any device limitations they may have. Responsive web design allows a website to adapt to the screen size and capabilities of the device accessing it, which is key for users with low-end devices and slow network connections. Here I'll focus on UK data from gov.uk. For those who are not from the UK, here's an explanation of what it is. Gov.uk is the website for the UK government. It is the best place to find policy announcements, information about government, and guidance for citizens. Since 2012, it has replaced 1,884 government websites with just one to become the home of all central government's online content and services. You can see what gov.uk looks like here on the slide. This is on an iPad, iPhone, and a Dell laptop. You will see this on the slide. You see the site on the slide is built using mobile-first design principles. The design is clean and simple and lends itself to being a mobile website. It was a brave decision by the GDS design team to use a mobile-first approach back in 2012 when it was first launched. Considering the now famous A List Apart article, Responsive Web Design by Ethan Marcotte had only just been released in mid-2010, and it wasn't until 2013 that responsive web design took the internet by storm. In fact, Mashable actually called 2013 the year of responsive web design. To back up this claim, they released a responsive version of their website for the post-PC era, as they called it. Back to the topic of gov.uk, this is what the site looked like before. It wasn't exactly mobile friendly, and many would say it wasn't very user friendly either. I remember this was, and still is, a fully taxpayer funded service. The new design was quite controversial at the time. There were quite a few angry members of the public leaving comments on the GDS blog post announcing the launch. Here, a random member of the public named Howard Andrews comments, "Where is the government website for grown-ups? This is the whole of gov.uk is obviously designed for primary school children and those with special educational needs." This seems pretty harsh, Howard. I'd be interested to know if he feels the same after 11 years. In hindsight, there wasn't actually a market in 2012 for a mobile-first government website, so you can imagine why it was such a controversial decision. In 2012, 80% of the UK population were accessing the gov.uk via a desktop computer, and less than 20% of users were visiting via a mobile phone or tablet. But if we fast forward 8 years, 2 months, 9 days to the 4th of January 2021, which happens to be gov.uk's busiest day ever, things look very different. This is 8 months into the COVID-19 lockdown in the UK, when the Prime Minister, Boris Johnson, tells everyone to stay at home for the UK's 3rd national lockdown. On this evening, gov.uk has its highest traffic in its 9-year history. At the peak, the Google Analytics real-time data broke due to the 88,000 requests per second that were hitting the site. The relevant part to this section comes in this graphic. When the real-time tracking data broke, 85% of gov.uk users were on a mobile device, with only 11% of users on a desktop. What a difference 9 years can make in technology. Two other important dates regarding mobile-first design on gov.uk October 2019 was when we saw mobile usage finally exceed desktop usage month on month, as seen via the red arrow. And in March 2020, we saw a huge shift in user numbers using mobiles, seen via the blue arrow. This shift happens to coincide with Boris Johnson urging everyone in the UK to work from home and avoid pubs and restaurants. COVID-19 looks to have been a huge catalyst for greater mobile usage, at least on gov.uk anyway. Remember at the time, this was life-saving information being given to the masses via mobile-first design principles. If that's not a reason to bridge the digital divide for everyone in society, regardless of their location or circumstances, I don't know what is. What we are seeing here is an example of how mobile-first and optimized web design save lives. To reiterate the importance of mobile-first responsive design across a large population, here are some more gov.uk data from the start of this year. On the left is a heat map of all screen resolutions that visited gov.uk in a single month. There are so many resolutions. Towards the bottom right corner of the image, the text disappears into a blur of thousands of individual images. On the right is the actual number of combinations seen. The important number here is 51,989 screen resolutions visiting gov.uk in a single month. Thank goodness for mobile-first responsive design. There is way too many resolutions and devices to test on, so resilience and flexibility has to be built into the design to cater for everyone, every user visiting, no matter what device and screen size they're using. Speaking of user devices, it isn't always desktop, tablet, and mobile phones being used either. Usually, the most popular tweet in the gov.uk stats thread I posted on Twitter every month was this one. Month on month, we saw users using games consoles to visit gov.uk, and delving into the data, they aren't only visiting the homepage. There are vulnerable people trying to visit the site to find a job, find information on the cost of living, and sign into their universal credit account. There's a user story that was always spoken about at GDS. It was written up by Terence Eden, who was witness to it. I'll try to paraphrase the story for you here. Terence is doing policy research in a housing benefits office in London. A young woman sits in the middle of the office and is surrounded by bags. These are all her worldly possessions. She's holding a PlayStation Portable or a PSP. He assumes she's playing a game to pass the time. It turns out she's using the free Wi-Fi and the PSP's crappy browser to read the housing benefits pages of gov.uk. She's been kicked out of her house and her parents' house, and she now has nowhere to live. The PSP is a hand-me-down from an older brother. When asked about why she's using a PSP to browse the internet, her response is, "It's shit, but it worked." My paraphrased version doesn't do the story justice, so I'd recommend reading Terence's blog post in full. It's called The Unreasonable Effectiveness of Simple HTML, and this reiterates everything that Ryan was saying yesterday in his excellent talk. So if there's one thing you take away from this talk today, it's when building a website in the future, remember to consider users whose response to the device they're using is "it's shit, but it worked." As I'd imagine, there are millions of people across the world who are in a very similar position to the young woman mentioned in the story. They can't afford the latest device and data required to use them, so they're using a second or third-hand device with a borrowed internet connection to complete the tasks they need to. Number 3, accessibility considerations and digital exclusion. I can't stress this point enough. If we want to bridge the digital divide and reduce digital exclusion, accessibility is a huge part of the problem that needs consideration. By accessibility, I mean the literal meaning, a user being able to access the information they need, and also the use of assistive technologies like screen readers and braille readers. Whereas there is no legal requirement for a fast and performant website, the same can't be said for accessibility. In certain sectors of the UK and EU, compliance with WCAG is a legal requirement, and soon a new regulation will become law called the European Accessibility Act. More on that in a few slides' time. The US has similar requirements with Section 508 and ARDA. In my opinion, good web performance also means ensuring that websites are accessible to users with disabilities. And this means creating websites that are compatible with assistive technologies and designing interfaces that are easy to use. Now, since Chrome Lighthouse comes with a whole set of accessibility audits, I'd like to think that many in the web performance community agree with this stance. On the slide, you will see a small number of accessibility audits Lighthouse looks for. According to my last review of the documentation, it has 57 it runs in total for accessibility. When many people mention accessibility, a large proportion likely think this. This is the symbol used in the UK to signify someone in a wheelchair or a person with a physical ailment. But as I mentioned earlier, how the digital divide isn't only a young versus old demographic issue, it's exactly the same for accessibility. As the saying goes, we're all just temporarily abled, so design and build for your future self. But there's more to accessibility than physical ailments. Here we have 6 icons from Microsoft that they use when talking about inclusive design. Listed, we have permanent disabilities, like having one arm, deafness, blindness, and being a new parent. Also, temporary disabilities, like having an injury or having an eye or ear infection. Then there are the situational disabilities, like being in a noisy or distracting environment, or a place with poor lighting. But there's actually more to consider. Not included in the previous slides are the hidden disabilities. These include things like autism, mental health issues, sensory processing disorder, multiple sclerosis, dyslexia, dyspraxia, epilepsy, and the one I know well, traumatic brain injury, e.g. from brain surgery. I don't mind talking about this quite traumatic part of my life, but for those who don't know, in April 2021, I was diagnosed with a huge brain tumor. After 7 hours of brain surgery, in which 15% of my brain matter was removed, I not only woke up with the worst headache of my entire life, but also a really annoying temporary weakness in my left arm and hand, meaning I couldn't use my phone and laptop fully for many weeks post-surgery. If you're interested in what my brain looks like, the before and after MRI scans are on the slide now. In fact, I'm still considered disabled, as I'm prone to seizures and have to take daily medication to control them. Apologies for the huge tangent there. I just wanted to emphasize the point that disabilities come in all shapes and sizes, hidden and not so hidden. Building for accessibility and inclusivity is a challenge, but it's vital if we want to bridge the digital divide. As I mentioned earlier, I'd like to think that as you're attending this wonderful web performance conference, you're already thinking about building inclusive websites that minimize their device footprint and utilize efficient use of a user's limited data. An excellent resource for the current state of accessibility on the web is the Web Almanac, which I'm sure many of you have read or even contributed to. I know Rick Viscomi is here today, who is project lead on the Almanac, so a massive thank you to him for all the work he's done over the years. Comparing the 2021 versus 2022 Almanac reveals some positives, like there's been an almost 9% increase in the use of Focus Visible, but it also goes on to say there's still plenty to do with straightforward fixes like using image alt tags correctly, with approximately 2.2% of websites have alt text that can say as a file extension, and fixing anchor tags with a roll of button, which according to the Almanac, 20% of websites do. And finally, adjusting pages to have improved color contrast. Just fixing these 3 issues could improve accessibility on a large number of websites. Like Annie Cook once said, there's no MVP without accessibility. The web community needs to realize that a website only has a great user experience when that user experience works for everyone, irrespective of the device and assistive technology used. It's this user experience built for everyone that is going to be key to bridging the digital divide for all demographics. And web performance is an incredibly important part of delivering a good user experience. As I briefly mentioned earlier, if you're a company that wishes to do business in the UU, you should add the 28th of June 2025 to your diary, as this is when the European Accessibility Act becomes law for all member states. I'd recommend making your business ready for this important upcoming date to avoid the ban from trading in the EU for non-compliance. Number 4, content delivery networks. They're essential for fast and resilient websites, especially ones used by millions of people across the globe. The speed of light is quick, but when you're still looking at a ping time of 255 plus milliseconds between London and Sydney, as seen on the graph here, 255 milliseconds doesn't sound like a lot of time, but when a HTTP negotiations take multiple round trips, even before the first byte of website data is sent, this all adds up. That's why you want servers in many geographic locations across the world to mirror your content and deliver it to your users from the server closest to them. As I'm sure you all know, the specific metric I'm talking about is time to first byte, or TTFB. And as Harry Roberts said in 2019, while a good TTFB doesn't necessarily mean you'll have a fast website, a bad TTFB almost certainly guarantees a slow one. So make sure you minimize your time to first byte to ensure your users aren't left with a page that is unresponsive and frustrating to use. As I mentioned, another very important reason for using a CDN is resilience. What happens to your website when your origin falls over? More importantly, what happens to your users? When a user enters their URL into your address bar, they expect you to still be there, not an empty page staring back at them. Or even worse, a server error message that they likely don't understand. For users who aren't technically savvy, I'd imagine this screenshot displayed on the slide would be highly stressful. Do users even know or care what a server is? Probably not. They only want to visit your site, complete a task, and get on with their lives. Referring back to gov.uk's busiest day I mentioned earlier in the talk, this is what the site's traffic looked like in Google Analytics. 760,000 plus concurrent users hitting the website looking for life-saving COVID information. Thankfully, due to gov.uk's use of a CDN, this is what the users saw. Yes, it's pretty unremarkable. The users saw the standard gov.uk homepage with all the important information and news about the national lockdown, COVID-19 travel advice, and Brexit still available to read. What fun 2021 was on gov.uk. I think this is a great quote that sums up CDNs quite well. It's like being a duck, calm and unruffled on the surface, but paddling like hell underneath. And this is pretty much what was happening. There were some pretty impressive Fastly CDN stats from that day. Between 3.2 and 3.2 million concurrent users, approximately 88,000 requests per second, a 99% cache hit rate at the CDN, and for the 17 million page views between 8 and 9 p.m., only 500 errors were served. I personally think that's pretty impressive for a public service website, and without a CDN, gov.uk would have buckled under those huge user numbers. In turn, it would have left their users without vital, life-saving information they needed. Here are some of the same stats, for the same CDN stats in graph form. The top graph is the cache hit rate. The bottom graph is the number of concurrent requests hitting the CDN. While CDNs bring increased web performance, if we take the literal meaning of the word, they also increase accessibility. They do this by giving a much greater number of users globally access to the information they serve. Another important service CDNs are able to provide is optimized versions of content. For example, content that is specifically tailored for low-end devices, like the one seen here, a low-spec Android device available on pay-as-you-go for £52.99 in my local Tesco supermarket. CDNs also help users on limited and expensive data plans. Here we see that the Falkland Islands is the second most expensive country in the world for mobile data, with 30 gigabytes costing upwards of £30. No, 1 gigabyte costing upwards of £30. In summary, CDN providers play a huge part in bridging the digital divide, from improved access to the internet and reducing costs for users. They also enhance performance, provide resilience and scalability for critical online services. Number 5, data compression. Since we've been talking about CDNs, it's a great time to mention data compression too. Data compression helps reduce the size of data over the network, improving page load times and reducing data usage. This is critical for users on limited data plans. A reduction in the amount of data transferred will also lead to energy savings. This is not only good for the environment, but also translates into cost savings for users. As we saw on the previous slide, people in St. Helena and the Falkland Islands need as much help as they can when it costs upwards of £30 per gigabyte of data. This is also where data compression can help rural users. Thankfully, over the past few years, the number of websites enabling some form of compression on their assets has been increasing. The graphs on the slide show a drop in uncompressed requests between 2019 and 2021. For desktop users, this is 5.3%. For mobile users, this is a little less at only 4.5%. It's actually getting easier for web developers to enable data compression on their websites, with many CDNs offering asset compression at the touch of a button. Compression at the edge is perfect for lazy developers, where the uncompressed file is fetched from the origin and compressed on the fly by the CDN. It's possible to do this automatically when assets are updated too. It really can be a set it and forget it solution. The use of Brotli compression will reduce data over the network even further, with many of the major CDNs now supporting it by default. According to Cloudflare, by compressing Brotli at level 11, developers are able to reduce their file sizes by 19% compared to the best gzip compression level. They later go on to say how utilizing Brotli at its highest compression levels can lead to improved website performance and website page load times. And I'm sure the folks on this graph would love a 19% reduction in their data usage. At these prices, 19% would save them a small fortune. And it isn't all about remote islands in the South Pacific that have this issue. These BBC articles from 2020 describe how residents of rural villages in Wales feel totally isolated and forgotten. They talk about having to walk up hills just to get a mobile signal, and one article even mentions how the village hasn't got a reliable radio or TV signals either. Going back to the map I showed earlier in the UK, this is an issue across the whole of the United Kingdom. It's currently known as a postcode lottery in the UK, whether you get a fast connection or not. In summary, data compression has a vital part to play in bridging the digital divide. It reduces data over the network and improves page load times. More importantly, less data usage allows users on limited data plans in rural areas to gain access to the information they need, no matter where they are or the device they are using. I believe Pat Meenan's talk is talking about compression dictionaries later today, and I'm sure he will cover some upcoming improvements in data compression too. So make sure you check that out. Number 6, offline capabilities and progressive web apps. The last topic I will briefly touch on is the web platform's offline capabilities and discuss if they can help when coming to the digital divide for users. The web platform has a powerful set of APIs that are designed to help users who struggle with connectivity issues. The key API I'm talking about is the Service Worker API. Is the Service Worker API ready to be used? Well, according to Jake Archibald, one of the W3C API authors, yes, it is. And there's a whole website here saying it is. And the web platform information website, Can I Use, is in agreement, with 94.4% of users globally currently using a browser that supports the API. The natural progression from the Service Worker API is progressive web apps. These apps leverage the Service Worker API to allow web applications to access native device features. One of the standout PWAs that is often cited is the Starbucks store locator and easy ordering app. The success of this app comes with some pretty impressive web performance stats. The native Starbucks app was a hefty 148 megabytes to download, a huge download for low data users. The PWA version came in at 233 kilobytes, a whopping 99.84% smaller. This led to improved order diversity by 23%. The lightweight app opened up Starbucks to a larger user base, simply because there wasn't the 148 megabyte barrier to entry for their digital storefront. Having said all this, I personally believe that using PWAs for web performance and reducing the digital divide could likely be a double-edged sword. Don't get any ideas, Robin. Yes, this is a fine-grained, yes, you get very fine-grained control over caching and the use and a much smaller footprint than a native app. But on the slide, we see how, but on the slide, how do you explain this concept to someone who is less technically savvy or scared of technology? For example, when a user visits a website, but it then becomes a native app on their phone's home screen. Oh, God. Is the user left asking, why is this website asking me to add something to my own home screen? Why? What is a home screen? Why is it now an app? Where did the App Store go? This could likely be very confusing for a confusing user experience. I'd struggle to explain this concept to my parents and even my younger sister, who are all daily phone users, but aren't heavily into technology like I am. I personally feel that PWAs may be a bridge too far for many non-technical users, but I'd love to hear if anyone has had success using PWAs and users with limited digital skills. Maybe it's a topic to discuss over lunch later. So that's pretty much the end of my talk. I only have a few more slides before I finish. I'd like to take this opportunity to thank you, the whole web performance community, as the past few years have been pretty rough for my family and I. As I mentioned earlier, back in April 2021, I was diagnosed with a grade 3 brain tumor, completely unforeseen after having no symptoms at all. Upon seeing the size and location of the cancer, I was pretty certain that I've just been handed a death sentence, and that I'd be lucky to get to my 40th birthday in the December of that year. While waiting 6 months for my brain surgery, the web performance community were there to help keep me occupied and help me get over the huge life-changing news. A few kind folks even banded together to buy me this 7,500-piece Lego Millennium Falcon, to help me help keep me occupied during my recovery. My sons and I were completely blown away when we opened the box. But after 7 hours of awake open-head brain surgery, 33 rounds of radiotherapy, and 4 cycles of chemotherapy, thankful to the wonderful National Health Service and the miracle of modern medicine, I'm still here. So a big thank you to Tammy Everts, Andrew Betts, Barry Pollard, Patrick Meenan, Cliff Crocker, and Andy Davis, who I want to buy a nice cold Dutch beer over the next day or so. You're going to make me cry. And not only, I'm not the only person to comment on this fact. I shared this tweet with from Alex Russell, where he comments, I can't say often enough how kind, supportive, and collegial the web performance community is. Truly the best of us, staring endlessly at the worst of the web community's excesses and staying positive. A comment I completely agree with. And that's the end of my talk. Thanks for listening. I hope you found it interesting. And I want to take a second to mention that I'm currently looking for my next job role. So if you know anyone who is hiring, please do get in contact with me. I have all my slides, all my sources in the final slide. Any questions? Thanks again. Ooh.
Great job, Matt.
Thank you.
All right. Oh, God, this is really awkward. I don't even think I can get up there.
Should we lead?
I can lean. All right, thanks, Matt. That was a great talk, wasn't it, everyone? This is my standing desk now. All right. So there was one general question asked about where the slides are going to be. They are all going to be on the website. So if you want to access the slides, they will be collected there.
Yeah.
But you talked about how to get decision makers to invest in equity and access in terms of like revenue or lost donations and things. But how do you motivate developers to care who may not be familiar with the circumstances that that their users are in? What strategies do you recommend?
I would say for me, it's always been iterate small like start small and build up as you sort of do it yourself. So at GDS, I was pretty much the only person interested in and iterating web performance, and it was quite hard. You just you're pushing things uphill to get it started. But once you start the actual process of pushing it uphill, you can actually bring people along with you, and sort of being able to use other developers and other people in the organization is a big help. But if you do it completely on your own, you'll completely burn out. So it definitely starts small, and if you make if you make something important that you celebrate, completely celebrate the hell out of it, and sort of like publish on Twitter, publish a blog post, and sort of bring people along for the ride. That's what I think, anyway.
Yeah, those are great tips.
Yeah.
Thanks. And then we had a question from Marcel, who said, how do you fight the temptation of a growing number of frameworks and libraries that are used to simplify development, with an impact on performance for slower connections and devices when working on gov.uk?
I think it has to be, I think you have to start looking at users. You need to approach users and make sure that you're doing user testing. So go to, I mean, the example of the lady in the office where she's on a crappy PSP. Go to places like that and actually see how a user actually interacts with the website. And it's just having a bit of, for me, it's a bit of empathy, having empathy for for users, and making sure that they have the ability to sort of get to the information that they need, and and trying to use, as Ryan said yesterday, use the right tool for the job. If you're downloading like hundreds of megabytes of JavaScript, then users are going to have a bad time. So definitely try and sort of use empathy and sort of change whatever the tool is best to use.
For sure.
If that makes sense.
All right, I think we'll do one more question. What's one change you advocated for that you're most proud of, or that had the most impact, you think?
I think it was when I managed to enable HTTP2 on gov.uk, because it was quite a, when I first enabled it and I changed the how it worked, it all went horribly wrong. It actually got worse, and I was literally ripping my hair out. Not that I had much hair at that time, but no, it was not good at all. So I had to go back to the drawing board and sort of change. There were issues with we were using sub-resource integrity for JavaScript and for CSS, and it was breaking. It was slowing down HTTP2, but I managed to turn it off, and it thankfully it actually worked out. So that's probably one of my achievements there.
Awesome.
So.
Well, everyone, thank you again. Thank you, Matt.
Thank you. Whew.
All right, welcome back. Did you appreciate the really good coffee? It was sponsored by Love Holidays. All right, we're about to get started. So everyone, if you're not yet ready, at least pipe down a little so that we can start our next speaker. Hello, hello. I feel like doing those kindergarten things. I don't know, in the US we have this thing where it's like the teacher does this and waits until everyone else does this. All right. If y'all could be silent in the back, please. I know those conversations are really fun, but we want to respect our speakers. They're not listening. Thank you. Woo. All right, up next we have Tim Vereecke. He is a web performance architect at Akamai. He runs frustrationindex.com and also scalemates.com, the largest and most performant 3D modeling site with 40,000 visits per day. That's pretty impressive, right? He also, I found out, has 2 daughters who that frequently come across slow websites that need daddy's help. I'll let him tell you more about them. But everyone, please welcome Tim to the stage.
Good morning, everybody. I hope everybody is alive and kicking. Before I start, I want to say that I like tuning things. I like making things better. And this conference so far is awesome. Great food, great speakers, great chats. Everything is fine. Now, PPK, there is like one small little thing which we could improve next year. And it's basically related to our code of conduct. Thank you. Now, I'm not going to speak about Robin today, or maybe just a little bit. I'm talking today about noise canceling RUM. And in my day job at Akamai, where I try to make our customers' websites as fast as possible, also when working on my own website, I use real user monitoring. And I really love real user monitoring. And why? Because it tells me how my website behaves under real-world conditions. Fast browsers, slow browsers, good connections, bad connections, somebody in Australia, somebody in Belgium. I basically see how everything works. Now, of course, it's not because I love real user monitoring. There is something else I love in my life. And those are, of course, my 2 little daughters. Now, RUM and my daughters actually have one thing in common. They can be very, very noisy. And some parental advice here. During the pandemic, the solution for my daughters was quite easy. Some noise-canceling headphones and problem solved. For RUM, it's a little bit more complex. Well, actually not that complex, it's quite easy. So let's explain that today. And if you implement the techniques I apply here, your RUM data will make more sense. Whenever you make a change, you will instantly spot it. You will see less fluctuations, and also if you correlate RUM data with business metrics, they will also make more sense. So stay tuned. Now, if I show a graph like this, everybody is basically happy, right? And if your graph looks like this, you don't need noise canceling RUM. Then everything is fine. However, how often does it happen that you hope you see a nice change like this, and then it's only, or even worse, no change at all? I've been there. And the reason is simple. There are 3 sources of noise which contribute to what you hope to get and what you actually get. And issue number 1 is we have this single percentile fetish. My kids, they have like this single color fetish, blue or purple. When you talk, we either, oh, what's your percentile you look at? Oh, the P75, the P50. Oh, no, I look at the P95. We have this single percentile fetish. And the problem with that is, I'll explain that straight away, but first, let's double check that to make sure, because I will use percentiles a lot, and you really need to know what percentiles are. So suppose you have these 12 measurements. In order to get the median or the P75, what do? You order them from very fast to very slow. And in the middle is the median or the P50. So 50% is faster than this value, or 50% is also slower than this value. P75, 25% is faster, is slower, 75% is lower. Same for P25, P95, P whatever you are looking at. And that's fine, it's simple. Now the problem is, if you just look at one, or you focus on one, you have this issue. I also work for a CDN, and this is a common pattern I see on many websites. If you're looking at the fastest percentiles, they're like very, very fast. You have like a big gap, and then you have some very, very slow responses. And this is basically cache hit, fast, served from the CDN, cache miss, you need to go to the origin is slow, you need to go from Australia to Belgium or to the Netherlands, you have some latency like Matt said earlier. And what is the option? Let's increase the TTL. Now if you increase the TTL, you get more cache hits and less cache misses. Is this a good change or not? Yes, this is a good change. Now, if you only look at one percentile, and I have a lot of customers, for example, the cool ones, they like to look at the P95 or the P99. If you just look at this value, this was no impact at all. If you're looking at the P75, everybody now with the Core Web Vitals looks at the P75, it would be, maybe why did we spend so much time in order to get so little benefits? On the other hand, if in this case you look at the median, you might have the impression that all your users got faster, while only a portion of the users are faster. So the solution is simple. Always, always, always analyze multiple percentiles. Otherwise, you create blind spots for no reason. Now, a word of caution. Suppose these fake numbers here at the bottom, you do a deploy, and these are the new numbers. What do you see? All of them got better. Yes? The P95, the P50, the P67, the P32, everything got better. Now, does it mean that all users got a better user experience? The typical answer is yes. Now, very often, what do? In this case, it's actually not. The only thing I did is the slowest response, let's say my users in Australia, I found a fix, magical fix for them, and I made them super fast, the same as in the Netherlands. Yes, all my percentiles improved, but I only impacted a small portion of my users. And why does this matter? Suppose you're looking at business metrics and you say, oh, all our percentiles improved, our bounce rate should improve, everything should improve, we should make more money. And you don't see that correlation. Why? You only impacted a small portion of the users, although all your percentiles were. So that's a word of caution. Let's go to issue number 2, traffic patterns. You don't see this issue in synthetic. And I love synthetic as well, so that's not a problem. But with synthetic, you're always testing on the same conditions. And with run data, you have certain patterns. If you're looking at a long-term trend in any run tool, you will see this pattern. And it's basically super easy. This is the weekend. Or depending on the audience, your weekends could be faster. Why? Different network conditions, different devices, people browsing less or more because they have more time, basically a lot different. For some of them, you will also see on Wednesday a small change because, for example, in Belgium on Wednesday, that's when dads or moms stay at home for their kids, and that's like a different thing. Now, why does it matter? Suppose you do a deploy on a Tuesday, And a few days later, you go into RUM and you say, I want to check if my improvements got better, if my changes did make an improvement or not. And very often you see, oh, I compared since the day of my deploy plus 3 days, and I do minus 3 days since the previous deploy, which makes sense. However, in this case, you would see a performance improvement while there is actually no performance difference at all. Because you add 2 days of slow weekend and you compare it to 3 fast weekdays. So what is better? And my advice is always, always, always compare apples to apples and compare it, for example, to the same 3 days before. Now, you not only have long-term patterns, you also have daily patterns. So here you're seeing the backend time, so time to first byte, at, I think, the P90, in the end doesn't matter. But what you're seeing here is that, magic, doesn't matter. At the bottom, you see 750 milliseconds. Depending on the time of the day, the fastest hour every single day on my website is 8 p.m. It's 100 milliseconds faster than the normal day. During the night, my performance every night drops with 100 milliseconds. So depending on the time of day, there's like a 200 milliseconds difference. What does it mean? Suppose you do a deploy and you look at your run data and you compare the first 3 hours after the deploy to the 3 hours before, you could come to the conclusion, hey, great change. You could also roll back because you thought it was degraded while it's actually not. So take into account your daily patterns as well. So compare apples to apples. That's already, I would say, the basics. If you're looking at the run data, that's the basics. Now let's look into the fun part. RUM contains a lot of irrelevant data, useless data, worthless data, whatever you say. And my advice here, let's straight away go, always focus on human visible navigations. Or if it's not human, if it's not visible, and if it's not a navigation, skip it by default, by default. Let me explain why that matters. And the noise levels of non-human visible navigations is 22%. So 1 out of 4 or 1 out of 5, depending on your website, is noise. And there are 3 sources of noise. One 15%, one only 1%, we will cover that later, and then 6%. Now, a little bit on my website, so I run the largest scale modeling website in the world. This is one of the 500,000 product detail pages. And if you don't know scale modeling, it's the coolest hobby on this planet. Much cooler than sword fighting. So if you don't know scale modeling, you basically buy a kit, you open the box, you have a lot of plastic sprues, you cut them, you glue them, you paint them, you airbrush them, you weather them, and you try to make a beautiful model like this. And you spend basically 1 year, 2 years, like I do, on a model like this. Now, I don't only have the largest scale modeling website in the world, I also have the fastest scale modeling website in the world. Thank you. Because my day job at Akamai, when I come home, my lovely kids, I give them hugs, I play with them, all these things, and then they go to sleep, the noise stops, my wife starts watching Grey's Anatomy, and then I pick my laptop and I try to make the website as fast as possible. So early hints, all the cool stuff, early hints, speculation rules, Broadly compression, CDN, image optimizations, AVIF, I try to do everything in there. Now, how I got there, I also had to implement and look at human visible navigations. Otherwise, I wouldn't have been able to get rid of the outliers. So let's look at navigations. So the human visible navigations, so we start at the end. If you go to the browser console and you type in this little snippet, you get 3 values. Either a navigation, the user clicked on a link, went to the next page. Either a back-forward navigation, the user clicked on the back button. Or, developers like us, you hit the reload button. So 3 options. If you do that in RAM data on my website, you see that 85% are navigations, and then 15% is what I call noise, from a real user monitoring perspective. And the reason is noise is basically on the next slide. Here you see the waiting time. So this is time to first byte without DNS, TCP, SSL handshake, redirects, just browser sends a GET request, and I get my response back. And what do you see? That the navigations I care about is 96 milliseconds. But because 14% of very, very, very fast back-forward navigations are added in the mix, this results in the total time being improved. Now, why does this matter? Suppose I work for a CDN. Suppose you make some caching changes like before, and you want to measure the impact. On which of these groups do you see the impact? On the back-forward navigations? No impact. So one of the reasons of noise is because you look at all your data, and you look at a portion which is not impacted by it. So by default, when I tune, and the same is not only for the CDN, it's also for the backend. If you're tuning database queries and you're trying to shave off some milliseconds there, on the back-forward navigations, typically, they don't have any influence. Now, what is the impact? Remember that fake data? If you add very, very fast back-forward navigations, you add, let's say, here 3 at the beginning, what happens? Your percentiles change. In this case, you will actually, at the top, you see the previous. Let me double check, you can see it, yes. At the top you see the previous percentiles. So the P50 is now a lot better. The P25, the lower percentiles, are shifted a lot. The P95 maybe just a little bit. Now, you might say, Tim, noise levels, we never look at the P50, we never look at the P25. Who cares? The problem is, noise levels can be different. For example, like every website, I have a homepage. People do a search, because it's the search engine is very important. Next, they click on a kit. That's the base model. That's what I call product detail page kits. And then, like in the real world, you can pay a lot of extra money on additional sets, like adding additional details, change different markings, some figurines. You can basically add some additional aftermarket sets for the product detail pages. Now, why do you care? I know you're not scale modelers, that's fine. But let's look at the noise levels of these 4 pages. So the back-forward noise on my search is almost 23%. Now, this basically turned into a blind spot. So for me, I know Tammy said that search is not always the most important, which is okay, but for me, the search engine is like the key part of the website. And I want it to be fast. And for years, I thought it was fast. Why? Because it contained 23% of lightning-fast back-forward navigations, and the actual performance of my search engine was more here. So that's a problem. Another problem is I spent hours and hours and hours, a few sessions of Grey's Anatomy, trying to understand why are my kids' detail pages faster than my aftermarket pages. Because they basically share the same template. It's the same hero image, the same stuff, basically everywhere. So I tried, there were like just a few queries difference, so that must have been the difference. I spent hours and hours and hours tuning, and I was never able to understand the difference. And the reason is basically simple. If I looked at the median, one was faster. Why? Because it had more lightning fast back-forward navigations. And why is that? Actually, now I forget. For example, for the search, why does a search page have a lot of back-forward navigations? You do a search, right-click, open a new tab, or you click and you hit the back button. You click, you hit the back button. You click, you hit the back button. And the same is true for these aftermarket sets. If you're looking at a product detail page, at the bottom, hey, here are some aftermarket sets. So you click on the first one, you go back to that product detail page. You click on the second one, you go back to the product detail page. That's the reason. Another example here from Ample's RUM, which I use, is here you see the typical red, green, orange, where the impact of these very, very fast back-forward navigations is seen on the total bottom row. So my actual performance is actually slower than without the noise. And I hear you say, Tim, we don't care about your stupid scale modeling website because our site is different. And I agree. Last year, here at the performance conference here, the RUM archive was introduced. And the RUM archive is a multiple aggregated customers' data, all anonymized, where you can spot certain trends. It's open source, and if you go to rumarchive.com, you will see that. And what does the RUM archive tell you? That for all these websites, which are not ScaleMates, that the noise on desktop, or sorry, on mobile is a little bit lower. It's around, let's say, 11%. And on desktop, it's going into the, I miss my glasses, the 10%. Now, it's not as much, but it's more than enough to skew your data and to put you in the wrong direction. Another graph from the RUM archive. So here you see a histogram of the time to first byte. And what you see that back-forward navigations, the orange part in the beginning, that there's like a big chunk of very, very fast back-forward navigations. Those make the median and the P75 look better. And basically, the RUM archive is 1 year old today, which is awesome. And Nick Jansma, he's an amazing colleague of mine. I have plenty of amazing colleagues. Nick is smart. Nick is humble. Nick has cool hobbies. Nick is friendly. Nick is basically everything you want from a nice colleague. Another new thing is introduced today. This is new today. Is RUM Insights. So RUM archive is cool, it's open source, but you needed BigQuery to actually query it. So it costs money, you need to set up an account, and although it's not that complex, it adds some effort. So RUM Insights is something new, and it's, if you go to rumarchive.com since today, you will actually see a lot of the insights in an easy consumable way without actually having to need to query things. So the screenshots I shared before were basically RUM Insights. Now, RUM Archive is done by a team of people at Akamai, and RUM Insights has one downside. Robin. Tammy said, work harder. Not don't work harder, work smarter. You should have been smart enough to know that I come after you. Now, Robin. How Robin thinks he looks. Robin, can you please stand up? Now, I want you to stay there. Now, we know Robin is a sword fighter. 13th century, 14th century, whatever. Now, none of us are sword fighters. So, Robin, suppose you would have a sword in your hand. Are you able to hit me from that location? The answer is no. Is that smart? No. Because next to scale modeling, I will now have for next year a new hobby, which is called longbow arrow shooting. Thank you, Robin. Back to the noise. So, back-forward noise really impacts that deploy. Can really add things. So if you have any backend changes, if you include the fast back-forward noise, you will not see a big impact as you think, because you think, oh, it impacts all my traffic, while it only impacts 80% of your traffic. Now, next is visible. What do I mean with visible? If in the browser you type document.visibility_state, you get visible. And if you type it in the console, you will always see visible, because at that point in time, the tab is visible. However, if you do that in RUM, and you capture that data, you get 3 different values, potential values. One is always visible. It means, let's say I'm in Google, I click on a link, I stay in the same tab, so the page starts loading in a visible state, and by the time the RUM data is sent, let's say on page load or a little bit later, the page was still visible. Always visible. Partially hidden means, or partially visible, how you want to say it, is, for example, I'm in Google, I right-click on a search result, I open it in a new tab, so the page starts invisible, and then before the beacon is sent, I click on that new tab, and it's loaded. The other way around can happen as well. I navigate on a website, I open a link, and for whatever reason, maybe because it takes too long, I switch tabs, so you start visible, and that's easy, nothing special. Now, why is this noise? The reason is very simple. On the next slide, based on RUM data, this is again on ScaleMates. My largest contentful paint is 4.75 seconds at the 95th percentile, which is good. Now, if you're looking at the total, it's actually slower, 4.89. And I would say the noise itself is fine. Now, always hidden is 7% of that is 8 seconds. Now, why would a page, when it's partially hidden, be slower than a page which is fully visible? Because browsers are smart. Browsers focus on the stuff you see, and the moment something is on a hidden tab, it will not allocate all priorities to render that hidden page. It will focus on rendering the page you actually see on screen. So that result, what it means is, the moment your page is somehow hidden, that for the browser, the performance no longer matters that much, which is okay. Now, how many of you have ever done a performance project where you want to improve the performance of a hidden page? Just like my skills on sword fighting, 0. Now, the reason why it's partially hidden is slower than always hidden is just because I just don't have enough samples. So I don't have a reason why the bottom one is twice as big. I think it's just because of the very, very low sampling. Now, look at the noise levels. How many of you tune the 95th percentile? Nobody? 95th percentile? Yeah, few hands, thank you. What is the problem if you're tuning the 95th percentile? If there's 7% very, very slow navigations, where the performance is degraded because the browser also decided to degrade, you're basically looking at trying to tune the performance of hidden pages. and you're doing whatever you want, and you don't see change in numbers. Or you ask yourself, why is it 13 seconds? Like, is there some query at the P99 which is taking multiple seconds? Is my CDN slower? Can be anything. So that adds those very fast, slow navigations add some noise to your data. So my advice is only focus on always visible. And same here, these 4 pages. The noise levels, again, can change based on the page you're looking at. Because one solution might be, oh, then let's not look at the 95th percentile, let's look at the 90th percentile, problem solved. If I do that on my home page, there the noise is 10%. So the 90th percentile is likely a hidden or partially hidden navigation. Again, here, search. Search was already faster than I thought, than reality, because it contained a lot of very fast back-forward navigations. In this case, it also looks faster than the rest. Why? Because it has relatively fewer very slow ones. So for years I thought my search is fine. The reality was that it was not that as fine as I thought. And bottom one, same thing. Here there was a difference. And why is that? Again, on for example, for product detail pages, what do people do? They right-click, open a new window, right-click, open a new window. And that's the impact of that. Now, I know, Tim, your website is different. If you're looking at the RUM archive data, or in this case, RUM Insights, which Awesome Robin, and I really love Robin, so if Awesome Robin made, is basically, here you see like 15% of noise, which is basically more than what you just saw. So the impact here with 15% is you already need to go like to the 85th, 90th percentile before you get rid of that noise. And on desktop, it's a little bit less. Back to these fake numbers. What happens is that noise adds this part of the screen, adds some very, very slow navigations, and this results, if you're looking at the P95, it skews your P95. It skews your P75. It skews your P50, and then for the very slow ones, it does not have any impact. And here is whatever you do to tune is, if you're looking at the P95 and like, why is it not changing? If you're looking at Matstock, we want to improve, we want to reduce the digital divide, we want to make sure that our 95th percentile is as fast as possible. Good luck if you're trying to make it faster for always visible, for the noise ones. Next is human. And real user monitoring somehow means for me real users, so you exclude bots. And there's one bot everybody cares about, which is the only bot people care about, is the Google crawler. Here you see Google crawler visiting my website, and they're welcome. Come as much as you want, because the more Google comes to my website, the more money I make, which is good. And I tuned for performance for bots as well, but I don't use real user monitoring for it. Why? Because Google bot does not run beacons by default. Why would they spend time on running run beacons? The only thing they want to do is crawl the HTML, and basically that's it. So that's not the problem. So I also don't need to worry about Google hitting the website too much. It does not add up in the data. And a lot of bots, I would say also other stupid bots, they just crawl the HTML. For example, on my website, I also show 3 million price comparisons. So what do bots try to do? They try to scrape my website and based on that make decisions of how much they should sell their product for. That's one thing. Another thing is I have a huge database with a lot of product information, like barcodes and when things were released. other websites like to consume/steal that information to make their websites better. Now, a lot of those bots don't execute JavaScript, which is fine. But some of them, they try to pretend to be browsers to get not detected. So what do? They do basically everything a normal browser would do, and they will also execute run beacons. And here is an example. And the problem is, remember that noise level was 1%? So it's 1% of the noise. That's in theory like neglectable. The problem is that bots are unpredictable. The noise levels might be 0 now and 80% for the next hour. They might not hit the home page, but only product detail pages, so their traffic patterns are completely different. And what you're seeing here is a CLS spike due to bots. Somewhere, I don't remember which date, Grey's Anatomy season, whatever, I took my laptop, deploy, making changes, trying to get CLS to 0, and I do a change somewhere later on. So the next day, what do? I look at my data and I compare the timings, the right timings, right? Looking apples to apples, I look at the right, and I saw degradation in CLS. And I didn't understand why, and sometimes CLS is difficult to understand, but the values were like, there was no doubt, rum never lies. I had a degradation in CLS. So I rolled back. A few evenings later, luckily my wife was then looking at season 37, I found the issue, and what was the problem? This was a German bot. And that German bot used an older version of Chrome, which had some CLS issues not being fixed. So all normal users were on the fixed thing. Maybe a small percentage normal users is there, but each time that bot hit the website, the amount of CLS issues increased. Why? Because I had suddenly a lot more measurements with that bad bot data. So, thing is, get rid of bots. So, 78% human visible navigation. By default, and that's the keyword, by default, whenever I do an analysis, I only focus on the middle part. So, no reloads, no back-forward navigations. Exclude the bots and only look at stuff which is visible. And your life will be a lot easier. And if you combine these two, because I remove noise at the beginning, I remove noise at the end. If you combine these two, you will see that your performance is actually a lot different. So the fastest percentiles get a little bit slower. The slowest percentiles get a little bit faster. And somewhere in the middle, if you look at the P75, it happens to collide a lot. Now, I don't know, we're just looking at the P75, which is good. If you're just looking at the P75, you will miss anyway some things. But if you would only look at the P75 and you would ignore everything I say, then this is still a problem. Why? Because it depends on the page. This is on overall, this happens to collide. But if on some pages it's 20%, on others it's 5%, you will never know what are the noise levels, so just skip it. Now, I said already a few times irrelevant data. And Barry's sitting at the front. He's a big fan of back-forward cache. He's getting a little bit nervous each time I'm saying, ignore back-forward cache, ignore back-forward cache, ignore back-forward cache. And the thing is, it's irrelevant data for many of your analysis, but for some, it might not. You might also ask, if it's irrelevant, why do RUM tools even capture this data? Like, why should I be bothered filtering it out? Shouldn't RUM tools just get rid of this data? And the answer is no, because often it's irrelevant, but it can actually also be relevant. And then the noise becomes the signal. For example, back-forward noise. If you're tuning waiting time, LCP, all those things, that's fine. CLS, cumulative layout shift. A lot of the cumulative layout shifts happen when people hit the back button. Do you care about those layout shifts? Absolutely yes. So for waiting time and tuning the CDN, it's noise. For CLS, it's not noise. Another thing is, I want these back-forward caches to be fast. Because I want the back-forward navigations to be fast. Why? I want, ideally, the back-forward cache to be used. And it should be instant. So, of course, check if sometimes I only zoom in on back-forward caches, and I validate, are my back-forward caches actually as fast as I expect? And if it's fast for 80%, great. And if 20% is slow, then I need to find out why are those not instant, because I'm leaving performance on the table. The 6% visibility state. I never, ever, ever look at what is the performance of visibility state hidden, but I do care about the percentage of that noise. Because typically, the bigger this number is, the slower your website, or the more annoying your website loads. Because if your page loads very slowly and shifts around, what do people do? If that would happen on my website, I would say right-click, open a new window, right-click, open a new window, and they wait a bit, and then they go in there. So if that noise level increases, could be an indication that your users are frustrated by the loading of the page. Now, you can't get this to 0, but the faster it is, the slower, the fewer chances people actually have to switch tabs. And the bottom one, the top one, the 1%, when do I look at bots? Rarely. If it would be a security conference, we could now talk for ages about this, but from a performance perspective, I always get rid of the noise. Another reason why you can't remove those from RUM at all, those are still valid navigations. So if you compare RUM data with business metric, things like bounce rate, conversion, session length, all these navigations are still valid from a business perspective. So this brings me to the end of my talk. So noise cancelling RUM is, yes, I love real user monitoring, but you need to remove 3 sources of noise. Make sure to look at multiple percentiles, because if you're just looking at one, you make yourself some troubles. 2, make sure to always compare apples to apples. So weekdays, think about weekdays versus weekends. And then 3, by default, for many of the optimizations, focus on human visible navigations and only look at the rest for things like CLS or validating the back-forward cache. With that, if you would like to follow me, I'm on Mastodon, Twitter, LinkedIn under Tim Vereecke, and I would say thank you very, very much for your time. Thank you. Thank you.
Welcome. That was amazing talk.
Thank you, Sia.
So much. Are you ready for some questions?
Definitely.
All right. Oh, and as a reminder, if you do have questions, you can submit them online with #perf_now and on the website. So would a fair summary be, make sure you're measuring what you think you're measuring? And then considering that, are there any other sources of noise that might be common ones that people miss when analyzing their data?
Other sources of noise, yes. There are, for example, I once did a talk on responsive RUM, where we all expect that people on a mobile device look at the mobile version of the website, which is not true, or on desktop, that people look on the, always load the large version of the website, sometimes it's small. So yeah, there you can also have some noise. For example, on desktop, we always think desktop is also means fast connection. In RUM data, you can still have somebody in rural areas who is using a satellite connection on desktop. So that could be another reason for noise.
Yeah. And then a good kind of technical one, but how do you determine if a visitor is a human or a bot?
How I determine that is, I will now speak for the, one is user agent. A lot of the bots might just say, hey, I'm a crawler, get rid of that. For example, if you run web page test, you can change the user agent, so you could filter that out, that's one thing. And then I know on the Akamai side, Akamai has like bot detection tools based on plenty of other patterns, and that can be injected in the run data as well.
Oh, cool. And then do you know if other data sets like the Chrome User Experience Report share any way to filter out noise or understand how much noise might exist?
So what I know is, for example, for CLS in Crux, does contain your back-forward navigations, because that's, that matters. So for CLS, it's not noise. I think for LCP, and the Google folks might correct me, but if LCP, if it's on a hidden page or partially hidden page, then it's, in my view, not included in Crux. So for LCP, it's filtered out.
Okay.
CLS?
CLS is filtered out and IMP is included.
Right.
For reasons.
That's another talk, likely.
In case you missed that last part. And then we have a good question from Pat here. Since he's sitting on the first row, I should ask it. Oh, okay, cool. Okay, good. I do have a very important question to ask you. What's a good intro scale model to try out while my partner is watching Keeping Up with the Kardashians?
I would say an Airfix model of a Spitfire in scale 1 to 72.
And that would be an airplane?
That would be an airplane,
Oh,
yes.
good. See, I'm at least a little smart. Awesome. Well, thank you so much for your time. Everyone, please give Tim another round of applause.
Thank you. Thank you.
Aw.
Thank you.
I have a few announcements while we get set up on the next speaker. But so the Performance Help Desk is sponsored by Google, in case you didn't notice. If you need to get your questions answered there, please check them out. Also, the Chrome team has this new mini-map tool for the perf panel that they want to get feedback on. And so if you're interested in checking that out, also go up to the Performance Help Desk and provide your feedback. Also, there was a power outage at the airport. So if your flight is today, you might want to check on the status of that before you actually head out to the airport. I have actually no idea how they're doing, but you might want to check it out. You must stay here forever. What else is going on? As you know, I'll just tell you this ahead of time, because I don't think most of you noticed this yesterday, but when lunch comes around, you know that there are two sides, right? There's two sides, food on both sides, but there's also there's usually a line that comes from both directions on this side. So if the line in the back is really long, check out the line on the hidden staircase side. I should have not told you, because that's how I get food fast. Wait, what? I know, don't share the secrets. It's a hack for next time. We won't tell them next time. Ready? All right, our next speaker is Estela Franco. She's a web performance specialist for Schneider Electric. She's also a Google developer expert in web technologies and also a Storyblock ambassador. You can find out more about her on estelafranco.com. I'm really excited to introduce you to Estela because we share a passion for a particular issue, which you will learn more about in her presentation and why. And by the way, I work at Shopify, so when you look up there and you see our numbers. All right, everyone please give Estela a round of applause.
Thank you. Thank you. Hello, good morning. I'm thrilled to be here today to talk about challenging assumptions about LCP best practices with data. So the first thing that you may think is, why are you still talking about LCP? Are you from the past? I mean, everybody knows everything about LCP, right? We know the thresholds, the best practices, the techniques to keep this metric under control. So to answer that question, I want to take a step back. Okay? In fact, I'm going to talk about the past, the present, and the future. So it seems like I'm going to talk about time travel. So I need, sorry, what's this? Oh, I can't believe that. Demo effect, sorry. Really, what's happening here? What's happening here?
Try password 1, 2, 3.
Sorry. OK, so it seems I'm going to talk about time travel. So I need a better background for my presentation. Yep, that is much better. So let's move to the past. So far, we've been focusing on our classic and beloved core web vitals, LCP, feed, and CLS. But a new metric has come to the core web vitals town. INP is here, traveling from March 2024, when it will become stable core web vital. Okay? And that's really bad news for feed, because INP is here to shame and replace FID. And the web performance community is super excited about this new metric. Don't get me wrong, I'm also super excited. I mean, who wouldn't be with all that JavaScript and long tasks and style calculation? So yeah, it's amazing. It's really incredible, this metric, right? But now let's move on. Let's move to the present, and let's see how these metrics have evolved over time. And you can see LCP has evolved a lot over the last years. You can see here, since it was launched in Chrome 77, that was September 2019. And a lot of things has happened since then. You can see a lot of implementation optimizations, bug fixings, and definition improvements. And do you remember? Come on. Well, do you remember how CLS used to be? Now it's a much better metric that it was designed to be, right? And again, a lot of things has happened since it was launched over the last years. But what about feed? It doesn't matter when you look at this metric. It's been a bad metric for a long time, right? And if you can see here, it hasn't evolved that much. And you know what? Even IMP has evolved even before becoming a stable core web vital. And the current approach is much better than other approaches that were tested in the past. If you got that joke, please come to see me after the talk, because it's a joke for real Back to the Future fans. So this was fun, but I haven't answered yet the question, right? Why I'm still talking about LCP. Instead of answering that question with words, I want to answer that with data. So let's have a look at the CRACS report. This is data for the last 3 years. It's data from August during the last 3 years. And you can see the percentage of origins with good core web vitals, the classic core web vitals. And you can see slight improvements year over year, but still less than half of the origins have good core web vitals on mobile or desktop. And if we break this information down by metric, we can see that LCP is the worst one. Okay? Even if we compare LCP with IMP, LCP is still worse than IMP. So hold on, I'm not saying that you shouldn't care about IMP. You should care about IMP. But LCP is still bad. It's not under control. So you also need LCP to pass the core web vitals. So that's why I'm still talking about LCP. Because everybody knows everything about LCP and how to improve that, but data says that LCP is still bad. Okay. So why is this happening? So again, let's look at the data. In this case, this is data from the HTTP archive. And you can see that images are the most common LCP content type. And images tend to be harder to optimize than text-based elements, right? So it makes sense that images are causing like these bad LCP results. But let's break down the LCP. In fact, the LCP is composed by 4 subparts: the time to first byte, the resource load delay, the resource load time, and the element render delay. So to better understand these subparts, let's look at this waterfall. You can see that blue line for the HTML document request, then a couple of purple lines for some style sheets. I'm really sorry, because this never happened before in this conference while I was sitting there. OK. Then the style sheets. Then we have a green line for an image, which happens to be the LCP element, and then some yellow lines for some JavaScript. And after the last JavaScript, we can see the LCP mark. So where's every subpart? The time to first byte is the easy one. It's the time that it takes to the browser to get the first byte of information since the page is requested. So it's the lighter part of the blue line. Then there's a piece of time until the LCP element is requested. That's the resource load delay. Then the time from when the element is requested until it's fully downloaded, it's the resource load time. And the time until the element is actually rendered in the screen is the element render delay. So let's take a look close at each subpart and what we know about how to optimize them. First of all, time to first byte. The first thing you need to ensure is that your host is able to handle the traffic you send to it, because if not, it will be complicated to have a good time to first byte. Another good practice is to optimize your backend, because if your systems are really slow to generate the HTML response, that will impact the final LCP value, because this time to first byte delay. Then you can use a CDN, especially if your users are far from your servers. But this can be expensive, and not all the projects have the budget to afford it. But you can cache the content whenever possible. Okay, so that can also help a little bit. Also, it's important to avoid page redirects, because when a user clicks a link, all the redirects that the browser needs to follow until it gets the final URL are calculated as part of the time to first byte. Also, you can use a service worker. You can leverage its cache to improve this metric. And last but not least, you can also use 103 early hints for render critical resources. Last year here, Sia gave a really interesting and really fun talk about this early hints technique, so that's really great if you can check it. Moving on, the next one, resource load delay. In this case, you need to focus on two aspects. First of all, you can optimize when the resource is discoverable. In short, your LCP, in this case, the LCP element, the LCP image should be discoverable by the preload scanner. So to do that, it's important to avoid JavaScript-generated LCP elements, because JavaScript, the browser needs to download the HTML, then discovers the JavaScript, then download the JavaScript is executed, and we finally have the content, right? So that's too slow. And also, if you are loading the LCP image from style sheets, it's important to preload them, okay, to make sure that the preload scanner will identify them and download them. The other thing you need to focus on is to ensure that you gave the correct, proper priority to the resources. Okay? In this case, it's important to avoid lazy loading LCP resources. And here, I want to make a little stop to go deeper on that. Because in fact, at Schneider Electric, where I work, we've been also facing several issues with that. In fact, we were lazy loading with JavaScript our LCP images in some pages, which is terrible, because especially on mobile devices, on low-end devices. So this is something that you can easily fix. In our case, we went from something like this with all those data attributes that are managed by JavaScript to something like this. You have directly the resources linked from the element, the HTML tag. And that impacts a lot, especially on mobile devices, okay, because it's easier, the image is downloaded faster, and you can have massive improvement just with that. And in fact, I'm really concerned a bit about this topic. And last year, I wrote, I was a blue girl last year. Now it's reddish. I wrote an article about this topic on the Perf Planet calendar because, it's an important topic for me. And in this case, the data that I used at that time, it was from Web Almanac 2022. And it says that almost 1 in 5 pages, mobile pages, are lazy loading their LCP images. Okay, so that sounds terrible. And if we split this data down by platform, you can see here that WordPress and Shopify were the ones with the worst issues, right? Moreover, Elementor, which is a popular WordPress page builder, seems to have also some important weight here, right? But during the last year, The WordPress team has worked a lot to improve this fix from the core, and also Elementor has improved this lazy loading feature to try to fix that from their end also. On the other hand, Shopify has also worked a lot on that. Yeah, that's Sia. I was really happy to see that Sia updated my data for my article to also keep monitoring this data while they were working on several improvements, right? And in fact, several conversations occurred around this topic, and currently the HTTP archive is storing the Shopify object, which also contains the Shopify theme. So now it's easier to identify if there are any particular Shopify themes that are maybe doing things worse than others, right? But you know what's even better than lab data? Field data, okay? And in fact, Shopify launched last week a table with internal data from the real users for their top 100 themes, okay? So for users, if you are using Shopify, you can go there and see if the theme that you are using is doing better or worse than other options in the market, right? That's great, RAM data. So the point here, I want to keep encouraging you to continue looking at the data and sharing your findings, because as you've seen, the web performance community is amazing. You can have great conversations with platforms, with tools, with everybody, and you can help the website ecosystem to have better results. Okay, so I want to share this with you. Okay, so that's why avoid lazy loading LCP resources is bad. But you can also leverage the fetch priority attribute. And I know there's some kind of a skepticism about this technique, but even Google implemented that on Google Flights. And you can see here, great improvements by just adding an HTML attribute to one tag. Okay, so that's an amazing quick win just by adding a tag. Okay, so moving on, the resource load time is the third one. What we know about how to optimize this subpart, it's, let's say, the most popular. Here is where we apply the traditional optimization techniques. It's important to reduce the size of the resource. This means that you need to serve the optimal size of the image. You can use modern image formats. You can compress images to try to reduce the size of the image resource in this case. You can also reduce the distance the resource has to travel from the server to the final client. In this case, the best way to do that is using a CDN. Also, it's important to reduce the network contention. So you need to make sure that you apply the proper priorities to all the resources to avoid many, many resources being downloaded at the same time. And you can also eliminate the network time entirely by serving the resources with the proper cache content policies. In this case, we're moving to the element render delay, the last LCP subpart. And if the delay is caused by style sheets, you can reduce or inline the render blocking style sheets when possible. We don't want thousands of lines of CSS inlined in our HTML page. If the delay is caused by render blocking JavaScript, in this case, we can also defer or inline the render blocking JavaScript. Again, when possible, we don't want 10,000 lines of JavaScript there. Or sometimes the delay can be caused by unrelated long tasks blocking the main thread. In this case, we can identify them and try to break them up so the main thread is able to manage the render stuff to render the image in the screen. Also, we can use the server-side rendering approach instead of a client-side rendering approach, because with this approach, the image will be discoverable by the preload scanner because the HTML is there, the elements are there, so it will be easier. But this generally means that we will have more server work, okay? So that may affect time to first byte. So as we always say, it depends, right? We need to test it, and we need to check if it's good or not applying this kind of techniques, but we can also apply the static site generator approach. In this case, we will pre-render the content in the server during a build time instead of on demand, so that will help to reduce the server work time. So, okay, we've seen the different subparts and what we know about how to optimize them, but what are the optimal subparts time? So according to web.dev, the LCP subparts should follow this distribution. Time to first byte should be about 40% of the LCP values, the resource load delay less than 10%, the resource load time about 40%, and the element render delay about 10%. And when you see this, you can think, okay, LCP threshold for the good bucket is 2.5, then I can calculate that. Don't do that, please. You need to compare, it's a distribution. So don't take the values themselves calculated for one specific threshold. So you need to look at your data and the distribution for your LCP values, okay? But that's theory. But what's happening out there? And it's not a rhetorical question, okay? What's the biggest issue related to LCP subparts? And we have a Slido poll open, okay? Here you have it, the bigger QR and the URL, because I want to hear from you, okay? I will give you a few seconds. And you can vote for your bet, and we will check the results later. Okay. Got it? Okay. So, to answer that question, which is the worst subpart, we need data. And where is the data? Yeah, I'm obsessed with data, as you can see. You have different options to get the data, okay? You can use PageSpeed Insights, which is already adding this breakdown for the LCP subparts. That's great because you don't need to develop anything. It's already built, and you can use it and get the data. But it's synth data, it's lab data. You are getting the results for a particular test run on Google's servers, in this case. You can also use Lighthouse. You will also get this information. Again, you don't need to develop anything. That's great. But in this case, you will get data from a particular test run on your computer. Then you can use the Web Vitals Chrome extension. You can enable that to get this information in the console login. You will have the LCP value, the LCP element, and then the 4 subparts and its values. Again, great. You don't need to build anything. It's already built. But again, you will execute that on your computer, and you will get the data from that particular execution. But you have more options. You can get this data in JavaScript using the LCP API, the navigation timing API, and the resource timing API. So at web.dev, you have this piece of code that you can use to get this data. And once you collect that data, you can do whatever you want. I mean, you can show this, you can display this information in the console logging, or you can add it in a beacon, or you can push it to the data layer, or you can push it to your analytics tool. So that's great. You have the control of the data, okay? And yes, it requires development, but it's worth it. I mean, you can get synth data, because if you are testing it, you can see it in the console log, for instance. But you can also get RAM data. And that's key to identify the actual real users' issues, to prioritize the implementations and fix the issues. But you can also use RAM tools. There are a lot of options in the market. All of them are currently monitoring one of these subparts, the time to first byte, right? But depending on the tool that you are using, maybe you get or not the other subparts. For example, if you are using Impulse from Akamai, currently they are collecting the time to first byte, but later this year, they will implement the resource load time directly from their servers. You don't need to configure anything on Impulse. So that's great. At least we will have more information, right, to go through that. And if you are using Debug Bear, they are also monitoring the time to first byte. But recently, last week, in fact, they implemented the rest of the metrics, so you can see the 4 sub-metrics in the specific experiences. So for instance, you can see here for a specific experience, you have the 4 subparts of that experience of a real user. So that's great. You can go through the worst results and see what's happening there. That will help you to identify potential bottlenecks and prioritize the fixes, right? Yes, time for a break. 2, cancel this. Then, if you are using RAM Vision, they are already monitoring the 4 subparts. You can see it here in the metrics menu. You can navigate through the different subparts, and they also offer in their dashboards the distribution as a percentage distribution, okay? So you can see here, for instance, the first screenshot, the time to first byte is 86% of the LCP, so it's easy to see where you need to focus to start improving that bad experience. In this case, is for a product detail page group. And in the second screenshot, you can see the element render delay is like 51%. It should be below 10%. So yeah, it's really helpful to identify potential issues based on real users' data, right? So, okay, we've seen how to get our data, how to collect our data. That will help us a lot. But also, it's interesting to understand how's everyone doing. So in this case, we can use HTTP archive data, okay? You can query it from BigQuery. And surprise, the LCP subparts are also available. So great, you can create your own custom query to get this data. But to be honest, it's not really straightforward. It's a query party. And here I want to send kudos for Philip and Rick, because they helped me to get this data. And thanks to them, I can share this with you. This is data from the HTTP archive. So you have the different thresholds, the good, the needs improvement, and the poor ones, with the total LCP values, and the distribution of the 4 subparts. And according to HTTP archive data, the most common scenario is the poor one. Okay? You can see here that the good and needs improvement scenarios, the distribution looks quite similar, but the poor one looks different. So we can go deeper and see it as a percentage distribution. And you can see here that even the distribution is not the same. The issues are quite common. In this case, you can see that the resource load delay seems to be the hardest, the biggest issue, okay? Because it should be below 10%, and it's like, yeah, 27, 28, 36% of the LCP values. And after that, the element render delay seems to be the second biggest issue. It should also be below 10%, and it's 18, 16, 23. So it seems like those subparts are the ones that we should start looking at to see if that's also a real bottleneck for our users. But this is lab data. I mean, the HTTP archive data comes from Lighthouse executions, and also remember that the HTTP archive is monitoring just a very few subset of pages for each origin. So it's like limited data, right? It can be really different from field data. And here is where we need to look at the future. So what's next? First of all, start collecting RAM data if you are not doing that yet. We've seen that you can do that with JavaScript, or also you can use several RAM tools, because with this data, based on that data, you can define your hypothesis, and that will help you to prioritize implementations, because based on what seems to be the real bottleneck, we will start addressing that to fix that big issue, right? After that, once it's implemented, it's important to validate in the lab, okay? Before the implementation, we have these values in the lab. Let's see if we are impacting those metrics, those values with what we implemented. And last, but the most important part, validate with field data, okay? Because if you don't see the impact in your real users' experiences, that implementation wasn't useful. I mean, we tried to make the web better for humans, not for tools, okay? But what if I don't have the budget or the resources to get the RAM data, right? Because we've seen that if we need to develop something to get the data and then collect the data and then store the data somewhere to be, available to analyze and so on, or if we don't have the budget to get the proper RAM tool to get this data, so how can we know what's the worst LCP subpart to help us in prioritizing the different fixes that we can implement? And here, I have really good news. In fact, I have breaking news, because coming soon to Crux, we will have the LCP subparts available in Crux. So that's great. Yes, yes. That's the reaction I expect from the web performance community. This is really exciting, because now, I mean, if you don't have the budget to get this data from your side, at least we will have the data available in Crux to identify those potential issues, as we are currently doing with the overall LCP values or with the overall CLS, feed, and IMP, right? So that will help us with the prioritizations and validations and so on. So that's great news, and I'm really happy to be able to share this with you here today. But I have more good news for you. I already traveled to the future and brought back data with me. And this is Chrome data from October this year. This is the LCP breakdown for the good, needs improvement, and poor packets. Again, you have the LCP values and the different subparts. You can see the distribution is a little bit different from what we saw from the HTTP archive data. And as I said, HTTP archive is only monitoring a few subset of pages, also lab data and well, Cracks monitors all the experiences, and lab data and seed data can be very different because of a lot of things. It's not your real users' experiences. And here you have the breakdown distribution. And they are quite similar, the three scenarios, right? The good, the needs improvement, and the poor ones. And we see something similar with what we saw with the HTTP archive data. In this case, the resource load delay also seems to be the hardest part. Remember, lazy loading LCP, I'm obsessed with that. Now you can see that I wasn't wrong. And then after that, the render delay is also like the second biggest issue, because those subparts should be below 10%, and in both scenarios are over that threshold, okay? So, did you get it right? Let's see at the data. Let's look at the data, and okay, you got it right. Good to see. You are really good on that. Again, other people didn't get the right answer in this case. But you can see that the element render delay was the last one. And in fact, it's like the second biggest issue. Okay, so don't forget about that subpart, because it seems to be the second worst issue. And again, when we are trying to optimize images, everybody comes up with the, okay, we need to serve the proper images with the proper size, we need to optimize images, we need to use a CDN, we need to use modern image formats. That's great, but it's really important to make sure that that's the best thing we can do now, okay? Because that's also something that I experienced in the past. Okay, we will optimize our images, and then nothing happens, because we are suffering other issues, okay? In this case, maybe the resource load delay, so we have really bad values because of that subpart. Okay? And in fact, that was really fast, because that was all that I had to share with you today. It was fast, yeah. I'm really good performance, right? I've been fast. So, thank you. I don't know if we have questions here to answer. Thank you. Thank you. Thank you.
Thanks, Estela. That was a really great presentation. You ready for your questions?
Yes.
All right. So in case you missed it earlier, when Estela did her article, it showed different platforms and how they performed on lazy loading their LCP, and Shopify was the worst. I think we were something like 67% of our sites were lazy loading the LCP. And I wanted to say that your data in that article really helped us get that recognition of the problem internally within Shopify, and it helped us to get approval for adding new features to that Liquid API. So do you want to kind of talk about the role of browser data sets like the Chrome User Experience Report and HTTP Archive to find and fix those problems?
Yes, in fact, that's the process that I did during the article that I wrote last year, because data is there, but you need to know where to look at, and then it can be a little bit intimidating querying the data, because it's not as straightforward as a dashboard with everything already calculated. So it can be a little bit intimidating, but I think it's worth it, because as we've seen, in fact, and also you've seen internally, it can help a lot to identify potential issues. And in this case, as I said before, it's really good to have the data, to analyze that, and to talk to people. So that's the key point that I want to share, to encourage people to continue looking at the data and sharing their findings and have these conversations, because all of us can help to make the web ecosystem better, right?
Yeah, yeah. If you're actually more interested in those data sets, Rick Viscomi I guess, does he leave both of them? Barry's also here. You can talk to Barry and Rick. They're from Google. But we can talk more. And also, there's a lot of great resources for helping you learn maybe what queries you need to write. There's a whole Slack organization for HTTP archive. I also really hope that we can get more browsers on board with adding performance metrics. For example, big kudos to Firefox for about to release LCP. But I also wish that we had more. I feel like there's a big gap in mobile, especially for WebKit. But we have some more questions, if you're all right. Any good tips to optimize LCP for a video player or video content?
Oh, that's a really good question. It's kind of hard because yes, it depends a lot on the video, where you are storing it, and also the different subparts, right? And how slow you get the video and it's downloaded and so on. So wow, it's a hard part.
I know. I know. So remind us, are the poster images now used for? So if you have a poster image on your video, that should be used for LCP. So maybe that would make it better.
No, that was always used.
The first frame. Yes,
if you're missing your poster image, the first few frames hopefully will be used.
So maybe if you see some degradation for your video LCP values, probably it's because of that, because it's getting the first frame and it tends to be slow.
Yeah,
so that's
I
bad.
prefer not having videos.
Yes, it's so challenging.
Personally.
Yes.
So this might be a question more for the Chrome team, sorry. But if most of the websites on the web have poor LCP values, aren't the current thresholds too optimistic and unrealistic?
Especially on mobile devices?
I don't know. Do you have any opinions?
I have an opinion, but it's more related to the element itself, because yes, LCP is monitoring the largest element, but sometimes that element is not content. For instance, the cookie notice, the cookie banner, that's not content. But many times it's the largest element, especially, for instance, in Europe, where regulations, you need to accept that you want to store the cookies to start monitoring the user. So that's why we have like those huge cookie banners. And on mobile devices, that's terrible because it's like almost the entire viewport. So yes, that tend to be the LCP element many times for new users. But in my opinion, that's my opinion.
I know.
It's not content from the website. So I don't know. For the user, I mean, the user doesn't count that as the most important part of the page, right?
And in defense of Chrome, I wanted to say that I do know that it was actually, part of it was based on research into human behavior. So it's not just arbitrary and hard to reach, it's actually that people will lose interest and are more likely to switch tasks. So that's part of why those numbers are that way. And even though we might not like that it's difficult to achieve, those numbers are still going to be true. We're still going to be distracted little primates.
Yeah.
I'm getting live notices to please extend the Q&A because lunch isn't ready yet.
Sorry.
It's like red font. So I hope you're okay with some more questions.
Yeah, sure.
All right. So looking through these new questions.
Oh, and if you let me, I want also to say something about the hardest part of all the process, because we've seen how to optimize the different subparts, but in my experience, the hardest part is to convince people, to convince the teams to implement those subparts, those implementations, sorry. And yeah, that's hard. And how many of you have suffered that, that issue, trying to implement something and people, the teams have other priorities, right? So in my experience, it's really important to spread the word, to let them know, maybe even internal courses and talks, to let them know how important is not the core web vitals themselves, but to make sure that the page is fast and that users get great user experiences, because that impacts not only, it's not because we want to have the better code, it's because it impacts businesses.
Exactly.
Right? So we've seen that it impacts on conversions and on revenue and on engagement. So it's really important to spread the word. And once you start, I think in my experience, it's important to maybe pick up a quick win because maybe it's easier to implement. For instance, if you see that you can leverage some quick win techniques, as we saw, for instance, the fetch priority attribute or something like that, once the team implement that and you can show the impact of that implementation, that's amazing how the teams get involved. Once they see that what they are doing is impacting business, is impacting the results, and many times, that's why I'm saying quick wins, because it's easy for them, because if not, it is a huge feature. Sometimes it's hardest to get it prioritized in the sprints and so on. But this kind of techniques is also helpful to get engaged with the developer teams. And also it's really important to know that if the dev teams many times use many anti-patterns as the LCP, as we saw before. But it's not because they want to, do bad things. It's because they think that's the good practice.
Yes.
And here I also want to say something. Maybe it's not really friendly for the Chrome team, for the Lighthouse team, because Lighthouse also encourages to that kind of things. Because okay, you can lazy load your images. But for many developers, that's not clear that they only need to lazy load what is outside the viewport, right? So they start lazy loading everything because Lighthouse says it's good. So it's complicated.
Yeah. I
So
do
it's
think there's
important.
still one gap too right now. Currently, if you do lazy load your LCP, it only flags it on if you did it in a native way. But and this was something. Is anyone still here from the Lighthouse team? We do need to add like the audit for if you if you lazy load via JavaScript library, which I think is still the primary way people are doing it. So if you have like lazy sizes, Lighthouse is currently not flagging that because it's more difficult. You actually have to detect for like data SRC or if a class of lazy load or something. But that's something that we can make sure they know so that they can actually like help spread the word of that anti-pattern. But that was a great note about like encouraging people within your organization because you actually are you're not a performance consultant or on a performance
Hobbs.
team. You're just well, actually, it's kind of similar to us. We're in an organization where they may or may not recognize the value of that work on performance and how do we understand what is motivating different people so that we can get them to advocate for change as well.
Correct. That's the point. That's why I'm saying that spreading the word internally and talk to the dev teams, talk to the product owners also to let them know why is this important, even if it's not like the new bug fixing or feature for the new, I don't know, they want to implement something for the user flows or whatever. So, but it impacts businesses and money, and that's important.
For sure. I have a note that suggested sword fighting. I think we'll skip that one for now. Is there a way to avoid or exclude LCP on cookie banners in RUM, or are we limited here in using lab data to get around this? I also don't know if you want to. I don't know. Like,
I don't know, depending on the tool, I don't know how
or
they
for
are
me,
really
like the
storing
cookie banner is a problem still, so I don't want to forget that that's a problem.
There are some workarounds, in fact, because the cookie banner is the LCP element many times because we have like a huge piece of text, right? But if you split the text into separate paragraphs, and all the paragraphs are smaller than maybe some content you have behind the cookie banner, maybe the H1 element, then the LCP element will be the H1 instead of the cookie banner because you have split it into separate parts. But it's a workaround. I mean, that won't fix that the cookie banner is really slow to be displayed in the screen, right?
Yes, for sure. So we have another question from Stuart. Could you expand more on business change? Any experience in relating LCP to revenue directly?
Oh, that's a really good one. It can be quite complicated. In my experience, we are a B2B company, so our public website is like a public catalog of the products and the services, so it's not directly converting because we have like we have the e-commerce part for B2C, and we also have like an internal application for clients to do their stuff. So it's not impacting the sales of the company, the web performance in the public website, but it will help your clients go through the, to be more engaged with your product and your catalog. And whatever they need, they know that it will be fast to get the information. So that can help to have happy clients, in fact, even if it's more complicated to measure that, right? But in fact, you can directly ask them, because you can pop-ups with surveys asking them about the experience and so on. So if you implement web performance improvements and then those surveys show that they are more happy than they used to be,
Yes.
that's something that you can correlate.
Yes, yes, definitely. Yeah, I know it's a little bit easier at Shopify because we can actually like pull up conversion rate and bounce rate numbers. So
Yes.
usually it's a pretty easy sell. Although I will say it varies a lot by like type of merchant and what they're selling, for sure. All right. So how relevant, I'm not sure I fully understand the question.
Okay, let's see.
How relevant is LCP compared to other metrics for apps? Like long-lived behind a login screen. Maybe they mean like web applications. So like, is LCP still relevant maybe for more application-like experiences? Maybe that's the question. We'll just go with that.
I don't really know. Yes. I mean, when a user interacts with an application or a web, they are interacting with a digital product, right? It doesn't matter if it's a web application, a native application. So those core web vitals are here to help us measuring the user experience. So I think it's relevant also in any context, even if we can't measure as we are doing on websites, right?
Yeah, they're still like, they're still apologizing to me that lunch isn't ready yet, but we are early. We can chat about other stuff though. We don't have to keep grilling poor Estela here. I'm like, are you ready for your 50th question? I don't know. What else is going on?
Well, in fact,
what's your favorite Back to the Future movie? I actually think that was a real question in here.
the first one, of course.
The first one. And why is that?
Good to
Why?
know. Well, because it's the first one, and it's the first time that you get involved with
Oh, yeah.
with all these things and with the the characters and so on.
And the world.
the cast, yes, and the DeLorean, of course.
Yes, yes.
So that's great.
Have you seen a DeLorean in real life?
No, never.
I feel like
Sadly.
they pop up sometimes in the U.S. Do they ever pop up here in Europe? No? All right. Should we break? But the food might not be ready. But you can start queuing in line for the toilets. remind.
Have a short play.
A short.
Short play.
Oh, another. Did you bring the swords? Where are you, Robin? Robin disappeared.
Another battle.
Oh, I forgot the toilet announcement in the morning, and I did have a joke about, because we're supposed to say keep your timed or interactive to a minimum. So perhaps don't wear inappropriate clothing for being able to actually use the restroom quickly.
That's challenging.
I don't know. I do have some jokes. They might have a bad word in them. Is that okay? Okay. So with JavaScript, I want to say fuck this, but I don't actually know what this is. Do you have any jokes? I feel like we've worn her out. Okay, about 5 more minutes for lunch to get ready, but you can like meander around, chat, use the toilets, go read the code of conduct. And yeah, we'll be back here at, hold on, I gotta get my notes. We'll be back here at 1:55 or 13:55, depending on what you recognize. And remember to stop by that performance help desk. And also Sentry is upstairs too, so you can stop by them. There's also a job desk. And remember the secret line I told you about. And again, no Greek party downstairs. Only cardboard plates and cups. No breaking of plates. has some tasty nibbles. I don't know what else is up on the menu, but I've been happy so far. So if you're not happy with your current job, there is a job booth up there at the top of the stairs. However, if you actually like your team and would like a photo with them, at the next break, they're going to do photos up here on the stage. So that's how your boss will know if you're looking for a job. My boss is over here. If you're looking for a job or not, as if you show up for the picture. Anyways, but for real though, if you want a group photo with your team or whatever, please come up at the next break up to the stage, and the photographer will do pictures. All right, for our next speaker, Harry Roberts is an independent consultant and web performance engineer. He's helped some of the world's largest organizations with their web performance. He also just celebrated 10 years as an independent consultant. Woo! You can help him make it another 10 years if you hire him. He's also a Google developer expert in web technologies and a Google Cloudinary Media Ambassador. I forgot what they changed the name to. It's one of those things. And when he's not hustling, he's riding bikes. Harry, everyone give him a round of applause.
Thank you so much. Thank you. All right, this is a really sort of dense talk, so I'm going to dive in. Not much of an introduction. We are going to be talking today about browser cache. We won't be, because my slides aren't working. Apologies, let me just see what's going on. You getting anything down that end? I'm just not getting anything. Right, okay, sorry about that. So today, we're going to be talking about browser cache, or technically, I suppose, HTTP cache. The browser's got loads of different caches in it. I want to talk about HTTP cache. The reason I want to talk about it is because something I see time and time again is developers sort of misunderstanding and misconfiguring cache. It's actually way more simple than people realize. But I feel because so many browsers, or all browsers have a browser cache, and it's omnipresent, that developers kind of take it for granted. They assume it's always going to be there, and that it's always going to work. The amount of rhetoric I get from developers, oh, I don't care if we've got a 2.5 megabyte bundle, we cache it forever. I look at their headers, I'm like, you don't. So a lot of my work recently has been helping organizations, engineering teams, learn how to set caching headers appropriately and just really, honestly, streamline it and simplify it. I think what we're going to find out is it's way easier than you realized. So quick show of hands, honest show of hands, please. Who thinks, and obviously with a crowd like this is going to be quite a lot of bias, but who thinks they've got a good handle on caching headers and they kind of understand it really well and it's set up pretty... Okay, well, that's less than half, actually, so that is an honest show of hands. Who thinks caching headers are sometimes contradictory, confusing, right? Do you know what? Until early this year, me too. Part of my research for this talk and the work I've been doing with clients has been all about just simplifying the process. And I promise you, it's going to be way easier than you realized. For anyone in the room who didn't put their hand up but is thinking, oh my God, a 45-minute talk about caching sounds so dull. Yes. The slides are already online. If you want to follow along, there'll be certain sort of header snippets, code snippets. If you want to follow along, grab a quick photo of this. The slides have already been published, so you can take a look there. Real brief intro. So I'm Harry. I am a sort of independent web performance consultant, which means I help organizations like these with finding and fixing site speed issues. Now, this is a very immodest slide. This is kind of my highlight reel of my client list. But the nice thing about this talk, it's nice to write your own reviews, isn't it? The nice thing about this talk, the thing you will enjoy, it doesn't matter how big or small you or your website is, every website will benefit from having its caching headers set up properly. So this isn't reserved for the elite or for enterprise. Any site of any size will benefit from this. There's a saying in our industry, and you may have heard it before, the best request is the one that's never made, and it's true. You can completely zero out the network cost of certain requests if you get stuff set up properly. The problem is, and I keep beating this drum, most people aren't doing it properly. So by the end of this talk, you will have a strategy in place to get everything running smoothly. Before we dive right in, I want to get some key concepts sort of discussed and understood. It's going to help if we've all got the same shared knowledge before we start to pick these concepts apart. The first and probably most obvious concept is caching itself, and the sort of sister concept, which is revalidation. Caching is how long can I reuse this file without checking for updates? And this is the key bit, without checking for updates. A big misconception that I see is that developers tend to believe that you can cache a file for a week, but as soon as you update it on the server, the user will get a brand new copy of that file. Not the case. If you tell a browser you can cache a file for a week, and you change it after an hour, you need to accept that your users are going to have that file out of date for 6 days and 23 hours, right? It's on you. So it's the biggest misconception I see is the belief that you can simultaneously have cached content and always the most up to date. It's not possible. Revalidation, on the other hand, is how do I check a file has changed after my cache time limit is up? And that's, again, a really key concept. Only after the cache time limit is up. You have to accept the inevitable fact that for a period, users will probably have somewhat out-of-date content between sort of your release cycle and then the sort of cache expiry header, or the cache control header expiring. If you think about it, caching is a way of preventing a client speaking to a server. So in a sense, cache busting is kind of almost impossible. Caching is a way of stopping a browser talking to a server, so revalidation should not happen while a file is cached. If you're seeing revalidations while a file is cached, you've probably got a bug. Something's misconfigured. You shouldn't expect to see revalidation while a file is considered fresh. That brings me on to fresh and stale, two concepts here. When we talk about files in cache, we split them into two buckets. Fresh is a file that is in browser cache and still within its expiry date. Fresh does not mean it's the most up-to-date version of the file. What fresh means is it's in cache, and as far as the cache is aware, it has the latest version. It might not do. The origin server might have an update, but the cache is blind to that. The cache cannot see it, so it will still consider the file fresh if its expiry is still in date. The flip side is stale, and this is a file that is in cache, but it has passed its expiry date. So this file may not be out of date, but its expiry has been reached. Therefore, we need to revalidate. The key thing I'm trying to impress upon you here is that fresh does not mean most up to date. Fresh simply means the cache thinks it has the latest version of the file. It might not do, but we've told it that it can reuse that file for X amount more time. I've been using the word file quite a lot, and really what I should be saying is request and response. So we're not talking about files necessarily, we're talking about responses. When we talk about sort of caching, we're looking for a request that goes out, a response comes back. We use the word response rather than file because the response might be a 404, which literally means there is no file. So technically, throughout this talk, when I use the word file, what I should be using is response. That brings me on to the next concept, 200 and 304 responses. When we talk about caching, these are pretty much the only two response codes that we care about. 200 is, yes, I fetched a full response. And that could be a response that came all the way from the server, or it could be a response that came from the browser cache. One thing I find quite confusing, and one thing I would like to see is there is no separate response code for a file that came from browser cache. I'd like to see another 20-something response code that says, we fetched a full file, but not from the network. We fetched it from cache. The only way to proxy this would be like looking at the transferred size of the file to ascertain whether it came from the network or from the cache. A 304 is I checked with the server, and you can reuse the old response. So 304 just says, hey, look, the file went stale. I went back to the server. The server says the one we have in cache is still good to use. And then you kind of renew the usage of that file. So 304 response is, we went all the way back to the server with a conditional request because the cache believed the file to be stale. It got to the server, and the server said, yeah, there's no change on this end. Go all the way back to the machine and pop that file back out of cache. That will not return a 200. That will return a 304, a revalidation header. When we look at solving problems, I find it easy just to simply remove them. So the first thing I want to step through, and actually a lot of the content of this section came from our very own Andrew Betts, just down there. He wrote an article for Fastly a few years ago, which he looks at all the redundant and unnecessary HTTP headers that responses tend to carry. So the simplest thing we need to do is just get rid of a bunch of stuff. Pragma. The Pragma header is technically kind of a bug. This should have never happened. This one definitely needs to go. Pragma no cache would be the most common thing you would likely to see if you see a Pragma header at all. And this simply should have never happened. It's not meant to be a response header at all. It's been misused. It mainly exists to fix compatibility with HTTP 1.0, and given that we're on H3 now, this is a header we simply do not need. It should not be used. The spec even says Pragma is not specified for responses and is therefore not a reliable replacement for the cache control header. Pragma as a response header simply should have never happened. If you've got it, remove it, get rid of it. The next header we can get rid of, surprisingly, is expires. We don't need expires headers. You probably see these. These are really common. They're not terrible. The expires header isn't a bad idea. We just have way better options available to us now. An expires header would look like this, and it sets a fixed date, hopefully in the future, at which the browser or the cache should consider this file stale. Problems with the expires header there's two. It's not extensible, so all it does is says when the file expires. We can't extend it with additional directives. But the other problem is, and I don't have a visual for this because I kind of only just thought of it a few days ago. I didn't put it into the slides. This file expires New Year's Day next year, 1st of January. I could put a file live and say, right, this doesn't change very often, so I'm going to expire it in a few months' time. What if I take a few months off work? I don't work on this site, I don't deploy anything. On the 2nd of January, anyone who requests that file now has a date in the past. That file is impossible to cache. That's the key problem with the expires header, is that as soon as you pass that date, a date in the past is effectively a no cache, or no store even. So the expires header, we can replace that now. It is a caching header. It's not harmful, but cache control is better. Cache control has been the preferred method of specifying cache rules since 1997, right? A long, long time. It's also susceptible to clock date mismatches. It doesn't really happen anymore, but if you're like me when you were a teenager and you kept putting your system time back 30 days to keep using Photoshop, keep that free trial going, that would break your caching, right? If you keep changing your system time, it can affect caching the expires header. Even the spec says if there is a cache control header with a max age or max age directive, then expires is ignored. So if you've got a cache control header with max age, you don't need to remove your expires header. I mean, you might as well do just for the sake of cleanliness. But because it has been superseded, the presence of a max age header will immediately just nullify the expires anyway. The way I would think of it is cache control does everything that expires does and more. They solve more or less the same problem, but cache control has more directives, it's more extensible, it can do more things. The other header we can get rid of, we don't need, is last modified. And this might surprise you. Last modified is very, very common, but it's again susceptible to certain issues and problems, some little gotchas. Last modified simply says, this file last changed on this date. And the browser or the cache can then decide, well, if it last changed then, and we've gone past that now and the expires has been reached, I'll go back to the server and see if it's been changed since. So last modified is a revalidation header. So expires is a caching header, last modified is a revalidation header. Again, it's not harmful, but we've got better options or alternatives in ETAG. Date of change, and we'll come back to this later in the talk, the date of creation or change of a file is only a proxy for if the file changed. I'm still running a really old school sort of setup for my website, so I'm using GitHub Pages. GitHub Pages, statically generated. If you change just like a single typo on your homepage with GitHub Pages actions or GitHub Actions will rebuild the entire site. So that one little sort of typo change in your footer on your homepage will generate brand new last modified headers for every single page on the site. So that's kind of a problem with last modified is the date a file changed or was written to disk isn't actually a reliable proxy, and it's a proxy at best for if the file changed or not. So last modified is open to false positives. Again, it's not harmful, but we have better options. So on the flip side, headers that we do need, and it's nice to sort of know, or you'll be pleased to find out, we don't need many. We only need 2. To get your caching set up properly, we need a cache control header, which hopefully you've seen before. Cache control private, max age 300, must revalidate. Cache control is the header. Each of the comma delimited things in here are directives, which is what makes cache control extensible. Cache control is a caching header, it superseded expires 6 years ago, is that? A long, long time ago. These are the rules and conditions around which a cache may or may not store a response. That's the one header we do need. The second header we need is ETAG. ETAG is a revalidation header, and it can look like this. This is a weak ETAG. And basically, this is going to generally be a hash of a file. A weak ETAG is generally an ETAG that's generated on a hash of the metadata of a file. Think about it like an analogy for thinking about weak and strong ETAGs. A weak ETAG like this is like a book's title. There may be many different authors around the world who've written completely different books that happen to share the same title. That's kind of a weak identifier. The ISBN number of a book identifies that specific book by that specific author, despite its title It's always going to be a unique identifier. That's how you'd consider a strong E-tag. That's the analogy that I use to sort of explain this to people in workshops and clients. A strong E-tag, again, is usually going to be a hash of a file. It doesn't have to be, but a strong E-tag is usually going to be a checksum of the entire contents of a file. This is a very reliable tell or clue. Well, not clue, I guess, a very reliable answer to the question, did this file change? So E-tag is a revalidation header. Remember, we've got the two concepts of caching and revalidation. We need a cache control header to solve the caching, a revalidation header, which is E-tag, to solve revalidation. It's slightly more reliable than last modified. As I discussed, you can get false positives with last modified. If your build system touches every file, last modified wouldn't be a good indicator of freshness. E-tag is much less susceptible to these false positives. So if we want to set our caching strategy up, we've got loads of different questions we can sort of ask ourselves to help get the right answer. It's not an interactive quiz. We simply don't have time for that. But what I'm going to do in the next section is I'm going to ask questions. And what I want you to do is just turn to the person next to you and see if you can get the right answer. What we're going to do is we're going to solve our caching headers by looking at different scenarios. If the scenario is X, what header would I need? So that's how this next section is going to work. We should have enough time for it. The question is, can this response be cached at all? If yes, what header would we expect? And if not, what header would we expect? So take a couple of seconds, just chat to the person next to you and see if you get it right. You don't win anything, by the way. But if you think you know the answer to this, show off to the person next to you. There's a lot of silence. We're just not sure. OK, if we can store this response, we'd probably just use something like cache control with a max age. One thing I should say is every single number in these slides is just an example. Don't go copy and pasting anything from my slides. These are just examples for example's sake. Can this response be cached at all? Yes. So you might put a cache control header with a max age of, what's that, an hour, 3,600 seconds. If you can't cache the file, you would simply use cache control no store. So we've introduced two new concepts here. The first concept is max age. This is sort of equivalent to the old expires header. This is basically how long can I store this file for? How long can this file be reused? It's a value in seconds. It's relative, whereas expires is absolute. So the way you should think about this is the expires problem is if I say a file expires on New Year's Day next year, but I don't update the file until sort of February, for that month in between, an expires header would be in the past, which effectively prevents anything from caching it. Because the expires header is relative, there's always going to be another week, another week, another week. You never need to re-emit different headers when you change the file. You can always sort of renew. It's always another week. And that's the benefit of having a relative caching strategy rather than absolute. It's relative to the moment it entered the browser cache, so it's not relative to the date the file was created. What this means is people's copies of a file will all expire at different times. If we all visit the perf.now site on different days next week, we can expect our assets to expire at different times to one another. Also, and it's not in the slides because I've sort of trimmed them down a bit, it's when it first enters a cache is when the sort of max age starts counting down. If you've got a file that left origin and stayed in a CDN for a week, it would then get the CDN should add an age header, which is a time in seconds that tells you how long that file was in the CDN's cache. Then when the file makes it to your browser cache, the browser will subtract age from max age and start counting from, it basically takes into account the CDN time as well. So if you see the age header, and this only really applies to people who are configuring CDNs, age header is a header you would need if you're using a CDN, which of course we all are. So like I said, everything in this slide deck is an example. Please don't copy and paste any facts or figures. They're just examples for the sake of it. I'm not responsible for you getting into caching nightmares. The next directive is no store. No store is a very strong directive that says no cache may store this file or this response at all. That's all you need. People really tend to overcomplicate no caching. Any spec-compliant cache, all it would need is a no store directive to say you may not store a copy of this file. A lot of people go all in, no cache, no store, must revalidate. Technically, these two are redundant. You just need the one in the middle. You just need no store. Any spec-compliant cache will just refuse to store anything with no store. There's talk about allowing back-forward cache to sort of cache no-store responses. It's kind of a hotly debated topic. I don't think it's necessarily the right decision. But certain caches, back-forward cache, there is discussion to allow back-forward cache to store no-store responses, but as far as I'm aware, that's not yet the case. There is discussion around it. Next question. By the way, at some point, these questions get really convoluted because the level of question you have to ask in order to get one of the answers I want to give you, some of these questions get really convoluted. Does this response have to always be perfectly up to date? So at the beginning of the talk, I said that if you cache a file for a week, you should expect it to be in cache for a week, regardless if you've updated it at the origin. You can always expect some out-of-dateness. If you're in a scenario where you cannot accept any out-of-date content, if the file has to always be perfectly up to date, again, just chat to the person next to you nearby. What header would you use if the file has to always be perfectly up to date? OK, this answer, this one, do you know? The answer to this one is a little confusing. No cache, right? No cache doesn't mean you can't cache this file. What it means is you can't go to the cache before revalidating this file. So it's a little confusing. No cache does not mean that you may not cache this file. What no cache says is you can't go straight to browser cache. Always go back to the server. If there is an update, get me it. If not, I can then use a file that came from browser cache. This is a way of guaranteeing the file always has the most up-to-date content and, in certain scenarios, still benefiting from browser cache if the file hasn't changed. If the response doesn't always have to be perfectly up-to-date, think of like an image in a blog post. It doesn't matter if it's not the most up-to-date copy of that image. Again, you would just use a max age with whatever time you desire. I've mentioned a bunch of times that these numbers are just examples for the sake of it. Towards the end of the talk, I've got a little bit of a cheat sheet to help you decide roughly what kind of time spans we should look at for caching headers. But until that point, just treat these as examples for example's sake. The next one, the concept we introduced there was no cache. And again, no cache doesn't mean you can't cache this file. Confusingly, it means you can cache this file, but don't go to the cache for the file before going to the server. So this pattern we had before, where we can reuse a file from browser cache, is now forbidden. We cannot do this anymore. With no cache, this is just not a possible paradigm. This is not a possible pattern. So no cache forbids the browser going straight to cache, always makes a trip to the server, which means it always incurs at least a round trip of latency, which therefore means you might not get much of a performance benefit from your cache unless the file was rather large. Most of the bottleneck on the web is latency bound, and if you have a no cache directive, you're always going to have at least a round trip of latency to the server to revalidate that file. If the file was only a few bytes anyway, there's no real benefit to releasing it from cache. You still incurred a full network round trip of latency. So unless the file is quite large, you won't get much of a performance benefit from caching if you have no cache responses, headers on your responses. Can this response be shared? Can the same file go to many different people? If yes, again, turn to your neighbor, see if you know the answer. Can this response be shared? Can this file be used among many other people, or is this file unique to one specific user? If a file can be used by multiple different customers, users, visitors, think of a style sheet. You wouldn't want every customer to have their own unique style sheet. If you're on a news website, you don't want the image on your news article to be unique to every person. You want to have one image that everyone sees when they visit that page. If you have files that you want everyone to benefit from, you would use the public directive. Cache control public, and then complement that with whatever max age you desire. If a file is unique to a user, maybe it contains a logged-in state or some sensitive information, a file is only allowed to be seen by the individual person requesting it, you would use the private directive. Private simply says this file, this response, is only to be used by the cache or the client that requested it. Interestingly, you don't need public at all. This is sufficient. The appearance of a max age directive implies public anyway, and actually public comes with side effects. So public can have some nasty side effects that you might not be aware of. One of them is if you've got a basic HTTP auth, you've got a login, maybe a staging site behind a simple HTTP auth. If you put the public directive on cache control, a logged-in state will now start to enter public caches. If you leave public out, I know it's Phil's face, it's terrifying. It's a really weird side effect. If you put a public directive on a response that also carries an authorization header, you would assume that logged-in state is unique to the person who had logged in. Public will allow that response to enter shared caches, which is exactly what we don't want to do. So public is implied. and if you actually explicitly put it in there, you will run into side effects that you likely don't want. So I would always just advise leaving public out, because it's implied. If you need private, definitely put that in. So, do you want many people to have access to the same file, like a style sheet? This exposes cacheability to intermediary caches. For us, we're mainly talking about CDNs there. It's implied by the presence of max age, so it's redundant. Public, sort of diagrammatically, would look like this. You've got a file on origin. Someone requests it, it passes through your CDN. A copy of it stays there, and a copy goes to this person, this person, this person. That file stayed in a shared cache. Private forbids that. Only the requesting client may store the response. It prevents data leakage. It prevents people seeing things they shouldn't see. There was a huge, it was Christmas Day a couple of years ago, or many years ago, Steam. This isn't I don't do any gaming, so this story is like secondhand, but someone was telling me a story about there was a huge rush of traffic to the Steam sort of gaming platform. People like want to spend their Christmas money on games, whatever. Don't want to talk to their family on Christmas Day, I get it. Flood of traffic to the Steam servers, so they quickly spun up some caching layers, like we need to get some caching, we need to protect origin, we're getting way more traffic. They inadvertently snuck a public directive into their cache control headers. People were seeing other people's sensitive information, to the tune of tens of thousands of responses. People could see people's logged in states, their account status, their like sort of financial, like credit card information. It was a real big problem. I should have actually added that into the slide. Someone told me about this story about a month ago. But yeah, you need to be really careful with this stuff. So data leakage is definitely can happen if you configure these improperly. So private, diagrammatically, the file will pass through your CDN. It will leave origin, it will pass through your CDN, but it won't stay there this time. That response is going to be unique to every person that requested it. The file never stays in the CDN. Okay, right, told you these questions got a bit convoluted. Can we reuse this response for offline users even if it's out of date? Can we reuse this response for a little bit longer even if it's gone stale? If yes, what would we do? This is an unusual scenario, but basically it exposes a bit of a quirk in HTTP cache. There is a scenario in which even a file that has gone out of date can be released from cache. Even if the max age has been met, the cache can be released a stale file in certain conditions. If the file can be reused for a little bit of time, if the user's offline, here's another way of thinking about it. When you're on an airplane, you've got no signal on your phone, but you open your phone, you open your browser, and there's a page still out. It even looks like it reloads, but the page remains on your screen. That's because browsers in an offline state are allowed to release files from cache even if their max age has been met. That explains that phenomenon. When you think, how is that page just refreshed even though I'm completely offline? It's because browsers are allowed to release files from cache even if their max age has been met. So if we are OK with that and we think, well, if we can just reuse this file for a little bit longer after it's gone out of date, just leave it alone. Just put your max age and that's all you need to do. If you think that is completely unacceptable and you never want a file to be reused if it goes out of date, if you always need to make sure that as soon as this file goes stale, we need to go back to the server, you put a must revalidate header on there. Must revalidate says to the browser, you cannot use, once that 3,600 seconds has been reached, you may not use this file without going back to the server. The top one exposes an implied behavior in HTTP caching, which says that actually in certain scenarios, browsers can reuse files even if they've gone stale. That scenario is usually a scenario in which the browser can't reach the origin server. So must revalidate. Caches are permitted to serve stale content unless explicitly told otherwise, for example, if a browser's offline. Must revalidate prohibits that behavior. The spec says HTTP allows caches to reuse stale content or stale responses when they are disconnected from the origin server. Must revalidate as a way from preventing that. So if you want to guarantee that no one ever sees anything after it's gone stale, stick a must revalidate directive in there, and that's how you shield yourself from that. Whew, this is a big one. Can we tolerate slightly out-of-date content, a slightly out-of-date response, while we perform revalidation? Anyone know this is kind of a new one, so if anyone knows what the answer is here, I'll be quite impressed. Anyone got any idea how to solve this one? Can we tolerate slightly out-of-date content while that revalidation happens? I heard a couple of people murmuring it. So basically, we've got a relatively new directive called stale while revalidate. One problem with revalidation, when you're talking about caching, is it is synchronous. You might have a web page that you visited before. There's a CSS file in your browser cache, but the max age has been met. What happens is the browser will say, well, the max age has expired. I need to go back to the server. But because CSS is render blocking, what's going to happen is while the browser goes all the way back to the server and says, hey, is there any updates to this CSS, the user just sees the blank screen. That revalidation is synchronous. Even worse, if the server comes back and says, you could have used that file all along, that synchronicity was completely blocking and for no real reason. So what stale revalidate does is it permits a grace period. What we're saying here is, for 600 seconds, you can reuse that stale bit of content, but make sure you're revalidating it in the background. If we don't want this, we would use max age 3600. We'd use a max age with whatever number. Stale while revalidate, again, is fairly modern, fairly recent. It's fairly well supported, though, so definitely recommend using it. I've been working a little with Cloudinary, and for their use case, an image CDN, you can normally tolerate slightly out-of-date imagery, right? Unless you're, well, for most use cases, you could look at an image that's like 10 minutes out of date, right? So Cloudinary, we're about to look at adding stale while revalidate to Cloudinary's image responses because, okay, if the image is stale, we can look at it for another few minutes, right? We can tolerate that for those kind of responses. So stale while revalidate basically forces the revalidation to happen in the background. So this is in any use case where we can sort of make do with even if we know it's out of date, we know it's stale, we can tolerate reusing it for a specified grace period. What this means is we immediately get a 200 response. The file's going to be released from cache. But in the background, we send a conditional request to the server, and the server will respond either with that 200 or 304. It might respond with the 200, which says, yep, you did need a new file after all. Here it is. Take that one out of your cache, the old one, and put the new one in. Or it might come back and say, you could have reused it anyway. I'm glad you did. Do we need to configure browsers and CDNs differently? Do you need different caching rules for your CDN to your browser? Anyone know what we might use in this use case, this scenario? Yep, I heard that down there. If we need to configure our CDNs and browsers differently, we would lean on the S max age. S max age, the S stands for shared, so shared caches. Also, this is really frustrating. It's like the whole referrer problem. There's a hyphen in max age, but there's no hyphen in S max age. It's really annoying. But yeah, you'd use the S max age header to configure a CDN or an intermediary shared cache differently to your end user cache. What we're doing here is saying, well, a user, a visitor to your website, can store a file for an hour. That's 3,600 seconds. A CDN can keep the file for a whole day. That's 86400. If you don't want that, if you just want the same caching rules everywhere, you wouldn't use S max age. You would just fall back to using max age on its own. So S max age, shared max age, with that annoying pesky hyphen problem, answers the question, why would you want to configure your shared and private caches separately anyway? I didn't know the answer to this, and I believe it was Barry Pollard who gave me the answer on Twitter. I couldn't find the Twitter thread. Basically, cache busting is a bit of a myth. If you think about it, cache busting is a myth. We've discussed you can't just until a file gets revalidated, you can't just lean into a browser and say, purge cache. As a side note, you can. There's a clear site data header you could use. But for the most part, purging a user cache is very, very difficult. Cache busting is a bit of a myth. Purging your CDN cache is really easy. You just log into whatever CDN you're using, purge all. You can empty your CDN cache whenever you need. So S max age allows for different layers of caching. Because you can't empty users' cache, or you can empty your CDNs, you could clear your own CDN cache every time you deploy. We could have maximum 1-hour-old responses for customers, for visitors, but we could avoid coming back to origin until we deploy, or just once, for example, once a day. So the use case here would be the visitor goes back to the CDN every hour. The CDN only goes back to the server, goes back to origin, either daily or whenever we roll a release. This helps you shield origin. It also means that users don't have very, very stale content, mainly or sort of mostly an hour-old content. But every time you roll a release, every time you deploy, you can purge your own CDN cache. That layered caching strategy is really quite elegant. Is the file hashed? Quick show of hands. Whose build system puts fingerprints in their file names? That's not enough. OK, well, get this configured. This is really important, but it also allows us to use some really powerful, aggressive caching strategies. If your build system puts fingerprints or even just version numbers inside your assets, you can cache these things really, really aggressively and basically forever. Cache control max age, and in a 32-bit world, forever is that. That's 68 years, just over. And immutable. Immutable is a relatively new cache control directive that says, this file never, ever changes. This file is immutable. This file is never going to change, so never bother revalidating it. This was sort of developed and worked on by Facebook in like, I think 2015, so it's been around for a while as a concept. If you've got hashed files, you can stick immutable on there, and you can put virtually whatever number you like in the max age field. If not, you'd set a cache control with whatever number you need, but without the immutable. So immutable, like I say, relatively new. It makes a contract with the browser. What immutable does is it tells the browser, this file never changed. If you think about it, a hashed file, if you change it, the hash changes, therefore the file name changes, which means you don't have that concept of that file disappears. Hashed files, their content literally never changes, so they literally never need revalidating. That's the beauty of immutable. It prevents browsers. It makes a contract and says, this is never going to change. Please don't bother coming back to the server. How long is forever? So I looked into this recently, and I wrote a little blog post about it. The spec doesn't actually specify what a forever is. But in a 32-bit world, the biggest sort of number you can store is this. Well, it's stored as 10 and 31 ones. If that was 32 ones, that would be negative 2 billion or trillion or whatever that is. In a 32-bit world, that's the biggest number you can sort of store in binary. Technically, though, the spec says you can pick any number you like. That could be 1,000 nines. There is no maximum value for max age. You can put it as big as you want. What the spec says is any cache should store the biggest number it knows how to store. So if you put 1,000 nines, but the cache can only do 2 years, the cache will do 2 years. The cache should always do whatever the maximum it can do. Ideally, what's been specified in the header, but whatever the maximum it can do is what the spec sort of not permits, but suggests. Back with the expires header, it was the spec said that caches should treat forever as 1 year, and that's why we kind of standardized on that the 1 year caching. Turns out the spec says we can cache things for literally forever. Whew, right, so we've solved caching. We now need to solve revalidation. What do we do after that file's gone out of date? What do we do after that file's gone stale? Technically, quite interestingly, we don't actually need revalidation. What we could do is just be wasteful and say, right, well, this file's max age is expired, so we'll just go back to the origin and re-download the file regardless of if it's changed or not. This would work, but it is wasteful. What you should think of a revalidation as is a renewal. It allows you to continue using a file and just update its caching headers appropriately. But technically, if you think about it, we could just be very wasteful and say, well, this file's expired. I'm not going to bother checking if it's updated. I'm just going to assume it has. I'll re-download it. And you get lots of false positives and transmit wasted bytes. So yeah, you could always just fetch the whole response without checking if we actually need to. That's not very much in the spirit of web performance. That's quite wasteful, so we shouldn't risk that happening. So revalidation headers, we've got options. We've already discussed we shouldn't really use last modified. It's susceptible to false positives. We should be using etag. Both of these will cause the browser to emit what we call conditional requests. If you have an etag or a last modified, the browser will emit a conditional request that says, hey, have you changed? So in this scenario, what would happen is we will get a conditional request to the server. If the file has changed, so if modified since or if non-match, we'll get a 200 response. If not, if it's 304 response, that file comes back from browser cache. Like I say, technically we don't need to do revalidation. We could just always fetch the full update, even if it hasn't changed. But this just avoids being that wasteful. So a conditional request will dispatch a request with a header, like if non-match, if the response had an etag. If we use last modified, it would dispatch an if modified since. If your build system has both etags and last modifieds, they'll both get dispatched. And if even one of them matches, even if one of them resolves to true and it has changed since then, it will take that. So even if your etag hasn't changed, but your last modified has, the browser, the cache will always request the new file. So if you do have both, you can run into conflicts. If it's true and it has changed or it doesn't match the etag, you'll get a 200 response. Here's your new file. On the flip side, if the file hasn't changed, can be reused, you get that 304 response. We prefer etag. I mentioned this briefly already, but last modified changes whenever a file is written, even if its content hasn't changed. Etag should be a checksum of the contents of the file, therefore won't change unless the actual content of the file has been updated. It avoids false positives and wasteful 200 responses. So just to show you an example, this isn't how it works, but as a model, as a little demo, all we've done here is create a file called revalidation that contains the string hello world. We can see its last modified was blah, 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 37 minutes, 50 seconds. The MD5 checksum what's that, 6F5902. The checksum is that. We rewrote the exact same content into the exact same file. The last modified has updated, but the content hasn't. The hash remains the same. This is the false positive situation you run into if you're relying on last modified. The next thing we're going to move on to, and I've already mentioned this already, but don't revalidate hash responses. Hash responses don't need revalidating. If you've got a fingerprint in the file name, it never needs revalidating, so don't put an e-tag on that response in the first place. There's no point attaching revalidation headers to files that we don't even revalidate in the first place. So it won't be sort of troublesome, but there's no point emitting a revalidation header if we've also told the browser not to bother revalidating the file. Because hash files never change, there is no need to revalidate them. All right, so I've got a couple of minutes left just to wrap up. That is a fairly dense talk. There's quite a lot in there. So just to recap, what have we learned? First thing I want you to take away from this is we should not expect to fetch fresh content if a file is still within its fresh period. If we are getting revalidations while a file is considered fresh, we've got a conflict somewhere, we've got a bug. We shouldn't expect to be able to fetch new content while a response is cached. It's the kind of trade-off we make. If we decide to cache a file for a week, we have to admit that that file could be out of date for a week, or 6 days and 23 hours, right? The other thing is, we only have 2 jobs, caching and revalidating, so we only need 2 headers. I think the biggest sort of thing we run into when it comes to configuring caching is that there are so many headers available. Which one do we need? Do we need all of them? We've only got 2 jobs. We only need 2 headers. That would be cache control and e-tag, and technically, if the file is fingerprinted, we don't need the e-tag. So in that scenario, we only need 1 header. Expires, caching headers, and last modified revalidation headers aren't bad, but we do have way better options in the form of cache control and e-tag. Files that never change never need to be revalidated. Those are the main takeaways. The whole section in the middle of the talk with the different directives, those fit specific use cases. You can refer back to those in scenarios that match your use case. Really quickly, handy cheat sheets. So just to give you an idea of what kind of time frames we might be looking at for these max age values, and again, these are examples. Think of like never cache a file, cache it for a short amount of time, medium, long, or forever, and you're thinking in like minutes. Can we cache a file for a few minutes? Possibly. So, for example, excuse me, my account, right? User-sensitive information, probably stick a no store on something like that, never cache it. The news homepage for maybe, I don't know, the BBC website, for example, probably cache that for a few minutes, but we don't want to have like yesterday's news. Store locator. If your business is doing well enough that you're opening stores every minute, then well done. But the flip side is pages that don't change very frequently, you can cache those for a matter of hours, then slowly settling to days, weeks, and then the sort of theoretical forever. For non-versioned assets, for assets that don't have versions in their names, that aren't fingerprinted, we need more granular cache control directives to be a bit more specific and precise about what should happen. We would need e-tag as a revalidation header. They'll both need cache control, so versioned assets and non-versioned assets both need cache control. Versioned assets, stick immutable on there, tell the cache to keep hold of it forever, and set your maximum expiry, which is, technically it's infinity, but about 68 years. And if you're backing yourself that much, then I applaud you. 68 years is a long time. With that said, I want to say thank you for your time. It was quite, like I said, quite a dense talk. Some further reading, I already cited Andrew Betts' article during the talk, but some good stuff to read there additionally. But yeah, with that said, thank you very much for your time. Well. Question time.
Great job, Harry.
Thank you very much.
There are lots of questions. I hope you're ready.
Oh, really? Okay.
I mean, luckily, you'll be saved by the bell at the end.
Yeah, well, we've got the table up there as well, haven't we?
That's true. I keep forgetting to remind people. In case you forgot, there is a table up there where you can ask questions later to our speakers if your question was not answered. So first off, what happens if there's more than one cache control header?
Oh, like 2 cache control headers on the same response?
Yeah.
As with all HTTP headers, a client should sort of concatenate them. So what it'll do is it'll take all your different cache controls, put them into one long one, it'll concatenate them, sort of like on the fly. And if you've got conflicting things in there, so let's say you've got a max age of an hour and a max age of a week, a cache should take the smaller of the 2. So if you've accidentally put cache control a week and then cache control an hour, the browser's going to sort of concatenate those on the fly, and it'll take the more conservative of the 2. If you put public and private on there, I don't know what would happen. I presume it would hopefully err on the side of only honoring private,
Right. I would hope.
hopefully. But yeah, so as with any HTTP response header, they sort of get concatenated. Usually set with link, so you usually have like several link, or you usually get loads of cookie headers. They all get concatenated anyway, that's just an HTTP header thing. Cache control specifically, it'll concatenate it and then pick the most conservative of any conflicting options.
Cool.
All right, that was a long answer to a short question.
No, that's great. I'm sure people are happy with the longer answers. So do you dig into cache rules for every project, or are there particular clues that you watch out for before you start digging in?
That's a really good question. So, everyone's favorite tool, web page test. When you run a test, click the repeat view also. And just, if you look at the repeat view and there's loads of yellow in there, that means there's loads of redirects. That's usually loads of 304s. Lots of yellow means we're doing a lot of revalidation, and can we trim that down? Can we get rid of that? So that's usually my sort of like eyeball kind of just proxying the problem without diving in too far. And then you can, in Chrome's DevTools, you can, in the network panel, you can sort of add a column for response headers, or you could even do like minus has response header cache control. That will show you every file that doesn't carry a cache control header, and you might spot some sort of vulnerabilities there. So yeah, there's quick ways to sort of eyeball the problem. I'm just kind of obsessed with caching at the moment, so I just will always deep dive.
It is pretty amazing. It is one of those hardest problems, right?
Right.
Why would someone choose a weak versus a strong ETAG hash?
Ooh, it's computationally more expensive to generate strong ETAGs. I don't know to what order of magnitude, I don't know if it's like prohibitive, but you can generate weak ETAGs much cheaper and quicker. You don't need to know the contents of a file. You can just hash the metadata. So it's just a computational expense. But if you're like pre-building your files and you're not doing much like on the fly, you're sort of pre-compiling your assets, then strong ETAGs would be preferred.
Okay, so for this one, I'm going to say it, but then I'm going to guess what I think the question is.
Okay.
So for stale while revalidate, if the file, like an image, is indeed out of date, will your browser replace the image or only on the next request? If it does replace it, isn't that poor UX? So I think what they're asking is it rendered first with the other image and then switching out, I think.
I believe that's what the question is. I think that sounds right. It wouldn't do. It would be a horrible user experience if it just was like, we've got, especially if it's like a new style sheet, and all of a sudden like the site looks completely different. So it will drop it into HTTP cache as per the new headers, and then the second, it's almost like font display optional, right? There's a risk that the first visit will be complete without the new content, but it shouldn't be harmful to the user experience. Secondary visit to that page should fetch the brand new file from HTTP cache.
Cool. I haven't read all of these yet because there's new ones that came in.
Cool.
Is it a good idea to use the file modified time for file cache busting? Although you said it was a myth.
Yeah, so I think what the question there is, you could fingerprint the file based on its content and put that like a hash in the file name. What you could also do is take the last modified and add that to the file path. But again, if your build system touches every file and they all get the same last modified time, putting that into the file name will still run into sort of false positives. But yeah, the actual fingerprint doesn't need to be like a hash or an MD5 or a checksum of the file's content. It could be a version number. The problem with that is if you like version your entire release and you've got like style.1.2.3, and then you roll a release, you don't make any style changes, but your release is 1.2.4, you're going to get loads of false positives again. So the general idea is if you can use a checksum or a hash of the file, that's the most safe way of sort of guaranteeing the file is or is not changed. But yeah, that file revision doesn't need to be a hash.
Okay, I like this question because it was one of my personal questions too for my website hosting, which I was going to ask Phil later as well. But as a developer that provides services to clients as a freelancer, this is not me, this is Marcel, we deal with hosting and caching systems widely. Should we invest more time investigating if the hosting services we're choosing have proper caching directives on their response headers, if everyone is doing it right? Also, do you recommend testing caching systems locally before putting code to production for ideal configurations?
The first half of that question kind of shouldn't really come from the mouth of a guy who just spent 45 minutes talking about it. I probably wouldn't choose my hosting provider based on their default caching headers. Any sort of web framework or sort of any decent CDN will allow you to configure them anyway, so your hosting
Yeah,
provider
sure.
should be sufficiently capable of allowing you to get in there. I mean, saying that, I'm hosting a GitHub page, and I definitely shouldn't admit this to you all. Don't look at my site's caching headers, please. GitHub pages gives you 0 access. So Netlify,
Yeah,
for
yeah.
example, is as simple as
Oh yeah,
a
that's
text
what I was
file
going to
called
ask. How do I do it on Netlify?
Netlify, you've got a file called _headers, and you can set sort of file paths, wildcards, whatever, and you can set different rules for matching directories or file types, and that's really declarative, and that's really nice. Yeah, GitHub Page doesn't allow that. My site's fronted by Cloudflare, so I could write a worker that strips out the stuff I don't need. And again, a problem with GitHub Pages, like I said, is they really don't.
They're trying to be basic because it's really just for you
Yeah, I
know.
mean, I can't expect too much from a very,
Yeah.
very free tool. But I could just get in there with like an edge worker and just strip out headers and do stuff on the edge. The second question was testing these caching strategies locally. Yeah, if you want to wait a year and refresh before every deploy. No, it should be a case of like run web page test against your staging environment or whatever and just check it that way. Checking it locally should always work. It should always work the same. It doesn't really matter if it's coming from localhost or if it's coming from origin or a CDN or your staging environment. Your caching headers, it should be a case of don't check disable cache, refresh and see what happens. You should see it doing the right thing.
Okay, cool. What are some of the most common mistakes that you've encountered?
We've got a client at the moment whose last modified header is 1 second before the Unix epoch. And every file on the web has been modified since 31st of December 1969. That effectively means they've got constant revalidations on all their assets. So that's not a common mistake, it's just quite a funny one. It's usually things like sticking every header on there, not understanding, and I don't blame developers, it's pretty
like
pretty
more
confusing.
is great.
Yeah,
It's
yeah.
like better, right?
So erring on the side of, doing too much, having too much on, too many headers, especially ones that begin to conflict. So those are the most common things. And then a one-size-fits-all approach, I definitely see that a lot. People are like, well, I'll cache my images the same as my style sheets, the same as my script. If you can be bothered to have a bit more granular caching strategy, you can really get quite forensic. These are good questions.
I know, right? There's more. We're not going to get through them all, but one more? Okay, we'll do one more. At a glance, I don't know which one's better. Are there cases when it's faster to fetch a resource over network instead from device disk cache?
Yes. Who asked that?
There's no name on this one.
It's a good question. I don't have it to hand, but Simon Hearn. If you look up Simon Hearn, it's called something like when the network is faster or something. There are instances where fetching a file from the network ends up being faster than fetching it from browser cache.
That's amazing.
Yeah, it is really interesting. It's a great article. So yeah, if you just look up Simon Hearn, like when network's faster than cache, you should find an article which details sort of the phenomenon there. It's uncommon, but it does happen. It can happen.
All right, well, thank you so much for your talk and your time here. Everyone give
No,
Harry
thank you.
another
That was great. Thanks, everyone. Cheers.
Cheers.
Thank you.
Thank you. All right, well, while they finish setting up for the new talk, I'm going to give you another announcement. So during the next break, Chrome again will hold another feedback session about the performance panel. So if you want to influence the features that are going to come up in the next performance panel release, or I can't promise when, whenever they update it, make sure you meet by the doors at the next break, and you can participate in that feedback session. And again, remember, I think at the next break is when you can take your group photos up here, if you still like your team. Cool. I should have looked up more jokes. I have a few more, I just forget them. It's just the JavaScript joke really sticks with me because I really feel it so much. What is this? Cool. Bueno. All right, so our next speaker is Jodie Chan. She is the Senior Vice President of Product and Strategic Partnerships for Chinafy, the premier China web performance platform. She's been key to growing their strategic partnerships ecosystem to include such heavy hitters as Alibaba Cloud and AWS and more. She's also a Women Tech Makers Ambassador And if you don't know this, she is also a singer-songwriter, and you can check out her music online. Her name is Joya as well. her alternate personality. It's on your bio.
It's true. It's true.
I know. We chatted about it over coffee. But I'm really excited to learn about this topic because I personally don't know much about it, and I hope you're really excited too. So please welcome Jodie to the stage.
Thank you. Hello, hello, everyone. This is my very first Performance Now conference. And if this year is any indicator, I think I'm going to keep coming back for the next few years because it's a fantastic community, and I'm just so excited to be here to talk to you about something that most people don't really talk about in this community, surprisingly. It's the second largest market in the world, and yet there's so little spoken about it. So we're going to dive right in. I work at a company called Chinafy. The name leaves very little up to the imagination. The only thing that we do is help websites load faster, fuller, and more securely for visitors in China. It's that simple. And surprisingly, in terms of our simplicity, there's actually a lot of complexity under the hood. And I think one of the questions I actually had even in the past 2 days is, I don't know if this is related to me. I don't know if this is a question that I need answered, but I'm very curious about the response. And when I first entered this cross-border web space, I think I had a similar question. I mean, I don't know how this is related to me. I know some basics about web performance, and I can dive into the details there. But what I didn't know was actually how many times developers, solution architects, marketers have come up to me and say, this wasn't an issue until all of a sudden one day it was a really big one. And I think some of the examples that I'd pull on is there's a university, may or may not be listed up here, there are several that I've worked with, and during the pandemic, they had parents who wanted to watch their children's graduation ceremonies, the few that were actually allowed to have a graduation ceremony then, and they could not access that page. And so the university actually had reached out, the international admissions teams had reached out, and they said, we need some help, because this beautifully designed portal that we worked so very hard on could not be accessed at all. Other times we're talking about steel companies, we're talking about investor relations portals, and the list goes on and on. So my point all to say is, this is very relevant to you, but you might not know it yet. And so just to have a bit of interaction to start, I ran this through web page test, absolutely love the tool, and thanks to them. How many of you think that this website would take, let's just say, 3 seconds to visually complete from Beijing? Show of hands. Oh, one, all right. 5 seconds? 10 seconds? 20? Interesting responses. Okay, so I think what's really fascinating is that this website's beautiful. You should check it out. It seems like there's a lot of tips and tools about how to enjoy Amsterdam. When I put this through the test, I could have actually had a sword fight with Robin, turned around and had a sword fight with Tim, congratulated myself on the victory of both, and these were actually the results. So when we're running the test, what we have here is, I run it through Beijing, obviously the capital city of China, which actually arguably should have really good infrastructure. You guys should be able to see those numbers, I believe. I've also put it through Singapore, so you can make the assumption that just because the servers are a bit further away from the Netherlands, they should just be marginally slower. You can see the significant difference. The whole point is, look at the chart, it's very dramatic because it actually is in practice. And we've also looked at the total number of requests, and you can actually see it's quite common that the number of requests is significantly lower from China than elsewhere. And obviously, the film strips are always very nice. We often show this to clients because you can see there's nothing to see. And so what I thought was really cool when I go through mainland China, so I live in Hong Kong. I won't go into the details about Hong Kong being slightly different to mainland China, but the technologies that we use are very, very different. And when you go to mainland China, you can go to, let's just say, a small village on a farm, try to buy some vegetables to cook, and you'll see this 80-year-old lady coming up to you when you're trying to make a payment. She'll then show you her phone, and you offer to pay in cash. She'll probably say, I do not want your cash. Because actually, the integration in terms of mobile payments, in terms of just digitalized as a society. So how is it possible that a society that is so advanced, so technologically integrated, has such difficulty communicating with the outside world? And so these are just some statistics. I think feel free to take a photo. I can share this later with you guys as well. But in terms of the consumer behavior, most people are shopping online. They're paying their taxes through a super app. I don't know about any about you. I don't do that myself. And they're obviously making transactions very quickly. And so in terms of discussing China's market, and we'll go into the technological side of this very, very quickly, I think one of the things that I've experienced time and time again is no matter how well experienced you are as a performance marketer or a web performance engineer or a solutions architect or as the owner of some of the biggest companies in the world, there was a very famous case many, many years ago, not that many years ago, where Marriott had miscategorized one of the regions in Asia on their website, and it was completely taken down. And it just became, a very big issue in which it actually instigated a lot of conversations about why isn't a website working in China and how to make sure that they do. And so I think Coca-Cola is a fun example as well. So when they first entered China, there was Coca-Cola. It means bite the wax tadpole. And so I think this is just a perfect example. You can understand that you can translate something from English to simplified Chinese, but have a completely different meaning at the very end of the day. And so I think, obviously, with all this to say, because the opportunity is so big and the challenges are so much, there are things that we can actually talk about here and how to practically resolve the issue. So another show of hands, how many of you have heard about the Great Firewall? Keep your hands up if you know what it means. That's where it gets really fun. Okay, so the Great Firewall normally comes up in conversations when someone asks, why doesn't my website work in China? And they'll go, oh yeah, it's the Great Firewall. The conversation normally ends there. And what I'm doing and trying to do with the company that I work with, Chinafy, is to actually break down what does the Great Firewall mean technologically. And when we talk about that, what is interesting is that when a website doesn't work in China, they can pretty much fall into two camps. One, these are the platforms that you've probably heard don't work in China. So Facebook, Meta, X, Instagram, YouTube, Vimeo, all entirely blocked. And these are blocked by the Chinese Ministry of Internet Technologies. I'm going to use the MIT just to not say that every single time. Then there's actually the 90% of other websites, non-platforms, that are functionally inaccessible. And they're functionally inaccessible because they're not technically compatible with the Chinese internet ecosystem. And this is actually the problem that we're trying to tackle. So I'm not here to circumvent the Chinese firewall. If you are these companies, I can't very much do anything for you. But if you're the 90 other percent, there is something that we can do. And so one of the first things that you'll notice, and we talked about this in the earlier slide, is that the first thing that you might experience is that a website can take a very long time to load. No matter what kind of metrics that we're talking about here, right? It can take 30 plus seconds. Oftentimes it times out. Sometimes at 15 seconds you see nothing on the screen. And so speed is definitely one camp of the issues that you'll experience. The other issue actually has to do with functionality. So in part, due to the things that might be officially blocked or just slow performing in China, you might notice that videos are missing on your site. Fonts are not loading. Images are not being displayed. And altogether, that causes a lot of problems, as you can imagine, for the end customer. And so you can see these signs there. Now, I normally show this slide to a lot of the consultants and the agencies that I work with because they get so much heat for when the website doesn't work in China. And some of the largest companies in the world still haven't figured it out. And so, this is actually a purposely used, somewhat older data, because you'd be surprised, actually, in even the past 6 months since when I first did this test, not very much has changed. And that's what we're hoping to change here. Now, I think when raising those issues about speed and functionality, the first thought you might have had is, well, why don't I just host closer to the end user? And I'll actually go into this further in the talk about why it doesn't sufficiently resolve the issue. So let's just say hosting near to the end user helps a little bit, doesn't solve the problem. Using a content delivery network. I personally love CDNs. I think everyone should be using them, and I hope you are if you're not. But in terms of China, that also doesn't fully solve the problem. We have Chinafy works with some of the largest CDN providers in the world. And they come to us primarily because CDNs can only go so far in terms of resolving the speed issues. And of course, all the best practices that you should absolutely have on your website, they might help marginally. But when we're talking about a website that takes 30 plus seconds to load and you want it down under 5, reasonable ask, this won't do. So why are websites slow in China? I think one of the physical aspects that we can kind of look at here is in terms of just the internet exchange points and the number of ISPs. And this is a totally, I think this might be somewhat common knowledge, I think, based on some of the common conversations we've had so far. But, just the lay of the land, physically, there's reasons for latency, limited connectivity, and also deep packet loss. Potential packet loss, I'll put it that way. And then in terms of functional inaccessibility. Now, of course, this is a framework. There are a lot of dependencies. But I try to take a very complicated issue with a lot of layers and a lot of details into something that I can properly communicate in a way that feels like you can actually resolve it. So for the sake of this talk, I will break it down into these 3 parts. We will be talking about the network layer, a level, infra level, and the front end. So in order to make a website work in China, there was really only one approach, maybe about 10 years ago. And that was to essentially take a website that you've built, completely redesign it, host it into China, and oftentimes it's a much simplified website, so probably not using your favorite libraries, your favorite plugins. Very simple website, host it in China, and then maybe using a local provider for a CDN. Now, this might make sense for some companies that have a physical presence in China, right? That want to launch and have, well, just purely serve the local market, and for all intents and purposes, have a separate team. Now, instead of just spinning up an AWS server and being easy, no problem, when it comes to China and you need to host something in China, you first need an ICP license. There are 2 types of ICP licenses. I won't go into how to apply for these, because we could go on for a very long time. So 2 types of licenses that you need. A prerequisite to that is that you need a China business entity. Then you need something called a PSB filing. And then also you need local experts to make sure that you're building the website in a compliant way. And so for companies that decide to pursue this route, it might take anywhere from 2 months, 2 years. The worst one I've seen is 5 years, and they gave up. And so the second option is somewhat, in between. What some folks might do is that they will actually build a simplified website, host it in China, and maybe use some tools to kind of resolve the most common issues, right? We're talking about the platforms that might cause something to be blocked. They might tweak that manually and then also tweak that automatically. And then the third option is what we essentially try to do at Chinafy, is oftentimes we're talking about, let's just say Shopify, right? Shopify is fantastic. I use it myself for my artist side of my life. And what they do is they make it really simple for you to launch a website, right? But what that also means is that they control a lot about how your website is built. It's not so easy to self-host. There are certain things that you can't just bolt on a different CDN. You get rate limiting issues. I have tried. And there are other things that actually limit this option. And so for a lot of companies that are using some of the top technologies out there, top cloud platforms out there, they might have to choose that third option because they have no other choice. And so when we're talking about the network level, right, Estela had a fantastic talk, I hope you saw it earlier, about how to resolve time to first byte and issues like that. All those practices are very helpful in terms of optimizing your website for China. But again, that's just a very, very small piece of the puzzle in terms of acceleration. But what we're looking about here is that there are things that you can do, right? You can obviously resolve closer to the end user, whether it's near China, let's just say host a server in Hong Kong, which a lot of people do, or Singapore, and then or host it inside of China if you fulfill all those requirements. And in terms of TCP handshakes, well, because we are in uncharted territory, I think I'll have to ask for your permission to use completely new terms, such as domain compression. This is something that we use really to say that there's so many domains on a website, there are too many trips that are happening, we need to compress them into something that allows us to make fewer trips and make it easier to access the things that we need to access. And so this is just one example. I mean, something that should take 20, 30 milliseconds ends up taking 1 to 2 seconds, and collectively, that is clearly your problem. And in terms of static files, right? And we're not even talking about the times, and there are many times, I'm sure you have experienced, where you will have a website where they just literally take the photo that an agency provides, a beautiful design agency provides, and puts it right on the website. We're not talking about those edge cases here. We're talking about folks that actually do know what they're doing, optimizing their websites, and it's still loading 85% slower from China. Now, you'll see on my left that we're talking about also the content delivery networks in play. I think Akamai's here. There's maybe some folks from AWS. I'm not too sure. This is not to name and shame. I think some of the top providers out there don't have this fully figured out, but they are definitely making efforts to. So a lot of this has to do with the global POPs, so we're not talking about the in-China POPs, which are completely operationally managed separate. So Akamai China has a China partner, AWS CloudFront has another China partner, et cetera. What we're talking about here is if you are using their global POPs. So of course, there's something that you can do. Harry's talk spoke about this perfectly. Set up your cache headers correctly, right? That definitely helps because it then at least allows fewer mistakes to happen and fewer roadblocks in terms of loading those files. Let's see, compressing your images, that's also very key. And in terms of content delivery networks is to be very much aware about what is in your technical stack and what are in the technical stack of your end users. Because oftentimes what ends up happening is you can use top-of-the-line technologies that work very well outside of China, but don't work well inside. And this is where it gets really interesting. 80% of the problem, I would say, in terms of performance, actually has to do with the resources that are on your page. And it's interesting because, I don't know, I just threw a few up in here that we've seen even from some of our enterprise customers. Again, back to the sword analogy, some resources will just mostly be for show. They're a bit annoying, you'll notice them, but it won't really do much. Other resources might maim your website, and other ones might kill it. And so the goal really oftentimes for a lot of developers is to understand what does what. But when it comes to China, a lot of the challenge has to do with the fact that these are changing day to day, right? And the technologies and the way that they function. For example, Google Analytics. Interestingly, Google Analytics, so Universal, when it was back in the UA system, you are actually able to get events firing properly. You get some data when a website is loading fast enough. The move to GA4 has actually transitioned and affected some other ways of data collection. I don't know the details on the mechanisms of how GA4 collects data, but all of a sudden it's completely different this time in China. And so we can have that conversation, I think, further up in the booth. If you can figure it out, maybe we can do something together. Now, other times there are things like Vimeo and YouTube. Again, because the platform is blocked, you can load a website with a Vimeo embed, YouTube embed. And the video content is not actually the cause of the issue. It really is because of the platform that's embedded in. So there's actually ways to handle for this. So what we would do at Chinafy, and a lot of this has been automated because of the scale of websites that we work with, but you as a developer or a solutions architect, however you'd like to name yourself, there are things that you can actually do in terms of resolving this issue. For example, Vimeo, if something is completely blocked, find a local equivalent. Vimeo, YouTube equivalents, I don't know if you've heard of something called Yoku. The name sounds, some nods of the head, okay. You could do Yoku, or you could do an MP4 video. Other times when things are completely blocked, it's like a traffic jam. You can't get past the car in front of you. What ends up happening is the browser will keep trying and trying and trying, and then maybe it'll give up, or maybe you just don't get anything after that. And so essentially what happens is you probably should take that out of your site if you're trying to make it load in China. And then to think about what external links are on your website. So this gets quite hairy because when you think about a website, I mean, Mark had a really good analogy earlier on yesterday about thinking about your website in terms of islands. Right now, if you're using that analogy, we have to think about it in terms of islands, in terms of the trees on that island, the ants on that island, the animals on that island, the rocks, right? And so when we're thinking about a website, we have to completely restructure how you're thinking about it in the context of China. And so this is always really fun. Again, we're not here to name and shame. I just found some random companies I thought would be interesting to look into. And again, reminder of the frameworks that we're talking about here. All right. Oh, this is for you to take a photo if you wish to take a photo, because I can't go through all the potential questions that you could have about this. Oh, that's good. Great stuff. So, Allbirds. This is the Allbirds website hosted in China. It's the allbirds.cn. And if you go to China, actually there are several stores for Allbirds. But interestingly enough, one of the best branded companies in the world has a simple, single-page landing page. It's just got one image, and it's got 3 QR codes that lead you to their social media platforms. It's got something called the ICP license. As I mentioned before, it's a bit small on the screen, but generally when a company has an ICP license, it's registered per domain. So for this domain, they have an ICP license. You can see it in the footer of the website, and it links to something managed by the MIT. And then you can just take a look at some of these charts. Again, Web Page Test has fantastic tests. In terms of Chinafy, we use a mix of RUM and synthetic, but for all illustration purposes, we'll show it this way. So OK, first view, 2.69 seconds, not bad. And then we look at the offshore site. And this is an offshore site by Shopify. Beautiful, way more interactive elements. I personally use this one when I purchase my shoes. And you'll notice that the stack looks more or less like the websites that we're using day to day here and the ones that we're talking about. All of a sudden, if you look at the film strip, it goes out of screen. So this is a perfect illustration, again, is that you can have a beautiful website, and if you're not considering the expectations of the end user in China, you might end up with something that doesn't work at all. And this is just a side-by-side comparison. I think this is quite interesting, because I spend my days looking at this data day to day. All right. Now, this is another interesting example. So LVMH, I can't say I own very many products by them, but I also check out their website. And you'll notice that LVMH, they do have a similar page. So they have a single image. You'll see that's hosted in China. We looked, you could do a dig when you're in China, or if you have a China IP, find your ways around that. And then you can actually find, it's similar to the Allbirds website, but what's interesting is this time it links to another domain, a subdomain, cn.lvmh.com. Now, LVMH, you would assume that they have some of the best teams working for them, right? They have experts and they have a lot of budget. So what ends up happening, though, is you end up with a beautiful website that they've localized. So at least, you see it's in simplified Chinese. But this is still hosted in France, actually, as with the rest of the domain. They are using the fantastic, Akamai. But what ends up happening is, without further tweaks and without further optimizations, there's still something going on here on the right. So you have a perfect example in which it's localized to some extent, but then at the very end, it depends whether that's successful in terms of your idea for the customer. And so, I'll just show you a bit of a resource waterfall. We love these charts. But what's interesting is when we're talking about China is what we're trying to investigate isn't what we can see. It's what we can't see. You'll notice that there are sometimes these gaps I try to highlight here. So when we're trying to investigate a website, we're trying to see what is the issue that's causing something to pause, causing something to stop entirely. And we also have to remove the variables. Is there some kind of content on that website that's causing it to be severely flagged? And so this is a very good example. We're happy to work with these guys. Don't work with them yet. But there are some gaps of things we can see here. And so then there is the other option in terms of onshore, offshore hosted websites. A lot of the times, again, as I mentioned before, there were 3 options to make a website work in China, right? There's the fully onshore option, there's the onshore and somewhat manually or partially automated, and then there's the offshore and automated options. When we're talking about onshore and partially automated, it's because you can host a website in China, but still have all those resources, all that functionality that hasn't been optimized for the end user yet. And so this is an example that we've worked with at Chinafy, where we were actually able to take something that obviously was taking a bit longer to load than it should, and taking to a relatively reasonable time. And then there are also other sites that are offshore, right? So this particular customer, I blanked out their logo. They have case studies out there, so you're welcome to look that up after this talk. But what we've done with them is that their goals, right? Their goals when we're talking about various stakeholders is, one, they wanted to have the same team outside of China manage the website. Fair ask, right? They wanted to maintain the functionality, the branding, and the plugins that were already on their website. So they didn't want to have a new stack entirely. And for whatever other reasons, they did not want to pursue the fully onshore option of something inside of China. And what we can do here is, because we're looking at several parts of their website, right, based on the framework that we're talking about, there's actually a lot that you can achieve. I mean, the purpose of this talk really is to show you that, yes, there's a huge gap. There's a huge knowledge gap, maybe prohibitive costs for a lot of folks, but there's actually quite a lot that we can do. And in terms of this particular site, what we did is we thought about it, again, in 3 tiers, right? There's a network level. So they eliminate the option of hosting inside of China, so we just resolve it closer to the end user in China. We used a China-friendly CDN. Actually, interestingly, in this case, we used GCP. So Google Cloud Platform actually, near China, performs really, I see that. We love GCP. This customer clearly does as well. So there is that option to then use GCP. And in some cases, they also use a multi-CDN, but that's really for the marginal gain versus the big gains. And then the most important, again, is on the front end. So what we've done actually is we've taken the original website, right? And we use geo IP-based routing so that there are essentially 2 versions of the website. On that second version is where we make all those tweaks and optimizations needed to make that website work better for the China visitor. And what that includes is actually being able to identify the hundreds of resources on that page, identifying what is blocked, so officially blocked by the MIT, what's just incredibly slow, and what are the gaps that we can actually fine-tune on an ongoing basis. And so, you know, the sad part is I actually can't show you the before, because once you go live, you can access it properly, which means I can't show you the problem about how bad it was, but I promise you this is true. We took this screenshot, and this is what it looked like before China 5. And this is after around 30-something seconds of waiting. So many sword fights later. And then afterwards, it actually just looks like their global website. So the beauty of this is we don't actually want the end customer in China to know that we've done much, right? The whole point is that it feels, looks, and seems to the designer, to the end customer, and even to the consultant that we worked with, that it looks and feels the way they designed it. Oh, and just to highlight again, these are some components, some have fallen off the screen, about things that were in the stack. And so, again, these look really beautiful. These numbers are really beautiful because actually in most cases they are. If we have the chance, I think what would be really fun is there are tools out there where you can actually test whatever website you want and see how slowly it loads in China. And through minor tweaks and things that you guys hopefully have learned to apply here, you can actually see quite a huge improvement. And so yeah, 240% faster. And so what's really fun actually about these talks is we're talking about, let's just say from here, we're talking about 500 millisecond gains. We're talking about, or 5 times 100 millisecond gains, Tammy quoting you. Here we're talking about 240% gains. We're talking about taking something that's 50 seconds to under 10, fully loaded and visually complete way faster. So it's very dramatic, and I think it's very exciting. And so what I've attempted to do here is create this chart. Again, we are going into uncharted territory, making new charts and new terms up. So this is really just to illustrate some of the ways that you can approach this. I think one thing that is very important to remember is that the conversation with stakeholders have to happen very, very early when you're talking about web performance in China. Because one thing, and the first thing you'll know, is probably they'll ask you about budget. It is incredibly costly to actually make a website work in China, even in the ways listed above, right? I think what's a good example is, let's just say if you're using a CDN globally, right? You throw on Cloudflare, they've got plans. I think they've got they've got free plans. They've got very cheap plans, maybe at most a few $100s. Their enterprise goes up to $5,000. If you are using a Cloudflare China CDN, that's $5,000 US per month. And that still doesn't resolve all the issues that we're talking about here. And so when we're thinking about resolving this issue, again, the first thing that we should do is engage the stakeholders. Know whether it's the marketers asking for this, whether it's the partners, and better yet, if there's investors in China asking for this, that really tends to move the needle. And so when we're talking about options here, though, again, every website is different. And in terms of the steps that you can take, depending on how many resources you have, how many tools you have at your disposal, there are different things that you can do. Now, one thing that rarely comes up, or hasn't come up in this conference yet, and probably reasonably so, are the legal aspects to what we're doing. Because I think one of the things in China that you'll start noticing is when you start Googling making a website work in China, hopefully China 5 pops up. I think our content teams do quite well in terms of making those resources available. You'll notice that there are actually a lot more requirements to the steps that you might want to take. So I mentioned earlier there is hosting involved, right? So hosting, you need the China business entity, you need ICP licenses, PSP filing. Please don't go to sleep. I know that we're going to have a few more minutes together here. But that is something that you have to consider, right, in terms of the availability of these options to you. The same goes for onshore CDNs. When you're using onshore CDNs, we're also talking about those same requirements. A lot of folks have actually come up to us before trying to navigate these conversations, which is why my job is so fun in the strategic partnerships department, because I am having talk with cloud providers who actually want to resolve this issue for their end customers. And then they have to navigate them through these very, very difficult conversations about legal requirements, regulations, and things like that. The PIPL is essentially China's equivalent to the GDPR, right? So data privacy and data requirements are also increasingly I guess, center stage when it comes to China, and it's still an ongoing conversation. What I found really interesting is we've talked to, let's just say, 2 companies, very much apples to apples, maybe just a different logo serving the same services, and they'll take completely different approaches to the PIPL in terms of their requirements. I'm not here to really answer why, but I think one of the things about the PIPL to consider is that there are certain companies that do have the business requirement of hosting their data onshore in China. Now, that's, of course, for the legal department to consider, but as someone who's talking about web performance in China, this is something that you also have to think about. And then, of course, again, company requirements differ every single time. So not only are websites incredibly different, but company requirements are very different. So what I'm hoping is, having that framework, very many slides before, having this framework can hopefully help you think about the ways that you can address a problem. Say someone comes up to you, you can think, okay, these are the 3 routes that you can possibly take, and these are the 3 options that we might explore together. And you really do have to partner with your end users on this. Doop, 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 doop. All right. And so in terms of going the market in China, I think what we want to think about here is that entering the market in China is really a long-term game, right? And web performance in China, it's almost like you're moving the target every single time, right? Resources are performing differently day to day, most likely not day to day, but at least month to month, right? Years to years. And so when we are talking about web performance in China, I think you really should squeeze yourself into that conversation from the very start and stick with that end user, with the consultants, with the partners that you're working with, because it is something that they'll need your help on throughout their experience in China. Now, the first thing, obviously, is making sure that website is working. It's not too much to ask, but again, as we've explored today, there's a lot to go through. The second thing has to do with observation and monitoring. The tools that you are using, there are some fantastic tools out there. Web page tests, I've mentioned them before. You can also do a mix of RUM data. You can definitely also try to work with local agencies in China to contact users directly. What's quite interesting is, I personally, I don't always love talking to customers face-to-face. Sometimes I have to do it, but we try to enjoy ourselves as much as we can. But in terms of talking with testers, that's where it gets very interesting. Oftentimes, when a website isn't working in China, and we're working with them, they'll just say, something's down, you guys have broken our website, what's going on? The answers to that often are very interesting in terms of scenarios that you might not think about. One scenario is they might be switching in and out of a VPN, and all of a sudden, you don't know why their website isn't working. Their office Wi-Fi suddenly has issues entering and accessing certain websites of certain IPs. So all these things you kind of have to take into consideration before putting the fault on yourself, but oftentimes there is something that you can do. Third thing is obviously marketing. We talked about the importance of business metrics and time. Well, Tammy talked about it. I didn't talk about it this time, but tying your performance metrics to your business metrics. And oftentimes, when it comes to China, I think it's understanding that similarly, web performance has impact on businesses, right? If 1 second counts, every 1 second counts, every 10 seconds is incalculable. And that's what we're trying to gain here. We're trying to gain that 10-second gain, and we're trying to move that mile better for our users. And of course, onwards, because there's a lot more to be done. And so, this leaves me with some time to hopefully answer some questions. But in this talk, I think there are a few things that I'd like to kind of leave the audience with. If you're a platform, I'd like to challenge you. Are you doing what is convenient? Are you doing what is common? Or are you doing something that actually helps the end user from someone who's very, very far away? Because the demand is there. We are seeing companies, we are seeing China visitors very, very much interested in the products that are available outside of those borders, right? So the demand is there, but the question is the supply there? I would also challenge agencies and consultants just to ask that very boring question is, does this website work in China? What is the performance budget that we are happy to have and to accept? Are there things that we can do to track and to better understand how our websites are performing? So this is me. Feel free to scan me. You can turn on those lights, wave them around. We'll be in a concert. I see them around. Okay. So yeah, I hope that today's talk was informative, a little scandalous, and that we can have some good conversations after. Yeah. Thank you. Thank you.
That was really insightful. I did not know a lot of that, and so I'm really happy I was here and learned that today.
Thank you so much.
So our first question comes from Amal. What's the best way to do a simulation or test of your website from the US for how it would perform in China?
I would say that the most accessible way is probably just to run it through something like, just to get an initial sense of how the website is performing, using tools like web page test. And there are some RUM tools out there as well that you can combine them with. But I think in terms of accessibility, literally go to the web page test, go to the advanced, select Beijing, Shanghai, or Ningxia as the location, pick whether it's with Wi-Fi, 3G, 4G. I mean, I have a lot of fun with this, but that's the first way to kind of test. Chinafy has their own tools as well. We have something called the visual speed test, which actually allows you to kind of see side by side how the page is loading from, I think, a select. So I can't give you a specific number.
Yeah.
Google might have that answer for you because it is searched actually quite frequently. But the mobile usership is incredibly high in China. But what is interesting I'd highlight is depending on the company that you're working with or talking to, sometimes they might only interact really on desktop too, right?
I was going to ask that. I was like, do we understand mobile device, the devices that are actually used in China well enough to be able to serve them well? Or do we fail in that department? Because I know most of your examples showed desktop.
Yes, desktop just makes for a bigger image, so I
Yeah,
like to show that on a screen. But in terms of mobile user experiences, so one of the first examples that we often talk about is there's this term that's being thrown around when it's talk about WeChat, so China's super app. Some of you might have used it. Actually, plenty of people use it outside of China as well. So there's WeChat, and then they say there's something called H5, right? It's like, what is H5 development? It really is, I think, designing for mobile. And oftentimes, a lot of the websites if your website is responsive, it's a very good chance that you've already thought about the end user in China. Because if they're sending a link through WeChat and you've taken the steps to optimize it, you are essentially serving them an H5 mobile experience. Exactly.
Cool.
So, yeah, I think there's more that can be done, but the best thing to do is to make sure your website is responsive and to consider mobile as well.
Awesome. What are the most widely used browsers in China, and how reliable is that crux data in China? Because Chrome might not be the most used browser.
Chrome is actually still used quite a bit. I'm not going to show the list of the breakdown of browsers. I think you guys can Google that. But what I would say in terms of browser and search behavior is that when we're thinking about China is, for example, Google, right? There's the Google of the world, right? China has Bing, or Baidu. And they have all these different search engines and things that are, I would say, I wouldn't say competitive, but just slightly similar. You can recognize certain behaviors, right? So a lot of people, if you're working for SEO on Google, when you're thinking about China, you really should be working on Baidu SEO. And so it's about roundabout way to answer, but if you have concepts that work generally outside, you can apply them as well for China browsers. Just like there's a Baidu Web Spider, so it's like webmaster tools in Google. If you could, I mean, there's some language barriers, I think, sometimes to using tools in China, but there are the tools out there, and it's just to consider that.
Definitely. This question's a little hard. I think we had some language issues here, but I'm going to try to get it right. But how do we get reliable RUM data? Like, we have made the experience that most people have used the embedded WeChat or similar browsers, which are based on very old Chromium engines. How do you analyze field performance?
That's something that I think we're also working on. I think oftentimes, if you want true accuracy, sometimes you do have to build your own tools. One of the partners that we have in Chinafy is Alibaba Cloud. So oftentimes we are using their tools, and there is, to some degree, reliance on the tools that are available, the limited ones that are available. I think one thing that is important to recognize is that these tools can be cost prohibitive for a lot of folks, right? There just simply aren't as many, and it's very costly to keep these alive. So what I would suggest, again, taking a step back, is to do a mix of synthetic, a mix of RUM tools, and then also just, again, to engage people who are in China themselves.
Yes, exactly. I think some of these questions are similar, but we'll go ahead and cover them. One was, are there core web vitals in China? Does Chrome work and collect data? Part of that was answered, but I think we can kind of get to, like, what are those metrics that we can use if we're not necessarily on the, the latest Chrome, like if it is from another browser, what are maybe some of those other metrics we can use?
I think DOM complete is something that's quite telling. You can kind of look at time to fully load, DOM complete, things LCP as well. I think whatever you're using from a conceptual standpoint, I think is to understand that, at the end of the day, China users are not that different from users outside the world in terms of their expectations, right? So when a page visually completes, I think that's something that we use personally, just because for us, the most important user is the end user, right? I know companies, oftentimes they want to know how many visits are happening on the page. They want their analytics tags to fire, which sometimes happens or doesn't happen, right? So we tend to use things that are further up on the resource waterfall chart, such as visual complete, LCP, things like that.
Cool. Well, I think some of these are a little bit ones we probably already answered.
Okay.
So I'll go ahead and wrap it up now, unless you had any final thoughts.
Final thoughts? I think we should all have a conversation. I think
so.
I think I'd be very curious to know your experience in terms of China web performance, and especially again if you're in the platform space or if you're a person who's working with clients who might have an interest in China. I think we should have a conversation about what we can do better as people who are trying to bridge that digital divide, not to take Matt's title, but to bridge that digital divide between China and the rest of the world. And then also just to see what we as a community of web performance experts can do better.
Awesome. That was amazing. Thank you so much for your time.
Thank you
and
so
everyone
much.
give her a round of applause.
Thank you, thank you, thank you. Good stuff.
Everyone upstairs, if I could ask you to please keep it down so that we can actually do our next talk. If you're upstairs, excuse me, hello. If you could tap the person next to you. Hello. Hello, you up there. You guy in the hoodie. I don't want to scream. If y'all could tap the person, hey, you. All right, we only have 2 talks left. We are in the home stretch. And we want to make sure that we respect these speakers as well. It is a lot to get up here, especially for the last ones of the day. And I'm really excited about these last two talks. They're going to be amazing. So how many of you have ever used web page test? I know. So I'm going to introduce you to your new favorite superhero. Pat Meenan is actually the creator of web page test. To me, that's... They say never meet your heroes, but I feel like he's a good exception to the rule. Pat is a great guy. He's actually currently a software engineer at Google, though he's worked at Cloudflare, Meta, Catchpoint, Google again, and maybe another one again, and even AOL, remember? You've got mail. He has worked in web performance for 25 years. His web performance career could have a career of itself. And he created Web Page Test, our favorite web performance tool. So everyone, please help welcome to the stage Pat Meenan.
Thank you. So I'm not here to talk about web page test, unfortunately. I love it, one of my favorite tools. I loved working on it. But I also spend a lot of my time, right now I'm at Google working on Chrome, working on loading performance again. It's sort of, I did my great tour of FANG, working on performance from sort of all sides of things, from the client, from the CDN, and from the browser, and from the servers. And so went back to Google because there were a few things that I wanted to get done. Fetch priority was sort of number one. We had worked on it when I was back there in 2018. We finally got it shipped last year, so please use fetch priority if you're not already, especially on your LCP images. It will it's a cheat code for Core Web Vitals. But today I'm talking about sort of the new next thing that we're working on. It's actually ready to be used. I'm really bad at naming things. You know, something that tests web pages is called web page test. This new project we're working on is compression dictionaries, because it's dictionaries for compression. So this whole presentation, everything in it, all of the tools and everything is on useasdictionary.com. So you don't have to really take any notes on any of the slides, just sort of soak it all in, and it will all be available here for you if you want to go revisit any of it. Yeah, again, I'm really bad at naming things, and just to be safe, I named it a whole bunch of things, because I'm really bad at buying domain names too. So yes, I have problems, lots of problems. So first, I wanted to make it clear, it is available today. So I say it's the next great thing we're working on. There is the little asterisk about it being an origin trial, and I know we've been burned a time or two on Chrome origin trials. This is one of the things I'm staking my career on it actually shipping in one form or another. The origin trial is to help shake out sort of, are there any rough edges with the developer experience, with the serving infrastructure? Are there things that we can make better to make the ergonomics better? And for that to happen, we actually need you to try it and not just work off of our assumptions on how we think it will work in the infrastructure. So, you know, I was really scared when I saw Mark was the first talk here, and following Mark's awesome design skills, my deck is gonna look like a Ryan super optimized website. It's like super bare, and I spent, I wanna say 10 hours on Midjourney, Dolly, Google's image generator, trying to get it to generate an image of a shrink ray. You wouldn't think it would be so hard. And it generated all sorts of really pretty pictures, but then I went back to my old school and just Google searched shrink ray, found the best cartoon I could. And this is sort of what we're trying to do to the resources on the web. Provide tools to make the resources smaller so you can ship more excellent experiences. What you do with them, you know, it's up to you. Ship more JavaScript, it's gonna happen anyway. Hopefully this enables it, or sucks up some of the impact of it. So I'm not a compression guy. This is sort of like the high-level overview of how I see compression working. If you've got any compression nerds in the audience, you know, I'm probably way off on the details. But basically, Right now, today, when you're serving a resource and you're using gzip or Brotli or zstandard or whatever the latest and greatest is, you have the version of your JavaScript, HTML, CSS, whatever text file, and the way it gets compressed usually is it will scan through as the file's coming through, and if it sees something that it saw before, it can go, hey, I'm going to replace that with a token that stands for what I saw before. And so the first time it sees function and the contents of the function and console log, it hasn't seen all of that before and it needs to spit it out. But the second time it sees all of that common stuff, it can replace it with something much shorter, and you end up with a much smaller compressed file that, when it goes through the decompression, gets reinflated to what it was originally. All dictionary compression is a separate file that we call the dictionary that has the common things that you're likely to see in the files that you're trying to compress. And so instead of having to have seen something before, the first time it sees it, if it's in the dictionary, it can replace it with something that's a token. And you end up with much smaller files because you don't need the first view of the uncompressed content. So the common parts of your code, your resources, your HTML, whatever, if it's in the dictionary, it can be compressed out. And you have this side file that's the dictionary. And so, fancy name, compression dictionaries. So we're going to try and bring it to the web. And I wanted really early on to explain why you should care. We'll get into the details of how and why, but the impact, it's not like the next tweak to Brotli where we get a few more percentage points. Here we have on the chart, the blue ones are gzip 9, the maximum gzip level. The red is what you get if you go to Brotli 11. And the yellow version is what you get for these resources in particular when you use a dictionary. There's generally two types of resources we're going to be talking about. Static resources, things that are part of your build or whatever, JavaScript, CSS, WASM. This is assuming compiling or compressing the static resource with a dictionary of the previous version. So let's say you've got a rich JavaScript app that has, the hashes in your file names to get good caching, for example. And so you've got your version 1 and your version 2 of your resource. It hasn't changed that much between your two versions, just whatever you've done to fix or add features or security fixes or packages that you've updated. This is using the previous version of your JavaScript file as a dictionary for the new version of your JavaScript file, effectively giving you delta compression when you're delivering to the clients. And so the YouTube desktop player, for example, updates multiple times a week. It's, unfortunately big. It's 10 megabytes uncompressed, 1 megabyte at the best Brotli that we can get. It's somewhere on the orders of 100 to 200 kilobytes if we can do week-over-week delta compression using dictionaries, just delivering the updates. The Vercel, for example, their application JavaScript week-over-week, it's almost compressed out. It's 96% smaller if you're just doing the delta updates. And Filament is just a WASM app that I happen to be able to find month-over-month releases, I believe, that were fairly big, substantial changes. I think they changed the version of FFmpeg that's actually in the WASM bundle. And we still get 45% smaller than the best Brotli compression we can get. And we start talking about big, rich web applications like Photoshop on the web, for example, that's 50 plus megabytes of WASM that you don't download and install, but somehow you have to get it into the browser, and I'm not sure exactly how you're doing that if you're not downloading it. But so week over week with Photoshop updates, for example, you wouldn't have to re-download the whole 50 megabyte application, you just download the delta. And so that's what we're here hopefully encouraging adoption for. It's not just static resources, so HTML content, using a generated dictionary, you can take all of the header of your page, the head of your HTML, the footer of your page, the general structure and layout of your pages, your data URI image placeholders, for example, all of that stuff that's common across your skeleton pages can go into a dictionary. And when you take that dictionary and apply it to the HTML pages, you can get, even for dynamic content, significant savings. Google search, optimized to the hilt. We get 40 to 60% smaller pages if we're doing dictionary compression using a custom dictionary. Etsy, I know you're in the house. 21% of the size, so 80% smaller for the product pages if you use a dictionary that has sort of all of the common parts of the Etsy page. So going page to page during a session visit, you end up with much smaller HTML delivery. Bloomberg, I know it's not the terminal, but the Bloomberg website was kind of amazing that you get almost 90% smaller on the HTML, which is generally the hardest thing to deliver and shrink, and most important for performance. Sort of trying to think the other angle, there was another, I'll get to it in a little bit. So we have a little bit of a deja vu here, especially for the older timers in web performance in the house. We've been doing this for, I want to say, the better part of 15 years. SDCH was a thing in Chrome, I want to say back in 2010, 2012 timeframe. Search, eBay, there were a couple of users of it. It was something very similar. It was HTML specific, but then that was right about the time that the crime and breach attacks started to happen, and we found out about side channels and compression, and it turned out using dictionary compression, at least at this layer, was a vulnerability, and we had to turn it off. And so from that point on, we've been doing a bunch of fighting trying to get delta compression effectively to the web in a privacy-safe way. HTTP 2, it was kind of funny to see the Twitter flame war a little bit that flared up about a month ago. It's time to unbundle all of the things now that we have multiplexed protocols, HTTP 2, HTTP 3. When we first launched HTTP 2, it felt like it would be a good idea. Hey, we can deliver a whole bunch of resources in parallel. We don't need to bundle all of our resources. Turns out that's wrong. Compression is one of the big reasons. When you compress all of your resources, it's a lot smaller than compressing each one individually. But there are also browser restrictions and overhead. If you have 1,000 requests, the browser has to do 1,000 checks in disk cache to see, do I have these things? And that's much slower than a single request to see if the bundled version is available. We did try to solve it, at least the compression side of things, doing cross-stream compression in HTTP 2. The security privacy guys took one look at it and went, nope, nice try, try again. And so the next attempt that we had, and this is much more recent, I want to say last year, web bundles for taking all of your sort of JS that's part of your modules and let you reference JS within the zip file as separate resources. It solves the compression problem. It lets you update individual resources within a bundle, but it had really bad developer ergonomics. You had to change how JavaScript was on your site. And that's kind of a big hill to push up, especially if it doesn't have browser support. And so this is the latest, and we think, we have talked to the privacy and security guys beforehand this time, by the way. And so they've all gone, yes, we can't find anything wrong with it yet. But there have been Google, Facebook, Apple, Firefox, and W3C security and privacy teams have all looked at it. So we're pretty confident it's going to fly. So the actual resource flow, what does it look like? The static resource flow is going to be sort of the easier case that I'll talk about first. And this is when you have one version of a file, and you have a new version of the file. And when I say you, I mean in the browser cache of your end user, they have the version of your JavaScript from, say, a week ago or a month ago in their cache. You have since released multiple versions, and you're now on version, well, in this example, version 2, so I guess you've released one new version. And we're going to talk about how you deliver that to them specifically. The only changes between the two were you updated a couple of lines of code or something like that, and the actual delta between them is much, much smaller than the actual file itself. So how this works, the first time they come to the site, or the first time they're getting the first version of the app, something on the HTML page will have a script reference to v1 or /app/v1/main.js. Or it can have a hash of the file somewhere in the file name. that file will respond with the use as dictionary, hence the domain name I purchased, because I'm really good at thinking of names. And it provides a match path of what requests this file can be used as a dictionary for. Because when you properly version your resources, main.js is not going to be the same request for version 2 that it was for version 1. And so this lets you say, hey, all of the files with this pattern are actually the same file, they're just different versions of it. So go ahead and use this for any future requests for anything that looks like a main.js request. And at some point in the future, when you come back and visit, the browser now knows that we've got a request for v2 main.js that matched the pattern that we have for a dictionary that we now have in cache. And so it announces to the server, hey, I've got an available dictionary, and it sends the SHA-256 hash of the dictionary contents. It's important, we couldn't sort of send just the file name because we wanted to make sure what the client has is actually the same thing the server has. And so it sends the full hash of the dictionary. And yes, I know SHA hashes are a lot longer than that, but they wouldn't fit on the slide. And it also includes, at least right now, SBR, which is shared broadly, in the accept encoding. It will also, as of Chrome 1.19, it also includes ZSTD-D, which is the Z standard version. And so when we originally did a lot of this work, it was going to be shared broadly. Z standard was released since the time that we started doing shared compression work, and Z standard also supports dictionary support. And Chrome, as of, I want to say 1.16 or so, has support for Z standard. And so now Chrome also has support for Z standard dictionaries, as well as broadly dictionaries. So whatever your flavor of compression you like to do, we'll accept either one. If the server has a delta compressed version of main.js that was compressed with v1 as the dictionary, it can send back just that delta with a content encoding SBR saying, hey, this was delta compressed. And the much smaller version, the browser will automatically decompress it to be the full version. I will say this solves the delta compression delivery of JavaScript. The browser is still running the full version, or compiling, parsing, running the full version of the JS. So don't go hog wild with the amount of JS you're sending down. The uses dictionary header, response header, has two parts to it. Match is a wildcard. You can have any, like you can have main.js, app.js, a whole bunch of dictionaries on your origin if you want. If there are multiple matches that have the same pattern defined, the one with the longest match string wins. And it's under the assumption that this is the more specific. Like if you have a generic dictionary for /star for, hey, I've got a dictionary that works in general well for my whole site, but then I have an application-specific dictionary, you can override basically the site-wide by having a longer match path. TTL is a specific time for the dictionary itself to live as a viable dictionary, independent of the cache headers and the cache time. So you could cache it forever, but say that you only want the dictionary to be used for a year or a week or a month. The main reason for separating those is going back to the request headers. So when the client requests the resource and you deliver the delta compressed version of it, it has the available dictionary header and the accept encoding, both of which the response is going to vary by the available dictionary and accept encoding. And so that introduces into your CDN caches or any of your caches in the network separate copies of your resource for every client combination of headers. And so if you update your resources 3 times a day, and you make it available for a year, you've got close to 1,000 different versions of the sec available dictionary hash that could be in the wild that will end up causing you to have 1,000 copies of your resource in your CDN caches, and they'll just start throwing random ones away. And so the TTL specifically is to let you sort of fine-tune based on how often you release, how long back, you want clients to be able to do delta compression based on sort of what your usage pattern is for clients visiting frequently, and balance that against how many copies you want to be in your CDN caches or your edge caches. And so this is actually changing to default to a week, just to make sort of everyone a little more comfortable on the CDN website of things about us not defaulting to blowing out all the caches on the internet. In a sort of static resource build environment, one way this could work, it's not sort of the only way, is at build time, you get artifacts, main.js, other files.js, and you have the previous versions of your releases available somewhere where your build tools can reach them. And after you've done your main build with your bundling and everything else, you can run a Brotli or a Z-standard command line that you take the hash of your v1, your older file, so that you know what the dictionary signature is going to look like for that as a dictionary. And you basically tell Brotli, compile this new version using the old version as a dictionary and name it with the hash in the file name. And so what that gives you at the end is you have your main.js as well as versions of your main.js that are delta compressed against previous versions that have the hashes in the file name, and they're just sort of all sitting there in your release directory available to be used. And when the browser requests it, the edge server, your application code, can basically go, hey, it has this dictionary available. Do I have a main.js file with that hash and SBR available to send down to the client? And if so, just send that file instead of the original resource. If it requests a dictionary that you don't have the hash for, just send the whole file. It's perfectly acceptable to not send content encoding SBR. It's completely progressive enhancement. It's just a miss on the dictionary, and you send the full resource. It's worth noting that in this case, your CDN will be caching 2 copies of main.js, one without a dictionary and one with the AABBCC key, since we're varying on available dictionary. So it's not a complete no-op, but it definitely nothing will break. On the dynamic resources, so that was the static case where we're serving versioned resources. I use JavaScript in the example. CSS is really easy to do as well. It doesn't even have to be text resources. WASM is still sort of a text format, but that works. But you can also do binary files if you're feeling really sadistic. I did experiment, and it's more in the dynamic case with JPEGs, for example. If you've got a color profile that you happen to be embedding in all of your JPEG images, in theory, you could pull that color profile out into a dictionary and use that to compress all of your JPEGs further, for example. So the compression doesn't care, they're byte streams. If you have anything that happens to be common between 2 files, you can use that to reduce the transfer file. In the dynamic case, this is more things like HTML, but also API calls, JSON. So if you're making GraphQL calls, JSON is really verbose. You've got all of the keys, all of the structure, a bunch of default values. All of that stuff can go into a dictionary and be compressed away. So your API calls can effectively become binary transfers. And so in this case, this is sort of a bunch of different product pages visualized with my awesome graphics skills, where the green and blue parts are sort of, the green are common on all pages, the blue parts are common on a few pages. You take sort of anything that might be common at all, put it into a dictionary. How you do that, we'll talk about in a second. And then just the parts that are different, like in a search results page, for example, the actual search results, but none of the skin around it, the search bar or anything like that, become what you actually deliver to clients. Sort of the key to all of this is any response, any HTTP response can be used as a dictionary. For any other resource. It really depends on just defining what the product path or what the match path is for where you want that dictionary to be applied. It doesn't have to be a previous version of the same file. It can be a custom file that you build that happens to work better for the types of content that you're trying to serve. The real key in the dynamic case is just, how do I get that dictionary to be fetched so that it can be set and used as a dictionary? Prefetch, preload could have worked, but then you have side effects on other browsers that don't support dictionaries, where it would be downloading the dictionary and never actually doing anything with it. And so, yeah, so this is just where it gets reused against all matching fetches. It doesn't really know or care about what's being fetched, just that the path matches what was advertised as a dictionary. And so what we really needed was just a way to trigger a dictionary fetch to be able to seed it. And so just added a new type of link. So instead of link rel equals preload, it's link rel equals dictionary, and you can point it to a dictionary. It can be either in HTML as a tag, or it can be in HTTP headers. And so this is how you would trigger your first HTML view, for example, would still be compressed using traditional compression. It would have the link tag in it that would cause the browser at idle time, sometime after the page load has happened, to fetch the dictionary, make it available, apply the path, and all of that. And so future HTML navigations, if they match the path that's advertised in the dictionary, can be compressed and much smaller. And so, yeah, I mean, if you sort of think about it, what we're doing here is effectively giving MPAs the capabilities that you get with SPAs, where you deliver all of the shell in the dictionary, and the content that's specific to each one of your pages is all you're downloading each time, without actually having to do anything SPA or otherwise. It just gets compressed away. And so as you're navigating through product pages or search results, you're just downloading the differences that you need for each one of those pages. Where we are with CDNs. So CDNs in particular like to generally normalize the content encoding, the accept encoding, do the compression. So there's sort of two phases to it. It's the don't break things and let us do compression dictionaries without support of the CDNs, but so that the accept encoding can flow through. And every CDN I've tested allows you to do that. Some more easier than others. All of them require slight tweaks to the configs, just so that they don't strip out the accept encoding of SBR, and so that they allow it to pass through the origin. Most of them, once you say content encoding SBR, they'll go, hey, I don't know what to do with that, and just pass it through. And some of them you also need to manually say that we can vary on the dictionary header and the accept encoding header, because they tend to not like to vary on accept encoding, just because there tends to be a lot of them. All of this is available on the usesdictionary.com/CDN, or there's a link on UseAsDictionary that has the details for these 3 CDNs at least on what you need to tweak to get it to work. Like Fastly is just a one-line VCL change, for example, so it's not maybe as onerous as it may seem. I know Akamai's in the house. I'm sure, I don't personally have an Akamai account and a rep to work with, but I'm sure it's really easy to flag somewhere to just not mess with the content encoding and allow it to go through. So there are, some restrictions on what we can do with dictionaries to keep the privacy and security people happy more than anything. It's one of those, over my time on the web, it's like, why we can't have nice things, the entire reason today is security and privacy. We would be building all sorts of cool things. I mean, it would be horrible for the users in the ecosystem, but the technology we could have if we didn't care about privacy would be awesome. But we're not in that kind of world. And so the main requirement for dictionaries is that they need to be same origin to the resources that they're compressing. And so if you want to use a dictionary on your HTML, it needs to be served from the same origin as your HTML, just to make sure no one's like hijacking other people's content and attacking it with an attack dictionary. And they need to be fully CORS readable by the document they're being loaded in. The main reason there is compression is a giant side channel attack for exposing the contents of the compressed resources. And so I don't know how the hell they do it, but the security researchers are able, using just compression and some control over what's in the streams, to actually extract the contents of what's in the compressed encrypted streams. And so the main workaround there is to say, that's fine, it's all readable anyway, so you can't attack something that you can just read. The restriction there is if you do have something that you want to protect from being readable from the documents, you can't use dictionary compression. For the vast majority of things, your JavaScript, your CSS, your API calls, that's not a problem, but just be aware that either means your resources that you're compressing are same origin as the document, or that they're cross-origin, and the cross-origin response includes an access control allow origin that covers either star or the domain that's making the request from the referrer. And the dictionaries are partitioned with the caches of the browser. So you're not going to have a mega uber HTML dictionary that you can use across 100 different sites, for example. So like Shopify, where you have all of the different vendors. Each vendor is going to have to download the dictionary because they're running on their own domain. You can't have like a Shopify one dictionary gets used from Allbirds and ProClips, two places I happen to buy stuff from that are Shopify clients. And so basically everyone's on their own island for delivering their Delta updates or their dictionaries for their resources. And those are really sort of the only two boundaries that we have, but those are enough to make it so that it's not attackable and so that we get to have our nice toys. There are changes. They are coming. We're in the standards process, and so the standards process is basically a giant bike shed of people going, I don't like that name, I think it should be named something else. And then going, why didn't we name it this other thing instead? And so SBR was what we had as a placeholder. That's being changed to BR-D, which is broadly with dictionary, to match Z standard with dictionary. But what Chrome has in it today in 1.19 is SBR. And we didn't want to change it because we're not done bike shedding yet, and the names may change again. So we'll wait for the names to settle before we change. But if you do origin trial, these are the things that are likely to change during the origin trial, and it's just things like the text strings that get used for the headers and for the content encoding. So nothing that breaks the actual flow and how things work. That we're pretty solid on. Sec available dictionary in the spec has already changed to available dictionary. They didn't think it needed to be protected with a sec header, and so if in fetch, you decide you want to break yourself and add an available dictionary that the browser doesn't have, go at it, break yourself. It won't actually break anything that the browsers care about. You'll just get responses that may or may not be decompressible by the browser. One of the things that we didn't go out of the gate with yet that we've noticed we probably need is beyond just a path matching, destination matching, so that you can specify a document dictionary to be used with HTML that isn't also sent for all of the image requests on your origin, for example, or for all of your JavaScript resources. So that if you do want to specify a /star path and say, I want this dictionary to apply to all of my HTML across my entire site, you'll be able to do that with match_dest document. You could, in theory, also do match_dest JavaScript or script and style. Those make a little less sense because generally we'll be doing path-specific, file-specific Delta updates for those. But if you do have sort of a JSON dictionary that you want to apply to all of your JSON requests, you could apply that to fetch and specific paths. The match wildcard that we have in place right now is probably moving to URL pattern, which is used for service workers and speculation rules and sort of the direction the web platform is generally moving if you want to specify sort of matching, URL path matching semantics. And so we're likely to take the match and split it into two. One part is for the path part of your URL, and one is for the query params search part of your URLs, and split it into two pieces. Still support wildcards. It won't be that much different. And it'll default to probably a wildcard for the search. So if you just have a specific path and ignore query params, that'll be in place. And as I mentioned, the TTL default will be changing from a year down to probably 7 days since last use. Instead of right now, it's 1 year since the dictionary was originally written into the cache. The 7 days from last use will basically mean any user that's been to my site in the last 7 days, even if they got the dictionary a year ago, will be able to do delta compression. And so, as far as the tooling goes, and this is probably where things get more interesting, Z standard, as far as the compression side, all versions of Z standard support external dictionaries. Whatever you get in your CLI, apt install, or however you download it, it should just work for generating dictionary-based compression from the command line, or from building into your servers if you want to call the APIs directly. Brotli 1.1.0 was released, I want to say in September, maybe August. So it hasn't made its way into all of the apt installs. You may have to build from source to get a version of Brotli that compiles or compresses with external dictionary support. Just check if the -D command line property exists. If not, it's not that difficult to build from source. You just clone the repo. If you install Basilisk, it's an automation tool for building with Bazel, which is the open source version of Google's Blaze, which I guess the Brotli team used for the build. And you just run build Brotli, and you have a command line version of the latest code. The Brotli repository includes a dictionary generator, which will probably be your best friend in the case of the HTML dictionaries. What you can do, and it's built the same way, it's just part of the same Brotli repository, it's just in the research directory. And what you can do is you can give it a whole list of files and say, generate me a dictionary based on these files, and it will extract all of the common parts of the files for you into a dictionary of the size that you specify. And you can say, make it no bigger than 1 megabyte, or however big you'd like your dictionary to be. The dictionaries, when you serve them, can be served compressed, so like a 1 megabyte dictionary, maybe 100, 200K on the wire when you serve it. So don't get too discouraged with building large dictionaries. I do have a tool on usesdictionary.com, actually a couple of them, and it's linked from there, that basically hosts the dictionary generator for you. So you can give it a whole bunch of URLs, I think up to 100, yeah. And it will generate a dictionary for you on my server in my basement, so please don't abuse it too hard. And if it's going slow, that's probably why. And it will generate a dictionary for you of the size that you request, and let you download it and use it for whatever you want to use it for. One of the other things that it will do, and it's how I got the estimates for the improvements on like the Etsy sites and the Bloomberg sites, is it will test the effectiveness of dictionary compression on those URLs that you provided. It does that in a painfully obtuse way of, for each URL that you specify, it generates a dictionary from all of the other URLs excluding that one, tests to see how well it compresses, and then does that for every one of the resources. So it generates 100 dictionaries if you're testing 100 URLs to test the compression of each one, because it would be cheating if you had the contents of the URL that you were testing in the dictionary that you were testing the effectiveness on. So it is a fair test for how likely your pages are, how much your pages are likely to compress. It also, you can specify a user agent string. One of the important things sort of to be careful of when you're generating the dictionaries is to not include any user private data in them. And so if you were at your app server, for example, to just observe responses, save them, and generate a dictionary from them, or from a CDN man-in-the-middle kind of place, just sort of observe the requests flowing through and generating a dictionary. You could include some private data by accident. And since we discussed dictionaries are publicly readable for anyone that has access to them, you've just put private data in something that's readable. The other benefit to this is it fetches all of those completely anonymously from my server. So there's no way, there's nothing that's not open to the web in those dictionaries. Coming soon, I didn't have enough time to complete the work on it. I have a WASM build of Z standard that can run in a Cloudflare edge worker. So if you don't want to do the dynamic compression for the HTML case on your origin, you can run it on an edge worker on your favorite CDN. I just happen to be using Cloudflare because I'm familiar with their edge workers, but I think most will run WASM. And so what you can do is have your HTML dictionary on your edge, as well as WASM and Z standard, observe any HTML flowing through, and when the client has the dictionary available, just automatically do compression on the edge. And so you can deploy it without having to build it into your actual application or without having to wait for CDN support. And to be fair, all of the CDNs are looking at what does it make sense for us to do as a value add for doing the actual compression, but you're not necessarily beholden on waiting for them to implement it. I mean, I feel a little dirty about running compression in WASM on the edge of a CDN, but you know, it's what WASM's there for. As far as the current status, I did mention it's in Origin trial in Chrome today, so you can use it today, please do. Feel free to ask me directly if you have any questions, or there is feedback on the Origin trial where you can let us, and please do let us know officially how it integrates with your build system. Does it work with your flow? Are there particular places where it caused problems where we can make it easier with different patterns or headers or anything like that? There is an IETF. The HTTP working group has adopted it as a standard. There's a draft. We're talking next week at IETF about moving that on. It will hopefully be an RFC for all of the HTTP layer headers, everything except for the link fetch tag. There's a W3C explainer. All of this is also linked on the Use As Dictionary site, so you can read the actual specs. The explainer is much more approachable and has sort of the layout and the history and whys. The W3C, we're probably going to take the link header and link meta tag specifically dictionary as part of the HTML spec and feed that into those specs. So we're crawling a few different specs, but there haven't been any objections. All of the browsers are positive on the change, so we're not expecting any problems doing that. It's just time going through the bike shedding and spec writing process. It does take a village. I'm up here talking about it, but I'm not like the one who's done all of the work. I don't think I've written any code for it other than sort of my tools and stuff. Yoav sitting right here, and you know, with his mug right in the middle. He's been fighting this problem since SDCH, and he was the one largely behind the HTTP2 attempt, and butting heads with all of the privacy and security teams, and came up with the original idea for this. I'm just largely working through the spec process and working with all of you on it. There are teams at Chrome working on the implementation. All of the browsers, all of the CDNs, even a bunch of customers have sort of taken a look at the specs, the headers, to see how they work in their ecosystem, just to make sure there aren't any problems with it. And so thank you, and you know, I'll be really happy when we get back to one social network. These are like all of the ones, not all of them are available in Europe. I'm really looking forward to Threads being available in Europe, and then we can maybe have another place to talk about things. I think that's it. Oh, and you know, because I don't think Europe lets us have the neon-colored Mountain Dew that we can get in the US, I brought some with me.
Trying to make a few extra
I'm
bucks
sure
on the
it's
side.
full of all sorts of carcinogens, but you know.
But we need those to grow, right? Thank you, Pat. That was really cool. We have a lot of questions, but we won't go through all of them, but we'll at least cover
I will
some
be
of the
around
highlights.
all night, so
Exactly.
feel free to corner me.
So will this be suitable for on-the-fly compression? For example, Brotli 11 is too slow and CPU intensive, or is it something that you might do at the build step instead?
Yes, sorry, I forgot to mention it on my HTML page. So on the Brotli page for static resources, I used Brotli 11, which is sort of the extreme, use all of your CPU and your friend's CPU to compress stuff. Z standard, I don't know why they can't agree on a scale. Brotli goes to 11, Z standard goes to 19 or 20 or something like that. I used Z standard 10, which is sort of in the middle and very CPU friendly. Z standard all the way down to 3. So Z standard will use dictionaries on all compression levels. I wouldn't recommend doing it on 1. At 3, you end up seeing a lot of the savings. By the time you get to 10, you've reached sort of the maximum savings, and then beyond that, you're getting the incremental tiny wins that you're used to seeing from like the last couple of percents. Brotli, anything below 5, at least on the command line tool, won't use dictionaries at all. So you have to use Brotli 5 or higher to get any benefits from dictionaries. In the static case, you might as well use Brotli 11 and get every little bit, but if your build system, you don't want to use that much CPU for whatever, you can use slightly lower. But yeah, Z standard is probably the way you want to go in the dynamic case. And we're talking about that in general anyway. I mean, the Brotli compression team will probably kill me, but the consensus seems to be that Z standard is lighter on CPU for equivalent compression than Brotli. May or may not be true. With dictionaries, it's definitely true because Z standard at lower compression levels still uses dictionaries, whereas Brotli doesn't currently anyway. But yes, absolutely, totally applicable to dynamic, even at low CPU usage. The main issue you're going to have in dynamic cases is the dictionaries. You just need to have them in application server memory or in web server memory. If you're in a CDN case and you have thousands of clients, then you may have thousands of dictionaries that you have to worry about keeping in memory on the edge. The compression libraries are really good about shared memory and letting multiple responses all use the same shared dictionary memory, so you don't have like a copy of it for every response you're working on, but it does add a little bit of overhead. Sorry, that was a very involved answer, but
no,
it was a good
excellent.
question.
I am sure they wanted all of that. Have you considered, this actually came from several people. I'm going to apologize in advance because it's a little tough question for your Chrome team. But have you considered shipping certain generalized dictionaries with Chrome? Like, for example, a dictionary that can be used for generic JSON responses, or a React dictionary tuned to common React syntax?
So Brotli itself has a dictionary in it, which is largely why Brotli compresses so well. And yeah, so it has a custom dictionary built from how the web looked at the time Brotli was shipped, which may have changed a little bit since then. We have talked about, in the future, and I'm not committing to any of this, it could make sense for the browser to advertise some set of known dictionaries that compress certain types of content well, maybe in the same header, maybe in different headers, that servers could then opt into using. I'd say that's probably we want to get shared dictionaries working first, make sure they work well, and that the origins are in a good place to be able to do dictionary compression. And then we can talk about, is there something that makes sense to ship that has, the problem with things like React and some of the frameworks is you've got version-specific things, but if there's sort of a general template of things that how the web looks today, ES6 API calls that people are calling, or common other things that should be in a new version of a web dictionary, it could easily make sense to have some of those available. But yeah, it's a good question because it could have some serious impact across the web without having to have everyone download dictionaries.
There's also unintended consequences, though, like how do you choose which ones to use, and how does that
and are you favoring like React 2 by having a
Exactly.
built-in dictionary that's not available in a newer version of React? And it may make sense where there's some repository of well-known dictionaries that sites can opt into that like the browsers could download into a shared cache, for example, so we don't have to partition it by site, and maybe something like that makes more sense.
A trusted shared cache.
Something like all of the browsers could agree upon, hey, let's add another thing to the well-known list that is downloadable at runtime or something like that.
Do you know if this works with service workers?
I mean, it doesn't break service workers in any way. Service workers don't sort of facilitate the dictionaries in any way, because by the time the resources have gotten to the service worker, they've already traveled the network. You could have, in theory, implemented dictionary compression in a service worker, but as far as service workers themselves, the responses that are dictionary compressed are transparent to the service. By the time it gets to the service worker, it's already been decompressed, and it's the full version of whatever V2 of your JavaScript or your HTML is, and so it's seeing the unmolested full version of the content. And so it doesn't break service workers, but there's nothing sort of special that service workers brings to the party.
And then how do you use multiple dictionaries? Is there a way to map them?
Yeah, so the match path and now soon the destination lets you specify as many dictionaries as you want. Like if you have 10 files in your build, for example, and just looking at JS and CSS, for example, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can have the match path be /*1/*2, and all 10 of those will be dictionaries available for any requests that match the URL pattern. And so you can have as many dictionaries as you want, as long as you can specify the things that they apply to using the patterns. Now, I will say each dictionary can only apply to one pattern. So you can't say this dictionary at this URL needs to cover 3 different patterns. You would actually have to provide 3 different dictionaries if you want to specify things in that way. And it could be like the same dictionary with query params or something like that. But and the browser will only advertise to an origin 1 dictionary at a time. It will be the best match that it picks. So you can't have like 10 dictionaries for /* and expect the browser to advertise all of those and the server to just pick the best one. To avoid complications on the varies and caches and stuff, we restrict it to the browser picking the best match it can identify and only requesting that one, so we don't end up with too many copies and caches.
Awesome. Thank you so much, Pat. Everyone give Pat another round of applause. Great job.
Thanks.
You did a great job.
Thanks.
All right, y'all. We're almost there. In case you didn't notice, we're going to have some drinks afterwards, and those are sponsored by Century, so give them a thank you before, before we get there. Thank you, Century. Any other last announcements before? Are you excited? Was this like a great conference or what? I didn't hear anyone snarkily say, or what. This is my first time coming here last year, and I have to say, I am pretty impressed. I'm definitely going to keep coming back, whether they want me or not. All right, ready to go? All right, so for our very last and I won't say very greatest, because the other speakers matter too. But we do have a pillar of the web performance community coming up next. Tim Kadlec is a performance consultant and trainer, and he's also the author of several books and has contributed a lot of content and support for the web performance community, for which we are all very grateful. So I want everyone, please welcome Tim Kadlec.
Thanks. Thanks, Sia. Yeah, but I always get a little sad on day 2 of this event. This is, I'm a little biased, but this is my favorite event by far. The entire year I look forward to it. The talks have been amazing, right? How incredible have all the speakers been? Yeah. Nowhere to go but down from here, am I right? But no, I look forward to the talks, but it's also the conversations. It's genuinely the conversations. That's always the standout for me. I've said it time and time again, but I feel like the performance community is an incredibly special one. The only reason I get to do what I do professionally is because, I mean, I've made a career out of asking people smarter than me. Many of the people in this room have been those people to explain things to me patiently like I'm a 5-year-old. That's like how I get by doing this. We just have an incredible, patient, kind community, helpful folks, and such a good mix of people come to this event. You get people that are working on the CDNs, the browsers, the standards, people that are working at agencies, they're working on in-house stuff, they're working on external work. Just such a variety of different perspectives and opinions. And that's I think what always pushes things forward is when you get all of that mixed together. So it's just a very kind and curious community. And I think that's really important. I've become a little bit obsessed with what I believe that any step forward, any big step forward in innovation, has to have a combination of curiosity, improved tooling, and improved metrics. And I feel like if any one of those pieces is missing, we don't make progress. That's where we get a little bit stuck. Like all three of these have to come together. And like I said, I've been a little bit obsessed with this recipe, and it's not just for performance. I feel like this applies to any area of innovation. My parents they store a lot of things for a very long time. I guarantee you in their shed are still worksheets from when I was 5 years old. I guarantee, I've seen some of them. But they were recently going through some of that, and they gave me a tub of some of the stuff that they found, that were mine for me to figure out what to do with. And one of the things they gave me when I was going through was this. This is a floppy disk. Now, for those who can't read it because the writing's a little bit, handwriting's not great, there's 2 lines here. One says Al Hoffman's adjusted stats, and above that it says Joey's adjusted MBA stats. Now, you probably have a couple questions, I think, that are necessary for this to make any sense, so we're going to answer those right away. First off, a floppy disk. It was a storage device before USB drives, way less capacity, much bigger for some reason. Nowadays, they make excellent coasters, I hear. I believe you can buy them on Etsy, actually. The second thing is, you need to know Joey. I'm Joey. My middle name is Joseph, and as a kid, my family called me Joey. Anybody who knows me as a kid, anybody who knows me from my family, they still call me Joey. It wasn't until around college, and actually when I started doing stuff online, that I started trying to use Tim for the name. And so there's a very clear divide. In fact, it was kind of funny. My wife and I were high school sweethearts, and when so all of her friends knew me as Joey, and so a couple years later when she sent out wedding invites to her friends, they all said that she was marrying Tim, and she got so many calls from who is Tim? Is this a relative of his? What's happening here? So I'm Joey. So those are my adjusted NBA stats, NBA National Basketball Association for the non-sports folks. And so that probably brings up a third question, and the answer is that yes, I was about as cool as you would expect a kid who walked around with a floppy disk full of their own statistically adjusted comparisons of NBA basketball players would be. That was very cool. But I remember working on this, actually. You see, I have one of the things that I don't think it's a great trait necessarily, but when I get into something, I get obsessed. There's not really much of a middle road for me. I get a little freakish about it. I don't do things lightly. And so in junior high, I got really obsessed with basketball. It was playing basketball, but it was also watching basketball, and it was the history of basketball, and it was coaching. The first career ambition I had, until my guidance counselor told me it was not a viable career, was I wanted to be a basketball historian. And then he said, that doesn't work out, nobody's going to hire you, and so I switched to web stuff. Actually, the reason I learned web technology was that so I wanted to write about basketball online. And so I was obsessed with this, and shortly after our family got our first family computer with internet access, I stumbled on the Association for Professional Basketball Research. Now, the site, by the way, you can still go to it, yeah, I said that fast, but that's right, .org. It still looks like this. Doesn't look legit, but it actually was pretty, there's a lot of legit work happening from this group. This was a group of folks that were as obsessed with basketball as I was, and actually, if you go and you look down somewhere in here, my name is still cited as a contributor. Now, many of you have probably heard of or seen the dog comment on the internet, nobody knows you're a dog. I was definitely the dog. I jumped in on this, I think I was 12 or 13. And it was so me and a bunch of retired folks talking about basketball history and basketball data. And I was just super eager, and so they had a mailing list that went through this, and I would read every email and jump in on every conversation. I used to buy old 1930s basketball programs, and then I would go through them and pull out the stats and then email the group, and that's why my name is as the contribution thing. Yeah, I totally geeked out on this stuff. But I remember in the mailing list, Al Hoffman, the other person on that floppy disk, he started playing with there's so much variety in different playing styles and stuff over the years of basketball. So he was like, well, how do we compare? How do we figure out how somebody really stacks up historically? So he was trying to adjust career stats based on the differences in playing style and all this stuff. And I thought that was cool, of course. So I decided that I was going to have a tweak on his algorithm and kind of do my own. I still have no idea I don't remember what I changed or why I thought that I was new enough to change something, but that's what this whole thing was. But that was just one of many conversations actually about metrics. Metrics became such a dominant conversation on that group, we actually got complaints, so we had to break off and have a subgroup that was just APPR metrics with a forum and a mailing list where we just talked about analytics and all of that kind of stuff. Now, it was super hyper geeky, right? But it's not overstating it to say that some of it ended up being quite revolutionary. Not my stuff. To be very clear, nothing that I did was. But there are people in that group who ended up becoming pioneers of sports statistics. They've written books, they've went on to work for professional organizations, they head up the data analysis teams. They help them teams to focus on how to keep their players healthier, how to build teams, how to play the game. A lot of this actually turned into a really big deal. I mean, today's NBA, like pretty much every basketball or professional sport, I should say, is underlined by a very strong foundation of analytics and data. And it's been pushed on by, the tooling as well. They've seen cameras and optical tracking devices have gotten better and better and higher fidelity. The NBA spends millions a year to have these tracking devices put inside of their stadiums so they can monitor every little thing. Just this year, actually, they upgraded everything. So they now have optical tracking that is tracking 29 different skeletal coordinates on every player's body, knees, wrists, everything. Every little precise movement that they make is being cataloged. It might sound overkill to some, but it's really fascinating because if you think about if you're watching a game of anything, like basketball is a fast-moving sport, the coach or whoever it is watching the game, there's only so much you can take in at once, right? But, in theory at least, if we're tracking all of this stuff, we can get all sorts of this invisible stuff that's happening to be surfaced. And then you pair it with machine learning, and now you're able to get to advanced analytics and advanced data out of this stuff. So it's really fascinating to see some of the changes that have occurred of that. There's one example from a team building perspective that I wanted to give quick. It's from an excellent book called The Mid-Range Theory. If anybody just wants to geek out on data and basketball and how they intersect, it's a great book. But Seth Partnow, the author of this, writes a story about how in 2018 he was working with the Milwaukee Bucks. And they were looking to bring in a center, so that's usually the biggest guy on the team. And they were looking at a guy named Brook Lopez. Brook Lopez was a free agent. He had a reputation for being a good scorer, but a really poor defender. Now again, for folks who are not really into sports, the goal of the game is to put the ball through the hoop. That's how you score. You want to stop the other team from doing that. Defense is really important. It's hard to win without good defense. And he had the reputation of being overpaid, slow, not very agile, kind of a dinosaur for the modern day NBA era. And none of his surface stats look good. If you looked at the surface stats out there was nothing to suggest that he had any potential to be a better defensive player than what he had shown up as so far. However, because of all the tracking data, they had access to new metrics that didn't exist before that showed some stuff that the coaches weren't seeing on the tape. So one of those was around the defensive rebounding percentage. So when an offense is coming down the court, they take a shot, you're hoping to force them into a bad shot, then you go up and you grab the rebound, you grab the ball, and now it's your possession. Defensive rebounding is critical for any team. It's a key cog in defense. Good. So what they looked at is when they looked at the percentage of available defensive rebounds while he was on the court, like how many potential rebounds could he get, and then what percentage of those did he get, he was in the 94th percentile in the league. He was excellent, amazing at it. When they looked at the team impact as well, when he was on the court, his team, he was the 5th most impactful player in the league. When he was on the court, his team rebounded better. Even if he wasn't getting it, the rest of the team did better. They looked at defending the paint. So the paint is the painted area close to the basket. It's where the highest percentage shots are. They looked at how the percentage of the shooters when he was the closest defender within 5 feet. And he was in the 87th percentile on this. He was, by every underlying data point, an elite defender in the making. So they pulled the trigger. They signed him for what, by NBA purposes, is cheap. And they brought him on. And over the next 4 seasons, this poor defender went on to be all-defense first team, that means top 5 in the league, all-defense second team another year, that's top 10, runner-up for defensive player of the year, that's top 2, and the cog in a defense that ended up winning an NBA championship. None of this is because Seth or anybody else in the front office is a genius. In fact, he says that explicitly when he's telling the story. Like it completely has nothing to do with anything that they did. What this is this was a combination of curiosity to applying that to a foundation of improved tooling and improved metrics that have been prompted by other curious individuals over decades of experimentation and decades of work. It's really easy to find the parallels to this in our own industry. Like, they're all over the place. Mark mentioned largest contentful paint. I actually wanted to dive into that for just a second because I think it's a really fascinating example of how this all works together and how we get a flurry of innovation and standards that come out the other end. Come out the other end isn't the best way of phrasing that. That's smooth. Anyway, no, keep in mind that this is the history as I know it. Like, I feel like, you know, I was there for some of it, seen some of it, I've read about some of it I'm sure I don't have. I think the interesting thing about like any great idea evolves over time through the input of many, and it's really, really hard to go back to its origin because I feel like it's sparked by a few but refined by a ton. And that's kind of how this goes, but this is at least a partial imperfect attempt to sort of show the progression here. So the story is, at least from my involvement, and it remembers in the early 2010s, we had these sort of unconference events, right? These were WebPerf days, things like that, where we'd get together. It was a bar camp style for anybody who's done that. You get together, you have the Post-it notes, you pick the topics you want to write about, everybody puts them up on a board, you organize them, and you're like, great, well, let's have breakout sessions on these things here. And I remember one of the common ones that we had at several of these was around, hey, all we've got is onload and document complete and stuff. Like, we really want, like, can we get some rendering focused metrics? We would like paint metrics. And the specific example that was cited a few times was we would love to be able to say on an e-commerce product page, when does that hero image load? Because we had nothing like that, but we all kind of recognized that, you know what, this was really important. It's probably more important than the load metrics that we had. Now, the initial response from this wasn't great. Like, it wasn't dismissive in any way. I don't want to set it up like that, but it also wasn't encouraging. The initial response, Pat mentioned the, privacy ruins everything. Yeah, well, our initial reaction that we got from browser vendors when we talked about this wasn't realistic. It wasn't going to happen. There were too many privacy concerns in exposing anything resembling accurate paint timings. Like, you open up the door for all sorts of interesting little timing attack kind of stuff. And it was discouraging. I remember having beers with people and talking about that after the events, and being a little bummed out about it. The story probably could have died there, but the perf community has always been a very resourceful one. Around 2012, Pat, who apparently has a habit of just putting up performance tools in his basement. I've got my laundry down there, personally. I don't know. He had web page tests running out of his basement at the time, and he added to web page tests a metric called speed index. Now, speed index was a really influential metric. It still is a really useful metric. I still know quite a few perf people who swear by it as one of their top couple that they look at. It is still a great metric to look at. But what speed index does is it looks at the progression of a page load. So instead of just focusing on the load time metrics that we had, it would look at how quickly do we get the majority of the content on the screen. And based on that, we give it a score. Lower score is better because it means we got the majority of the content up there faster. So in these two hypothetical examples, let's say that there's a fourth image off to the side where they hit load at the same time. But the progression on the top film strip, much, much nicer, right? Because we're getting the majority of the content for people to read and to consume out earlier. And so that's what speed index started to report on and let us actually get finally a little bit of a better rendering metric. I think somewhere in there we had, above the fold render time and a few other little things like that, but speed index was a monumental step forward in focusing on the rendering. A few years later, 2015, this is another one that stands out to me, was Steve Sodders wrote about hero image custom metrics. So Steve started doing these experiments. We still had no way of recording when that product image shows up. So Steve started experimenting with, well, what could we do with just JavaScript, right? So we had like performance.mark. So we could do things like, what he tried was he put a script, an inline script, that would use a performance mark right after the image in the source code. He also used an onload event on the image itself to fire a different performance mark. So it looks something like this. He ran a bunch of experiments just to see, comparing it to the film strip. And he found that if you looked and you took the longest of these two metrics, you got pretty close to when the image showed up on the screen. Now, again, it wasn't super, super precise, but it was a big step forward because now we had a way that had been tested across multiple browsers that we could potentially do this on our own, despite the fact that we had nothing yet from the browsers to be able to do anything standard-wise. 2017 is when we get the first working draft of the paint timing API. Now, this is the one that gives us first paint and first contentful paint. Not largest contentful paint, that's a separate thing. It's a little confusing, but that's that. Like, the paint timing stuff is all about first paint and first contentful paint. So this is a full, like, at least seven years, and I'm sure there were conversations before this, between, like, bringing this up and then, hey, we've got something now that browsers are going to be able to work on, browsers are going to be able to ship. And we're actually going to be able to get some of this paint timing that we desperately wanted and start to really move that conversation. And I don't think, you look at the 7-year gap can be a little bit like, whew, but if I feel like you've needed those necessary steps in between. Like we needed the momentum that came from the experimentation from Speed Index to get to this point, to where that interest was there and we started to find ways around some of the issues. Not even a full year, 6 months later maybe, Speed Curve put out Last Painted Hero, which is what Mark referred to during his talk, where it recorded the hero text, hero background image, the last one to be painted onto the screen. That comes out in its tool, so now we've got another tool really starting to push and promote a hardcore rendering metric. And then not long after that, we saw largest contentful paint get the intent to ship in Chrome in 2019. And then, of course, this morning, we got it in Firefox, so that's freaking cool, huh? I'm really pumped about this. As an aside, I've had some concerns that like performance is kind of on the edge of a performance monoculture. Our conversations are dominated by one browser. It's not through a fault of their own. They're actually doing great work. But we do end up talking a lot about metrics that are supported by one browser, exploring it in tooling that is run by one browser, thresholds that are set by that one browser. And so it's really, really important that we get that cross-browser focus wherever and whenever we can. So having metrics like this available in other browsers is a big, big deal. Because without them, I worry that we can stagnate a bit. I like this. This is better than the tree falls in the wood and nobody. This is a happy little dinosaur. My kids are obsessed with this game. It's so sad. It's fun. But I do wonder, like, I do worry that, like, sometimes if the metrics are absent in these other browsers, do we risk, like, just ignoring or falling behind or not adopting things that we should? And I do believe, I have a suspicion, and I could be wrong. This is suspicion. Tim could just be dumb. But I do believe that in part, one of the reasons why we tend to see Safari lag sometimes on adopting some of the newer performance standards is because we also see them lag a little bit on some of the newer performance modern metrics. And in all honesty, why ship standards that impact metrics that you can't measure in tools and that your tools don't show, like, and support? So I do suspect that plays at least a little role in there, even if it's not a super hyper obvious one. And similarly, as a developer, it's really hard to put effort into using something that we can't show the impact of. Tammy mentioned that every developer should be able to show the impact of the work that they've done. Couldn't agree more. And metrics with clear targets, particularly if we do the kind of filtering and splicing and dicing that Tim was mentioning in his talk earlier, that's one of the best ways to do that. And if they don't show up, it's sometimes hard to get those things out the door. I remember when I worked at a company, we had a product that would inject resource hints. It could inject pre-connects when those first came out. And we talked to one of the customers, and we were trying to get them on board with the pre-connects because we could see, like in web page tests and stuff, the impact that it made. And we could not, they had zero interest in putting it out. And the reason why was because at the time, does anybody remember like the industry benchmarks, like from Keynote and Gomez and stuff like that? Yeah. So there was like, they'd put out these things, you'd be like the top 10 retailers or whatever, all that jazz. It turned out this company, their success at the time was based on whether, like how well they did in these benchmarks. Keynote and Gomez ran browsers that were several versions old, and so they didn't support a lot of these modern standards. So injecting a pre-connect literally did nothing for them by the metrics that they were using for success. It's a good cautionary warning, I guess, in the importance of picking good tools as well. But I do think it's a massive, massive win that LCP is now, we now have our first cross-browser supported, at least in 2 browsers, Core Web Vital. So kudos to the Firefox team for jumping on that. Yeah, we can whistle, that's good. That's whistle-worthy, I feel like. So yeah, so you can see there were many different stops along the way, a bunch of iterations on experiments, on tooling, on things that were very non-standard, just somebody rolling up their sleeves and trying something out. Honestly, we could be filling in these gaps a lot more. Somewhere in 2016, 2017, and 2018, element timing went through 3 different iterations where there was first an attempt to spec it, and then in 2017, they were like, well, the images are too hard, we're just going to focus on text. And then they kind of cracked the nut and came back in 2018 and re-expanded it now into a new one. So it ended up turning into the element timing API that Mark mentioned that I also think I would love to see everywhere, not just Chromium, please. And then somewhere in there, too, is when hero rendering times from SpeedCurve, before Last Painted Hero, the hero rendering times came out, and that was based on one of the earlier versions, too, of element timing. So you can see the tooling and the metrics in that went hand in hand and played together. And of course, so the progress wasn't fast. It wasn't, I don't think, linear. But we've seen a flurry of innovation that's come out since then, right? Like we saw a couple of talks already in the last 2 days that really focused on LCP a lot, talked a lot about the different optimizations available to us. Pat mentioned, Robin, the reason why you all have to sign safety waivers for next year. Mentioned fetch priority and how that is a cheat code for LCP in particular. Absolutely is. You don't usually get a performance win that's just a single attribute like that. I know eBay put this out in November of last year and talked about how they saw an LCP improvement of 150 milliseconds in RUM data instantly. And now 150 milliseconds is nothing to sneeze at. I think it was, I don't remember who was mentioning, it's not always, Tammy was mentioning, it's not always those 500 millisecond wins. We're looking for 100 milliseconds at a time. So that's a pretty big deal for, it's not even a one-line change, it's a, attribute change. Lazy loading, like having native lazy loading available in the browser is incredible. Just the sheer amounts of JavaScript that you can hear falling off of sites when they ship something like this is incredible. It's like taking away megabytes of JavaScript that we don't need anymore. And it's also kind of interesting, by the way, just as an aside, both of these are also standards that were in a long time in the making. Priority hints actually had another variation that almost shipped or may have shipped and then got pulled back. I don't remember exactly what happened, but that was pretty close at one point. Lazy loading was another one of those conversations that we've been having for like 10 years. And again, I actually think, though, that in retrospect, I question whether or not something like this would have had as much impact had it shipped before those metrics were around to show the evidence of actually getting them out. So it's one of those things that in the moment can feel frustrating, but sometimes in retrospect, you're like, you know what, I don't know if that would have landed, because what would we have looked at to prove its efficiency? So I'm pretty excited. I think we're at a really exciting point in the performance industry. I think we've seen a flurry of innovation around new metrics in the past few years, new tooling to support that. I feel like the attribution and stuff that Nishu was talking about has been a huge step forward. And I think all of this is going to really start to give us a better picture of what's going on. And we're going to get a flurry of new standards and innovations that are coming soon, I think. I think we're on the cusp of a important but potentially painful impact on how we build for the web. And I think a lot of the stuff that I'm most excited about has to do with the main thread and the other things that we're doing to devices. I feel a little bad about this next one. I had this before FID got beat up a little bit the last couple days, but it is a fibber. Like it has lulled us into a false sense of security in terms of what we're doing on the web and on main thread. We'll get into that in a minute. But if you look at first input delay right now on the web, it's as of September 23, it's 94% of mobile origins have good FID based on the 100 millisecond threshold. Interaction in XPaint, which has been talked about a few times now, that's 65% of mobile origins. It's a much more, it's a harsh awakening a little bit, particularly since I think first input delay was so easy, I guess, to hit. We'll touch on that in a little. But I'm really, really optimistic and really encouraged about the migration to INP. I think INP has a chance to like really start to force us to assess how we build for the web and what we do with the main thread in JavaScript. And it's just a much more accurate representation of reality. So this is the Allbirds site. I'm using Chrome to take a profile, just opening the menu. And this is a really common, by the way, issue. I don't know, pull up any e-com shop, expand the product menu like that on a mobile device, and this issue is going to hit maybe 60, 70% of them. It happens. So this is the resulting trace here. So there's a couple things I wanted to zero in on. First, I do have the Web Vitals extension running because it's a super handy thing for just evaluating core Web Vitals as you're playing around. And you can see it spitting out the different metrics. And it's giving me very, very different scores here. First input delay looks amazing. 11 milliseconds is blazing fast. INP is like 544 milliseconds. I don't think I even throttled this, by the way. This is just, I think this is unthrottled. 544 milliseconds for the interaction to next paint metric. Such a big disparity. And it's because of the way that they report. So if we zoom in on this actually in the main thread and see what's going on, this chunk here, we've got a chunk over here which you might see under the interactions, it's starting to say pointer and it gets truncated. And then we've got this pointer chunk over here. So it actually fires two, when you open it, there's actually two related pointer events. They both have work associated with them. The total time, technically, between when I tap and when the work is done and completed is actually about a 711 milliseconds. First input delay only cares about the first input and the delay until the browser can start processing in the JavaScript related to it. So that's this little sliver there. That's what first input delay is telling us out of the 711 milliseconds. Interaction in XPaint will take the larger of the two events in this case, the longest interaction, and give me the metric for that. So that's where our 545 milliseconds comes through. Now you can see already that this is much, much nicer, right? Like if you're going to optimize this, where should you be focusing? It should be on this, right? And first input delay gives you no indication of what's going on. INP at least lets us start diving in. I think there's a case, I think it would be interesting to see like the whole composite score at some point. But I'm not mad about it. I think like 545 milliseconds compared to 11, it's already starting to shine the light where we should be focusing on improving this. So I'm really excited about that. I think Nishu gave us a bunch of reasons to be really excited and optimistic about INP and its potential impact on the web yesterday. You know, she mentioned the new APIs like scheduler.yield is input pending. You know, we had a talk about that, a few of us. Like, I think it'll be interesting to see when, like, we get to a lot of real-world case studies, how hard is it to isolate and find the things that you should be putting in those, like, to break up those tasks. I think is going to get super interesting. Sometimes, you know, things that sound great early on, and then we start to put them, like, battle test them on the web, we find we got to iterate on them, and that's okay. That's all part of the process. She also mentioned the better attribution that comes with Loaf. And I love the focus on attribution from recent metrics in the past few years. Like, that is a game changer. Like, just as an aside, like, attribution can transform real user monitoring into a full-on diagnostic tool. Real user monitoring in the past has always been, to me, much, much more useful as I need to check the state of affairs and see how we're doing in this situation or that situation, and it's super important. But if you want to troubleshoot what the heck's going on, whew, you run out of steam really quick. Right? Attribution now makes it possible for RUM to be a full-on diagnostic tool, and I am so pumped for when we see more RUM providers start to jump on that attribution train and really push that forward. So yeah, FIT is a little bit of a fibber, but I do find myself in an odd situation where I feel like I need to defend it for just 2 seconds. I think a lot of the frustration we feel towards FIT and some of these other modern metrics is honestly less about the metric itself and more about the fallout of trying to use a metric for every site on the web with a threshold that applies to every site on the web. What I mean by that is, like, first input delay itself isn't bad when we look at what it's measuring. If we know that it's measuring just that input delay, great. That is actually sometimes a really important and useful thing for us to know. When we have an input delay there, we'd like to be able to zero in and fix it. It's just probably not a metric that's worthy of every site focusing on. And so I think that that's more of the fallout than the frustration that sometimes comes with this. But I would like to say that I do believe, and this might be slightly controversial because I know people have very different takes on this sometimes, I think imperfect data is much, much, much better than no data. If you promise to, there's the caveat, you got to think critically, you got to explore the gaps, whatever. But like, I would much, much rather have an imperfect metric than no metric at all. If we were to turn off every light in this venue, don't do that. If we were to turn off every light in this venue, and then if we said, okay, all of you need to make your way outside and find your way outside, right? Now, we give you a choice. The only tool available to you is a flashlight that's running on like one dying battery, and it can only give you a little bit of light. You'd all take it, right? Because that's better than running around in the pitch black. Like, it gives you at least a little bit of visibility. You can't see everything that's going on, but at least you have some awareness of what's taking place. And I feel like that's where even imperfect data and even imperfect metrics can be a really good starting point. And to me, it makes it much, much easier to see the gaps. Like, it's much easier to see the gap when I have an imperfect data or data point or an imperfect metric in place than to anticipate where that gap might be when I'm trying to get the perfect one, right? And so I think we got to keep that in mind with some of this. And it can also still have the positive impact. I mean, first input delay started off really well. I think there's a very strong case that 100 milliseconds was always far too generous. But we have seen it trend up over time, so it has led to improvements, which is nice. And it's not just individual developers. We've actually seen the metrics and tooling can have the implications on a macro level as well. There's this nice little jump here that happened in 2021 in the number of origins that have a good first input delay. And what this comes from is actually a browser improvement. Stoyan is somewhere in here, Stoyan Stefanov. Hi. He ran into this actually. There's a double tap to zoom feature, right, on mobile devices. You tap, you zoom in. For Chrome to be able to make sure that something is a proper double tap versus some other click, they actually have to have a delay. They have to have, they say 300 milliseconds. In Stoyan's metrics, he was seeing something closer to 200, 250. But the delay is still there. It waits to see if that second click is coming, that second tap, so it knows to zoom in or fire it as a traditional event. They had already removed it in certain cases, but doing more experimentation, they discovered that they could actually be a little bit more aggressive about removing double tap to zoom. In this case, when they have minimum scale or maximum scale, something that was sort of implicitly specifying, that with device width or initial scale 1.0 or greater than equal to 1.0. So they did this, they turned off double tap to zoom, and the entire web benefits. We get like a good 3 to 4% jump on that first input delay. The biggest jump we'd seen or have seen the entire time. I mean, not too surprising, the fastest way to improve the web is to improve the platform itself. And we've seen plenty of that, by the way. There's ample evidence of this. In February, Google talked about the good INP increasing by 4% because they made an improvement to the Chrome scheduler. More recently, they started with the fetch priority. They started trying to increase image priority from low to medium for the first 5 images on a page. We're seeing wins coming to the browser. Baz talked about this with Firefox. We saw quite a bit of evidence of Firefox improving over the course of the year, some dramatic improvements. And he kind of called that out. This is like the advantages of benchmarks and metrics is that they have the opportunity to improve the entire web platform. So it's really exciting to see and hear examples of exactly that thing happening, and happening in many different browsers, not just one. So I'm kind of excited about the INP switch. The other jump that I hope is coming is around memory usage. They say an elephant never forgets. It turns out a JavaScript-heavy page never forgets either. Memory is like a big black box right now. I think a few people dance around the topic. It comes up occasionally, usually in a side conversation. But that's kind of where it sits. I tried, when I was at Web Page Test, we ran a bunch of benchmarks to see like how much memory usage our site's using. And what we found was like, it jumped up in the 90th percentile. They were using like 30 megs of memory usage. And this is just for JavaScript-related memory. This is not like the whole everything else that goes into images and stuff like that. I don't know what I was expecting. 30 to 40 megs feels heavy. I don't know if that's bad, though. Like, we're missing context, like, to some extent, right? Like, we're missing what are the upper bounds, like how much of the memory pool is actually available. It's hard to get good data around the constraints here. Also, the metrics for this are kind of lacking. This is based on a real user metric that was available, but to have it available and running because of, again, privacy and security issues, you have to have certain things that you're opted into. And last I checked Chrome usage, the things that you're opted into to be able to allow you to use this, it's less than like 5% of the web. It's a minuscule amount. So it's like we are at a tough situation to grab anything to help us correlate this to business metrics, user behavior, or to even understand like how much of a capacity are we actually using when it comes to this stuff. What I can say definitively is that memory leaks are everywhere. So first I want to show you a good one. So this is Sonos. How do you pronounce that one, the speakers? Sonos? Okay. So this is their site. This is actually a site on Next, but it is an MPA, as the kids are calling it these days. And so if you open up Chrome DevTools and say show performance monitor, I can never remember where to go, so I'm a Command-Shift-P, bring up the palette kind of guy. And bring up the performance monitor. You can track and watch the JavaScript heap size and a whole bunch of other stuff as you're kind of navigating through. So I went to a product listing page, started clicking on products, going back, just kind of like you would normally do that if you were shopping the site. And you'll see that we've got actually a pretty decent pattern here. The JavaScript heap size is going up, it's coming down. It's going up, it's coming back down. It stays at a pretty healthy number, close to where it started off. The browser is able to effectively clear things out when it's not needed. We're not retaining a bunch of memory. This is a good thing. This is a healthy little model here. For an unhealthy model, and I'll just tell you my approach for this was I went to Vercel and I just looked at their customers and popped up any site that was an SPA. Don't sue me, Vercel. But this is it turns out that pretty much every one of them has this problem. I'm sorry, this is the heap snapshot for that first one, just to show you. I also, you can take a heap snapshot in Chrome, which actually gives you the details of what is there. And you can see that even as I was going back and forth, we went from 33 to 35 to 37. It's all pretty close. There's not much change here in memory usage. This is Under Armour, which is a React-based SPA. Notice in this case, we do have a little bit, the heap size is going up. It is coming down a bit, but you'll notice that it's coming down higher than where it used to be, right? And as we continue to do this, we continue to do that same pattern, view some products, go back. It just continues to slowly climb like that with a few cleanses along the way, but the trajectory is up. If we take the heap snapshot to get a little bit more precise on what's going on, we went from 40 megs to 80 megs to 130 megs. Now, I was not doing anything crazy here. I was just looking at 2, 3 products, take a heap snapshot, take 2, 3 products, and then go back and take another heap snapshot. And I was tripling the memory usage. Now, if you look at what's here inside the other, where it's actually breaking everything down, you'll see a bunch of these detached things, right? Like detached internal node, detached SVG element, all of this stuff. Detached means that the browser wasn't able to clear this away. Somewhere there is a reference to this still in the code. Now it could be often it's with JavaScript you had an event listener that you didn't remove or something like that. But for whatever reason the browser can't quite get rid of this during garbage collection, and so it just kind of hangs around and it keeps building up and accumulating. Now, not to pick on just React, I'm an equal opportunity harasser. This is LinkedIn. Somebody actually pointed out to me that LinkedIn had an issue, so I fired that up. This is an Ember-based app. They don't ever come down. The trajectory just keeps going. It doesn't ever, you just keep doing this. I was on my profile page and just clicking through an activity and going backwards. Again, I think a normal user behavior, and balloon this to 450 megabytes in 4 clicks. There's a lot going on there. And again, just because I know Chrome has a little bit of the rep around memory sometimes, I don't know if it's a super justified or fair, but just to point it out, you can get at these tools in other browsers, and you see the same pattern. In Safari, if you're looking at the memory profile, it continues to go up. And if you look at Firefox, they actually have a tree map visualization, which I kind of I think. I don't know, I will say that this is the thing with memory tooling, is I think getting from hey, we've spotted that there's an issue, to figuring out what the issue is still challenging. You can get from the heap, for example, the constructors, you can get to the lines of code eventually, but you really have to parse the tree to figure out what the heck you're looking at and find the right line of code to get there. It's non-trivial, which is, I think, part of the reason, too, why we don't necessarily see a lot of innovation or work happening around memory optimization today. I'd say if we were looking at experimentation tooling metrics leading to new innovations and standards, when it comes to memory usage, we're really desperately still on this experimentation stage. The tooling is not where it needs to be. It's not usable enough. The metrics don't really exist for the most part. and therefore we're not really going to see much in the way of new innovations and standards. I find it kind of interesting because it's a little bit of a chicken and the egg problem sometimes, right? Like, we need the demand to push for the features and the tools and for the new metrics, but the demand doesn't come unless people roll up their sleeves and start experimenting and trying to find a reason for it to be a problem in the first place. So we have a lot to learn here yet, but I'm optimistic we'll get there. And one thing that we do know is that it is tied to a lot of JavaScript usage, and that's particularly prevalent in the SPA area. I had a sad little laugh when this slide came up from Ryan, because it's a very common reality. And the truth is, the painful, uncomfortable truth is that single-page apps were never built to be performant. That was not the intent. I'm not naming names because I've said stuff, I've done all sorts of dumb stuff. I'm not throwing anybody under the bus here. What I will say is that there was somebody involved in the early forms of React who then gave a talk in 2015 and talking about the origins of React. And what they said, the exact quote talking about it, was that people started playing around with this internally and everyone had the same reaction. They're like, okay, I have no idea how this is going to be important or performant enough, but it's so fun to work with, right? Everybody's like, this is so cool. I don't really care if it's too slow. Someone's going to make it faster. It is a bad recipe for performance success. I just want to state that. That's not how you do that. That was never the goal with SPAs. It was always kind of from day one fighting an uphill battle there. But, there's a lot of developer ergonomics, a lot of different reasons. The adoption has been high. Rum Insights was a killer launch, by the way. Nice announcement on that one. I swapped this in there right away. One of the data points on the Rum Insights stuff that was pushed out earlier is multi-page versus SPA navigation. And you'll see that on mobile, it's about 35% of the navigations that they're reporting are single-page apps. So the adoption is pretty high. It's out there quite a bit, very prevalent. Now, the case for this, from a performance perspective, the argument for why SPAs might not be bad for perf is based on the fact that, okay, the initial boot of an SPA might be a bit slower, but our hope is that any subsequent navigations will be faster. So we will incur an upfront cost, but the hope is that it's amortized over the rest of the page views, and the composite experience is then a bit faster. I have my own beliefs on whether or not that's going to be true, but it's a really hard thing to prove right now, because even these metrics, this isn't like based on some browser thing that is reporting, right? This is Akamai data. So this is Impulse doing its own SPA determinations, which is great. It's great stuff. But like, part of the reason why we have such a struggle with like proving the case of what to do with single-page apps is because we don't have a way of measuring them consistently. There's no concept of a navigation. The browser doesn't know when an SPA navigation occurs because it doesn't look any different from anything else. Yoav and Barry, who are both here, and I encourage you talking to them instead of me, like they're much more interesting. But they wrote up about how they've been experimenting with measuring soft navigations, basically building in a soft navigation heuristic into the browser so that we can actually tell when those navigations occur. Now, this is non-trivial. Like, this is like, there's a lot of work to get that heuristic right. You got to look at like what's changing, how much of that's changing. All sorts of stuff goes into this. I don't get to work on it. I'm not smart enough to deal with that. It's like, it's intense stuff. But this is going to be a game changer, because when this comes out, we can actually start observing those soft navigations in a standardized way. We can start recording those navigations when they occur. We can start breaking down layout shifts in largest contentful paint by when they occur after the soft nav, because right now, you get that LCP and it just kind of keeps kind of going, right? Because it's like the browser doesn't ever see you navigate away. The layout shifts are all accumulated to that first navigation. There's all sorts of issues with not just vitals, just any metric when it comes to an SPA. So having this heuristic land would be huge. Now, I suspect there's going to be some browser progression. I'm putting words into their mouth, but like, I read the article. The article talks a little bit about like, it gives examples of how you can reset LCP. I fully expect that at some point, if we can get more confident in that heuristic, that the browser is going to start to do that for you. You're not going to have to be like, okay, I'm going to reset LCP. The browser will actually do some of that. In fact, that was implied in some of the early standards conversations. I suspect that's coming as well. But this is going to be a monumental shift. Like, decades of debate about this is going to, well, I'm maybe naively optimistic, but hopefully be solved by a little bit more visibility in what's going on. So I'm excited because this wave of tooling, this wave of metrics is bringing visibility to issues that I think are all over the place, but we haven't quite gotten enough visibility to give them the attention that they deserve, or we haven't quite agreed how to solve them yet. But of course, the tooling and the metrics, and that's so very important, but like they don't happen in a vacuum. It all starts really with that curiosity. Curiosity is the spark. We've talked a bunch in all of these examples about the different experimentation that was necessary to, like the LCP examples are all over the place, but anything that we've done, you've heard this a few times now, how much that experimentation, how much the community plays a role in pushing these things forward. And so that brings me back to what is the single most important catalyst in the web performance industry, and that is you. That is us. That is the performance community. The future of performance has always been set and defined by community and by the community efforts. It's one of the great things about this little subsection of the industry. Community interest and experimentation is what led to innovations like new metrics, the new standards that we got out of that. The community feedback and innovation is what continues to push the refinement and adoption of modern metrics like INP with the potential to completely change the way we build for the web. It's why we're looking at the prospect of SPA navigation heuristics to potentially solve something that we've been debating for over a decade, bringing data to a debate that's long been lacking it. I loved this quote from her Q&A, from Katana's Q&A yesterday. They asked about React stuff, and she was like, if there's a better way to do it, we'll find out over the years, and we just keep getting better at it. Now, I'm a performance nut. I wouldn't mind saying that we'll find out over the minutes, but that's not reality. Like, progress is slow, progress is iterative. But I think this sums it up really, really nicely. I hope everyone here realizes the powerful role that they play in making this happen. If you work on browsers or you work on standards, hats off to you. That is such a thankless job, but what a massive impact. If you work on tooling, I hope you recognize the power you have to push the web forward. And I would hopefully encourage all of you and challenge you to not think so much about, to think past today's problems and think about how you could solve tomorrow's as well, because you can push that stuff forward in an incredible rate. And for everybody else who's here who doesn't do standards, doesn't do tooling, they just care about perf, they're working on it, I hope you realize that the importance and the influence that you have over this. I know Pat mentioned the origin trials and wanting feedback. Yoav gave a talk yesterday about wanting people to participate in performance standards groups and how to get involved in that. It's been a recurring theme. Nothing happens without the community pushing it forward. We can cultivate that curiosity and that spirit of experimentation, and that's how we make the web better. Thank you.
Thank you so much, Tim, for closing us out with a bang. That was really inspirational. We're at the end of the day. It's the end of the party. Well, not really the end of the party. Well, I guess that's the after party. But I want to say a lot of thanks, and I want y'all to help me give a lot of thanks out. First up, I want to give thanks to our speakers, all of our amazing speakers. I also, again, want to thank you, the audience, for being here. You're the reason why we did this and why we're here, and making you involved in all of this is how we push that web forward. So give yourselves a round of applause. I also want to make sure that we thank our venue, the catering and support staff around here. Give them a big hand. That food is pretty tasty. And finally, I want to thank these guys, the organizers and all the supporters, for actually making this happen. Didn't they do an excellent job? And I did forget a step. Finally, final draft version 2 is we also want to thank all of our sponsors for giving us the money to make this happen. And I'll hand it over to PPK.
Please stay here.
Oh, okay. Awesome.
Did you like the conference? To close off, I'd like to ask a few people to join me on stage. All the speakers who are still here, please come on stage. Phil, please come on stage. Krijn, where are you? Please come on stage. I think the photographer is going to make a nice photo of us. Yeah? No swords on stage, that's good. Okay. Spread out. Yeah. No. Yeah.
I think he's still talking. I'm not sure.
Okay, before this goes on for too long, because it's fun to be here, but it's bloody boring to watch. Sia already said most of the thank yous. I would like to add a thank you for our MCs, Phil and Sia. I guess you're tired. I'm tired as well, so I'll keep it very brief. First of all, we're going to come back in 2024, 14th and 15th of November here. So make a note in your agenda. If you're not already, please subscribe to our mailing list so that you actually know that the conference is going to take place and so on. We will send you about 3 to 4 mails per year. I'm going to advance this slide, but I'm going to show it later on again so you can get it. It's time for some drinks. Thanks to Sentry. Sentry is sponsoring the Friday night drinks, and we're going to have fun. We're going to have maybe a little bit of alcohol. I'm not sure about you, but I would like 1 beer. Please leave all the cups and glasses upstairs. Please also do not take drinks outside, and that is not allowed. And remember the Pac-Man rule, keep some space open for somebody else. Thank you. See you next year.